All right, let's have a look at the last minute revision for the AI. It's really the very last minute, isn't it? So, right now we're just checking what type of skill set you need and also the confidence that I want you to have during the test. Okay. So without further ado, let's get started. So, there are many topics, as you can see, categorized with each section from the AI guidebook, right? So all those skills require certain awareness of the question types, and that's what I want you to do. So, when we go over the questions together, what I want you to do is, oh, I know how to do this, right? So do not rely on my method, but, just pause the video, while you're solving the question and make sure you answer them first, right? And what I want you to do is this, when you revise with this video, just look at the question and says, hold on a sec, do I know how to solve it? Oh yes, I know the examiner or the teacher is trying to be cute because this is checking that skill set exactly. So that awareness is what I want you to have first, to not rely on the problem solving from the video, but attempt by yourself. So let's get to it. So yes, if I was in your shoes, if I was the students, if I was being a student, then I would say, oh, hold on a sec, yeah, the examiner is being cute because what I had to do here was to try to express in the scientific notation. So 2/5 times, yes, if it's a division, we subtract the exponent, so it's gonna be 10 to the power of a minus b. That is a great answer. But if I'm trying to describe in decimal, that's gonna be 0.4, right? But I can't use that because I need to describe things all in integer. So that is great. So instead of putting 0.4, let's do 4 times 10 to the power of negative 1 times the base of 10 for the next one. So it's going to be described as 4 times 8, 10 to the power of a minus b minus 1 is what we have. Okay, so then you can find the a and b in terms of d is what we need to do. Okay. All right, so the second section of the AI syllabus is something to do with the arithmetic sequence. So what I want you to realize is that arithmetic is always a linear progression. So when you see a question like this, you need to think, oh, okay, I know what to do. I know that the for the linear progression, the gradient is going to be considered for the common difference. I know that, right? So it's going to be un minus 1 must be constant, and if we do the algebra, then I'm very confident that I can find the gradient very quickly because it's going to be the common difference. So that's great. So then, and also part D, what we're trying to do is find the solution for the sequence, right? So let's say I'm trying to find 71 minus 7n over 2. I want this to be less than negative 200. So we need to solve an equation, and yes, you can use n solver if you want. And but for this such a linear case, I'd prefer doing this by hand. So if I do 71 minus 7n is less than negative 400. But while you're getting the n, you can actually equate that and then later on discuss whether you're gonna round up or round down. So for this one, we have a 7n is equal to 471. So if we quickly use our calculator, why not? So let's do 471 divided by 7. So if I do that, I roughly get n is approximately 67.3. So that is great. However, for the sequence and series is a discrete data, so you need to make sure that you write in integer. So I'm gonna let n to be 68 is what we have. Okay. So always trying to round up, because if you didn't round up in this time, 67, it's still bigger than negative 200. So you still have to subtract by 7 over 2. Again, to move into the value that is less than negative 200. So always make sure you're trying to write down the integer value for the sequence and series. And yes, many types of simultaneous equation for the sequence and series. So for this one, what we have here is that the third term, so I'm gonna write u3 is being u1 plus 2d is equal to 10. And the 15th, so u15 is gonna be u1 plus 14d. So we shouldn't hesitate every time solving the sequence or series problem. That we are very confident being able to solve them because we know how to express them explicitly, right? So make sure you're able to come up with the formula. And also, yes, I want to demonstrate how we can demonstrate the sequence on the calculator, right? So make sure we are able to go to the graph, right? And then press menu on your calculator, on your Nspire calculator, go to graph entry, and then press sequence. So for that, you can either put the explicit form or recursive form, right? So it's very important that you're aware of those methods because it's also used for the differential equation with the Euler's method. So for this one, what I would do is, let's try 1 minus, 2 over n squared. Why not? All right, for that, you don't need the initial term because it's explicit form, right? But also, I want you to realize that you're able to describe in the the recursive form. If you define, for example, let's say, if I just use keyboard, so my present term is n, so I can do u2 of n minus 1 plus d, right? So as you can see, this is a recursive form of an arithmetic sequence. It's possible to demonstrate on the calculator, but in this time, you got to put the initial term. So if I put the initial term as a 1, it's going to start with 1, and it's going to demonstrate a sequence that goes by the common difference of 2. So if I press enter, then there you go. It starts at 1, and the next term goes by adding extra 2 as a common difference. So make sure you're able to demonstrate the recursive as well as the explicit using the calculator. So that is great. So for number 5, whenever you see a question like this, what I want you to be aware is that, oh yeah, examiner is being again the cute because, he or she is asking about the formula, right? And, for the arithmetic series formula, there are 2 kinds, right? So n over 2, a1 plus an is one kind, and then another one is n over 2, 2a1 plus n minus 1d. And obviously, I think depends on, it depends on the question which one is better. And for this one, obviously, I think the first one is better because you already have the first and last term. So only thing that you have to figure out is the last term, number of terms. So for this one, I'm gonna let this to be the general term of the sequence, such as the common difference is a 6, so it's gonna be 6n plus 5. So then you realize, n must be 60. So then it's gonna be s60 or is equal to 60 over 2, and then the first term and last term, voila. So it's going to be 11 plus 365 is what we have. It's not that bad, right? So we can figure that out already using the calculator. But for this one, as soon as you see the series, be able to come up with the formula is what I mean. And also, whenever you have 3 consecutive terms, it's time to use arithmetic mean or geometric mean later, right? So for this one, yes, as you can see, if I have a 3 consecutive term, I would automatically write arithmetic mean definition here. So for this one, yes, if you are taking an exam and solve this problem, then you will do, twice of the middle term has to be sum of the first and the last term is what you're going to do. Okay, so that is great. So that's how you work with this arithmetic mean, geometric mean thing. So geometric mean we're going to discuss later, but yeah, so this is going to be arithmetic mean, then geometric mean is, sure, b squared is equal to ac, right? So be able to use them interchangeably, all right? So that's very important. So let's have a look at the question number 7. So if I'm given series, be able to bring out the sequence, right? So, Sn represents the sum. So it's going to be a1 plus a2 going all the way up to, an minus 1 plus an. That is great. So Sn minus 1 is going to go from a1 all the way up to an minus 1. So if you want to isolate the an, make sure you subtract, right? So that is great. So we have Sn minus 1 is equal to an is what we have. Okay, so, and then, so I don't want you to neglect, right, the importance of the algebra when you do the AI, right? It's very important that you are able to perform the algebra by hands. So this is very important. So for my an, what I'm going to do is, I got the n squared plus 4n minus, n minus 1 squared plus 4. N minus 1 is what we have, right? So that is great. So it's going to be n squared minus n minus 1 squared plus 4n minus 4. N minus 1 is what we have. And then, obviously you can do the expansion, but I don't want to because I can factorize it by using the difference of a square. So that's going to be n plus n minus 1. And then, n minus 1. Right, so then if you expand that out, it's going to be plus 4. So then voila, that simply just becomes 2n minus 1 and plus 4. So that will just become 2n plus 3 is what it is, right? So that's my sequence I claim. And if you want to compare your answer, verify, just check with the first term, will you? Because the S1 is going to be the same as the first term of the sequence. So if I put S1, that's just a 5, as well as the U1 being 5 as well. So I'm very happy with this result. And make sure if you're given quadratic term, quadratic expression for a sequence without the constant term, that is an arithmetic series. We should be able to see that right away, okay? And also, sure, simple interest, that's the final sequence version of the arithmetic sequence. So make sure you know the formula, right? So as soon as you see fixed interest or simple interest, the formula goes by the following. So it's going to be the AN, the nth term of the simple interest is going to be given as a A naught plus N times the interest rate times the initial value. So your common difference is going to be determined by the interest rate applied to your first term. Okay, it does not go geometrically like the compound interest. Okay, then you can plug the n equal to 1 or 10 in this formula. So make sure that you are able to perform those equations by using the formula. Okay. Oh, sure. So this is a very special kind of arithmetic sequence for the AI. Sure. As you can see, you know, it's going down, right? So whatever the deficit is going down. Okay, so that's great. But then you realize that it may not be perfectly arithmetic. However, what you need to do is you're approximating the arithmetic by finding the average of the common difference. So what you want to do here is to find the common difference by taking the average of each difference. So, so difference here, if you just work on your head, 0.33 negative, sorry, that will be negative 0.38, that will be negative 0.36, etc., right? So it goes all the way up to, for that one will be negative 0.37. So there are 9 categories of them. So you subtract all that divided by 9 will give you the average of negative 0.36. So even though the difference is not constant, so it's not changing that much, we're assuming that it's common difference. So then you can come up with the arithmetic sequence of negative 0.36 and plus whatever the constant value that you need to put to, figure out the constant value to find the explicit form, and then use it for 2025. Okay, so make sure, even though it's not perfectly constant, we can still use the approximation. Okay, so for that you need to find the average of the difference. Okay, that's what it means by the approximation with the arithmetic sequence. Sure, it's a very lovely problem here. Why is it lovely? Because I want to always remind you that the algebra matters. At the end of the day, you have to solve things a lot by hands, okay? Especially for not only the topic 1, but also topic 3, topic 5, right? The calculus. So for this one, yes, if you want to show geometric, that means you need to find the common ratio. So 4 root 2 over 8. Root 2 over 2 is my common ratio, right? So, and then for the general formula, you are already aware that it's going to be un is equal to u1 times square root of 2 over 2 to the power of n minus 1. I get it. All right. So the first term is 8 times the expression, but then it's expecting you to be able to work with the exponent, right? So 8 is a 2, 3, and then square root of 2 over 2 is just 2 to the power negative half, right? That is great, to the power of n minus 1, and we should do the algebra, right? So by the product rule here, so it's going to be 2 to the power 3 times, if you do the distribute, 2 to the power negative half n plus half is what we have. Then we're going to add them together for the exponent. So 2 to the power negative 1 over 2n plus 3 plus half is 7 over 2 is what you need to show, right? So make sure we are able to do the algebra quickly. Do not rely on the calculator too much, because from what we have observed so far in the last 2 or 3 exams is that the distinguishing point of getting 7 and getting 6 is that you have to do the algebra by yourself. Do not rely too much on the calculator. All right. And yes, there will be a lot of context problems. For that, you need to know whether it's progressing or it's deteriorating. So for this one, depreciation, that you are going to be willing to, choose the common ratio to be 0.88, right? That will be your common ratio. So spends 15,000 buying computer. It's a very kick-ass computer. So 15,000 times 0.88, because it's depreciation by 12%, so my common ratio is going to be actually 0.88 is what we know. Okay, and then to the power of n is what we're gonna do. So here's the thing, this is debatable whether you want to do the n minus 1 or n, but the thing is, if you want the effect to be immediate after plugging the 1, that means after 1 year progress, then it must depreciate it, then you put it into the power of n. So for the theoretical questions, it's often to do with the -1, you're right. But for the real life example where you want the effect to be done at first year, you need to put into the power of n is what you need to be aware, okay? So it's a context problem. So, when you look at this question, what would you do? Oh yeah, examiner is being trying to cute because he or she is asking about the the simultaneous equation problem. You can give it to them, right? You can give it to them. That's great. So here the third term right away, I'm gonna write a1 r squared is equal to 8. That is a great. And then the sixth term is going to be a6 is a1 times r to the power 5 is equal to 27, right? 27. Then you need to solve it simultaneously. For this one, yes, the division is going to be better. So r cubed is equal to 27 over 8. Then you know what? I don't want you to put this on a calculator. If you can solve this by hands, quickly do that because it takes time to put the numbers manually. Obviously, there's going to be many categories that you must use calculator, not this. So r is going to be 3 over 2 is what it is, right? So then you can figure out the a and you can find the 10th term, etc., etc. But make sure when you see a problem like this, you instantly notice, oh, okay, this is a simultaneous equation problem, right? So that's the eye that you need to have. And same thing for the series, right? So geometric sum of the first 3 terms, so we have S6 to be 305, so 304. So I'm gonna write it as an expression. So it's gonna be first term times r to the power of, 3 minus 1 over r minus 1 is equal to 304. And then first 6 term is the sum of the first 6 is gonna be, oops, sorry, haha. Yeah, you're right, so should have written 3 here. As 6 is going to be a1 r to the power of 6 minus 1 over r minus 1. That's 1330. So that is a great. And then you need to solve it simultaneous again by just putting into the division here. Then you can isolate for just the r, for which you can use a calculator for that, okay? So make sure you're able to see the problem like this. Okay, 2 numbers, 2 expressions needed, so we can solve it, okay? Be confident. And also, yes, it's very important that we know how to use calculator for such sigma notation here. So, and also make sure if you got a linear expression inside of a sequence, that's going to be arithmetic, right? So arithmetic is always something to do with the linear. But if you got the exponent, that's going to be the geometric, okay? But I got something to mention about these sigma notations. If I have let's say I is equal to 1 to 5 and 3 times 5 to the power of 3 minus 2i, so I know this is gonna be geometric because it's got an exponent, but my question is what's gonna be the common ratio? You're right, common ratio is something always of a constant that will give the power to be just simply n or I depending on the index. So here I don't want you to choose the common ratio to be 5 because if you chose 5, I don't have something of a neat I got negative 2i. I don't want that. So common ratio here has to be then 5 to the power of negative 2i can be re-expressed as a 1 over 25 to the power of I, and that is going to be my common ratio. So you need to be able to spot the common ratio from the sigma, please. Okay? So that is great. So yes, and also where can I see the sigma notation? Just go to this bookmarks, will you? So every time you want to use the fancy notation such as the integral, differentiation, whatever, just go here, absolute value, anything is in that category. So you can find the sigma, choose your own index, then you can solve it. Okay, so that is great. All right. So and also yes, what I want you to see is that it goes up, increase. Then you need to choose your common ratio. Well, right. So I'm gonna put 7.7 billion. So unit of this sequence is gonna be billions. So okay, and then I'm gonna put 1 plus 1.72 over 100 to the power of n, right? So that's gonna be my common ratio. So make sure you're able to translate the context, especially for sequence and series, and this time it's going up. So I'm gonna do 1 plus 1.72 over 100 to make it into the common ratio of the sequence. So that is a great question. Okay, so very, very important, isn't it? Because something to do with the it is something to do with the compound, right? So if it's something to do with the compound, make sure you always talk about the scheme. It says monthly. So for the monthly, what we need to do is to split the interest by 12, isn't it? So I got the initial value of a 5,000. And then what we want to do is to write down the geometric sequence for that. So I'm going to do 1 plus 3 over 100. That is great. However, what you need to do is to, because it's a monthly, I need to split the annual interest by 12. So I'm going to do 1 over 12 by splitting that up to the power of the 12n. If n was given yearly. However, in this question, I'm given the progression is a month already, so I can just put 18. So, I want you to remember, if it's annual, sure, it is going to be initial value 1 plus r of 100 to the power of n. That's great. But if it's a quarterly, what do we do? Right, if it's a quarterly, that's going to be a naught 1 plus r of 100 times quarter to the power of 4n. And then we just wrote down the monthly already, so make sure you are able to use them interchangeably. And yeah, you know what? You can use the financial solver, of course. But for that, I prefer using the financial solver just for the, annuity or amortization, not for the compound, because it's just simpler. It's just quicker. It is just quicker for us to do the, it's quicker for us to use the expression by hand, okay? So that's great. So yes, what we have is the increased spending on the education 5%. That's great. So whatever the initial value, what we can do here is that we can come up with the common ratio. Okay, let's have a look at the next question. It's talking about the inflation. So every time you see in the question something with the, inflation, it's always about the indexed interest. So you got to be careful. So whatever the initial spending there was, it says that it's going to go up by 5%. So we are very confident to write as a 1 plus 5 of 100 to the power of n. But then you know that there's a real value of it, right? So for that, you need to consider with the inflation. So for the inflation, it's given as what? 1 plus 2.5 of 100 to the power of n. So your interest has to be indexed, right? So find what is the real term increase per year. So what you need to do here is that, okay, then I'm going to, divide that by the inflation. So that's going to be indexed. So then you can figure out the value. So if I just quickly use the calculator for that, 1.05 divided by 1.025. So then if you subtract by 1, then roughly speaking, that's a 2.44. That is going to be roughly 2.44 interest. So that's the interest rate increasing by the inflation rate with the indexed. Okay, so make sure you are able to get the real interest by considering the indexed, the inflation rate. So that is great. And then the next category, 1.5, talks about the laws of exponent logarithms. And yes, I really want to encourage you to make sure you can do the algebra quickly. So right, for the Z, if we just quickly, practice our algebra. So for this problem, yes, it's asking whether you can do the, the approximation way or not. So for this one, I'm dividing. So for that one, it's going to be subtracting on the top. So it's going to be a to the power of m to the power of m. That is great. So for the second one, it's going to be a to the power of negative m to the power of m minus n. That is great. So now I have a to the power of m squared times a to the power of negative m squared plus mn is what we have. And then yes, by the property of exponent, we can add them together. So it's going to be canceled out. So it's going to be a to the power of mn. So make sure you're able to simplify quickly, right? Do not rely too much on the calculator. And for this one, sure, I got the when you see the negative exponent, what you're urged to do is that you want to put it into the fraction form, right? However, what I want you to notice is that on the numerator, I see the difference of a square, right? So it's going to be p minus 1 plus q minus 1, p minus 1 minus q minus 1 is what we have. And I got p minus 1 minus q minus 1. So as you can see, I can just cancel that out very quickly. So it's going to be 1 over p plus 1 over q. So that is very lovely. Okay, so make sure, we are able to simplify, right? It's very, very important, especially for AI, if you're aiming for the 7, right? So because at the end of the day, it's the time factor, right? So you need to, you know, increase the efficiency. And that can only be done by more manual work than relying too much on the calculator. Obviously, for probability or some differential equation, you must use calculator. We're gonna have a look at that, okay? But yes, you know, also what I want to remind you is the simplification, right? So a to the power log, for example, AB is gonna be simply B, and also log a of a to the power of b is also going to be simply b. So we are using the inverse function relation between the exponent and log. So for part A, you know, how can you simplify that? That's going to be, you know, 10 to the power of log x cubic. You know, it doesn't have any base. That means it's automatically base 10, right? So then using this property, it's going to be just x cubic. For part B, it's e to the power of ln. You know, you're finding the difference between the log, then you're dividing the inside. That is a great. So it will be simply just x over y. That's it. For D, you know, it's just going to be e to the power of ln. You know, what is it? X to the power of -2. So then voila, I have 1 over x squared. So make sure you are able to simplify quickly. And also, yes, sometimes it asks you to find the exact value, right? It's not always 100% through significant problems, so make sure you're able to use solve the exponential equation using the log. So for this one, if I look at just the third one here, e to the power of x minus 1 is equal to 5 over 3. Then e to the power of x is equal to 8 over 3. Therefore, x will be ln of 8 over 3. So make sure you're able to convert the exponent into the log, vice versa, very quickly. Okay, so we must be aware of this. Okay, but it's pretty straightforward, so I'm going to move on. So 1.6 was talking about finding the bounds, all right? So make sure whenever you see the multiplication or division, sum or difference, you know how to find the upper bound, lower bound, all right? It's very important because sometimes it can be confusing, especially if it contains division or the subtraction. So it says nearest whole number, so then, you know, the b is going to be bounded by, 7.5 and 8.5. 5 is going to be bounded by 4.5 and then 5.5. And then, C is, okay. And then these 1.5 and 2.5 is what I've got. That is great. But then I now want to find the upper bound, for example. If I want to find the upper bound of a b over c minus d, so I want my fraction to be the largest is what I'm saying. So for that one, it's going to be, yes, I want to find the upper bound of b. I want the numerator to be the biggest. However, for the fraction to be the bigger, I want the least denominator, all right? I want the least denominator. So for this given value, what I like to do is, yes, I would do, you know, lower bound of c minus the upper bound of the d, so that the difference is the least, right? The distance between those numbers are going to be the smallest, giving you the largest possible fraction. So for that one, it's going to be 8.5 over a 4.5 minus 2.5 is what you have. So if you put that in the calculator, you're going to get 4.25. So that's your upper bound. And lower bound, similarly, you know, I want my fraction to be the least, isn't it? So for that, I want to find the least value of everything opposite here, really, isn't it? So 7.5 over 5.5 minus 1.5. I want you to notice now I'm dividing by a number that is the largest, isn't it? So that the fraction is going to be least because it's got the largest possible denominator. So if you put that in the calculator, you get 1.875, right? So then a is going to be bounded by 1.875. And then 4.25 is what you're looking at. So make sure you are able to find the lower bound, upper bound, all right, using the logic. So this one is pretty straightforward because it's talking about the surface area. So, you know, if I call it as A, B, C, make sure, you know, you find each bounds with the 1 decimal places. So it's going to be A, B, C, isn't it? So for this one, there is no trick, right? So it's going to be bounded by the product of the upper bound of A, upper bound of B, upper bound of C. So it's actually not that bad. Okay, so I'm going to move on. So yes, you know, the percentage error is very important. I don't care whether it went up or down, you know. I'm just looking at the percentage error. So for that, I use the absolute value, right? And then what's the formula? It's going to be approximated value minus the true value over the true value, right? And I don't care whether it went up or down if I'm looking at just the percentage errors. That's why you're putting the absolute value, okay? The true value is a pi. So what you want to do is 22 over 7 minus pi over pi. You know, I don't know whether it's going to be positive or negative unless I put it in the calculator, but just put an absolute value and then put 100% is going to give you the percentage error. So make sure you know you're always dividing by the true value, okay? All right, so let's have a look at the next one. It says, so pause the video, read the question, do it on your own time. It's very important that you always try by yourself first. Average speed, so average value is just rise over run. It's just speed is defined to be what? The total distance divided by total time, right? So distance over time. So it's using the definition problem for the part A. So it's gonna be 87 over 4 over 3, right? So if you put that in the calculator, you get 65.25. However, you know, the problem like this that involves the unit, you shouldn't forget to write down the unit. It says kilometer per hour is what we're going to do. So that is a great. But it says what? Absolute error is asking for the absolute error. That's not percentage error. So absolute error is just absolute value of whatever the velocity we have. We're going to have a look at the velocity of the true. So approximation. So for that one, you know, what we had the estimate was a 70, sorry. So 70. And then the true was the one that we have computed. It was a 65.25. So the error, absolute error is going to be 4.75 kilometer per hour. So for that, what we want to do is the percentage error. And for that, you know, what we're going to do is to divide that by the true, right? By the true. So in this time, the true was a 65.25. So I'm going to divide that. And then it's going to give you the percentage error by multiplying 100%. Okay, so that's roughly 7.28%. So make sure you know how to find those values using the true value as well as the approximated value. Okay, so that is a great. So let's move on. The Carolina completed 250 kilometer car trip, rounded to the nearest. Okay, so that's important. GPS in her car displays average speed of blah, blah, blah. Rounded to the 1 decimal. Okay, estimate the time it took Carolina to complete the trip. Okay, so time taken. So it's the triangular relation, isn't it? It is the triangular relation. So I got the distance, speed, time. So for the time, I need to do, you know, distance over speed. Okay, so in roughly speaking, it's 250 over 56.8. So if you put that in the calculator, but we've got to make sure that we're trying to describe into you know, whatever the unit you want. But obviously, I think it's better to do it the hours, so 4.40 hours. But then, you know, because since the time, I want to convert that into minutes, so make sure that you multiply 60 on it, right, for the 0.4 hours. So 4 hour and 24 minute will be a good answer. Okay, and it says a maximum possible percentage error. So it's asking for the maximum possible percentage error. Okay, so what you want to do is that the length of the trip first, right? So length of trip, and it says nearest to the kilometers, so it's gonna be bounded by who? 249.5 to 50.9 is the upper bound for the length, and then the speed is going to be bounded by who? Sure, it's going to be bounded because it got rounded to the 1 decimal place. You got to go to the 2 decimal places for that then, right? So it's going to be 56.75, 56.85 for the lower and upper bound. That is great. And now I want to talk about the time taken, right? So time is going to be the length over speed, the distance over speed. So now I want to find the lower bound and upper bound for that. Okay, and for the lower bound, you know, you want the fraction to be the lowest, so numerator has to be the lowest, denominator has to be the largest, right? So that the fraction is going to be the least. So I'm going to have lowest on the top and then the largest on the bottom, right? So you need to be always able to find that. And then whereas if I want to find the upper bound, the numerator has to be the largest and then the denominator has to be the least. So that is great. So you can figure that out by finding the lower bound and upper bound. Okay, so that is great. So if we put that on the calculator, it's going to be bounded by 4.39 and then 4.41. That is great. And now if you want to figure out the percentage error, you need to then compare these two with the actual hour, right? So then it's going to be, you know, percentage error of each. I'm going to compare with the 4.40. So let's do that. So if I got the, for example, 4.41 minus by, subtract by 4.40, divided by who? 4.41, but I put an absolute value just to look at the size of it. Okay, so that's number one with the upper bound. And number two, with the lower bound, it's going to be 4.39. Okay, and subtract by who? 4.40 divided by 4.39 is what we have. So you got to put that on the calculator. So if we try to compute, then you get 0.289, you get 0.287. So, you know, now we see, yes, at the upper bound, it's going to give you the maximum, the percentage error. So make sure we're able to, you know, compute it with each bound and see which one is going to be giving you the percentage error. Okay? So it doesn't mean that the upper bound is going to always give you the maximum error. It really depends, right? In this time, yes, we were happy to see that the upper bound actually gives you the maximum bounds. Okay, sure, amortization, annuity, you need to always be willing to use the calculator, right? So if I use the calculator, especially the solver, you need to make sure you are able to put the numbers in each category, right? So let's read the question carefully, however, because they can always twist the problem. So the one difficult part about the financial sequence series is they can twist the words, and you need to be able to spot what they have been twisting. So that's not easy to spot right away. But if you look at this, he retired at the age of 68 with the $830,000 in saving fund. Okay. Quite a bit of money, right? So, and automatically I know that's gonna be my present value. That's my present value. He rolls the money into an annuity fund that earns 4%, paid annually, compounded monthly. So that is great. So I gave my money to the funds. So I deduct my funds from my balance to someone else. So for me, I will use present value to be negative 830,000. But it doesn't really matter. You could have put that as a positive. That means you would have ended up getting the payment. What is it? Negative. It doesn't matter. It's really the perspective of whether you think on behalf of yourself or behalf of a bank, right? For bank, if someone gave me the money, I earned. But at the end of the day, you're going to give the money away, which then will give the negative sign for the payment. So it doesn't really matter. It doesn't really matter. Anyways, but if I think myself, and then present value, I now gave that money to the fund, so now it became negative. Okay, and then he wants the money to last until he's 85. So from 68 to 85, that's 17 years, right? But you got to be very careful. You got to be very careful for this number of period, because it depends on the payment, right? So it's compounded monthly, so that's lovely. I'm gonna put 12, but also I want to withdraw the money each month. All right, so that I need to put 12 here. But here's the thing, you know, so for that, so the number of period is gonna be 12 multiplied by the 17 years. That's gonna be the number of period. However, here's the big question. So what if I have quarterly interest compound, and then the payment was still monthly? Which period should I follow for the given years of a 17? The answer is always try to follow the payment per year. Okay, so if this was a 12, regardless of whatever the number we have for the compounding, make sure you write down the 12 on behalf of the payment per year. So it's very, very important, because what you're trying to get, my friend, is the payment. So make sure you always try to follow the payment. Okay, so that is great. That is great. So now we realize that I have to multiply by 12 because it's a monthly payment, right? So that's great. The interest rate is always put in annual interest. So I'm going to put 4 here. And then this is the unknown. So what you need to do is to select the PMT after having put all the numbers there, and then press over. So you need to make sure your category, your selection here is on the PMT. The future value, you know, now I've been using all the money, so that it's going to run out. So I will let that to be 0. right? And the payment is at the, so here it says, it doesn't really mention here, does it? But then I'm going to, let's say, assume that it's going to be n. Okay, so then you can figure out the PMT. So roughly speaking, it's going to be given as a 5,614.06. So that's the money that you can withdraw onto 85, right? So make sure you're able to use your calculator well to find those value. And for part B, it says 6,000 per month lifestyle. And then will Henry be able to maintain his current standard of living? Of course not, right? Because the maximum money he can withdraw to last until he's 85 is maximum amount is being put as a 5,600. If it's beyond that, obviously the money is gonna run out much quickly. So make sure that he stays on the lifestyle within 5,600. Okay, so those are the common sort of a problem, for the annuity problem. It's very likely that they're gonna ask you together with comment this, comment that, right? So it's very important for us to realize that. So let's have a look at the next questions. Is a loan, so it's very likely that it's gonna be repayment, right? Sure, and then the loans are, so obviously we're gonna use the financial solver as well. And it's very important that it's, for the financial solver, I want you to think of it as a linear equation, right? What I mean by that is just a one unknown, really, right? It's just one unknown. So you can think of it as a linear equation. Every category has to be filled up except for one category, so that's fine. So let's try to plug it in. So I borrowed, you see? So I got the money from the bank. So my balance is going to be positive. You see the difference? So in the funds, I gave my money to the fund, so I subtracted it. But now I got the money from the bank, so in my balance, it's positive. So present value is going to be positive 15,000. Okay, that's great. And then I got the 5% interest. So interest rate is annual interest, so that's great. So I'm going to put 5 here. And then the compound monthly, so it's going to be 12. All right. Then what is it? So payment here is that the monthly repayment. So I'm paying back, you see. So I'm spending that money. So payment should be negative 300. So that's great. Okay. And then payment was monthly payment, that will be 12. So now I'm doing this in the span of what? Sure. For 5 years. For 2 years first. Right? Let's do 2 years first. So now I'm doing for 5 years, but 2 years this and 3 years in that, right? So what I want to know is what balance I'm going to have. For that balance, I'm going to use another scheme and see what will happen. All right. So for this one, I'm not going to put 60 because I'm only doing this for 2 years. So this needs to be 2 times 12. Then you can get the future value. And then do you think the future value will be positive or negative? Good. It should be negative. Right? So because you still got to give that money back. So it's going to be given as a negative 9,018.34 if you use correctly on the calculator. And now, you see, now I am doing for 3 years with different schemes. So for the remaining 3 years, it's going to be, what is it? 6.5, right? Interest rate went up, right? So for that, the rest was the same, right? 12. Right? And then the future value, I want to pay back everything, so it's going to be 0. And then now present value in the bank, it's going to be 9,018.34. That's the remaining balance. But now I'm doing this for 3 years for monthly repayment, and the interest rate actually went up. So, at the end of the day, within these 3 years, you're going to actually end up paying more, right? And then you put it on the calculator, then the PMT, the payment, is going to be negative 270.29. Okay? Sure. So then it's what you can do. Okay. So make sure you are able to know what category you're looking for. And the financial sequence series is just really like a linear equation. It's really like a linear equation. Okay. Let me take a pause and come back for the next question. Okay, let's have a look at the next question. So working with the simultaneous equation. So every time you realize, I gotta use my initial conditions to find this unknown parameter which is in linear form, you can press the following. On the nth spire, you can press menu. 3, 2, go for the linear simultaneous solver, right? So then if you plug it in, for example, if I put 1, I'm sure I'm going to get a plus b plus c is equal to 1.7, right? And then the other one, you know, if you put 4, you get 16a, 4b plus 2c is equal to 7.2, and you can put the 9, 81a, 9b, 3c is equal to 23.7. And then if you press menu 3.2, menu 3.1 is N solver, menu 3.2 is the simultaneous solver, then you can find the A, B, C, right, using the calculator. So if you did, you should be able to find it. So I will leave that as an exercise. Okay, so same thing for the next one here, really. As you can see, I got the, 3 initial conditions. You can plug it in, then you can come up with the 3 linear equations. You can use the menu 3.1. So please do not hesitate to do so, you know. But for a harder problem is that it's not so obvious what equation we should use. You know, for previously we were given functions and we just have to use those coordinates. But for this one, we have to derive it, right? So let's derive the equation first. It says a sum of a digit of a 3-digit number. So let's say ABC is equal to 16. So a plus b plus c is equal to 16. That's given, right? And then I need 2 more, right? So to solve it simultaneously, I need to have 3 equations for 3 unknown. So then the third digit is twice the difference between the first and the second digit. So for that, what we can do here is, all right, so the third digit c is going to be the same as, what is it? The difference between the first and second. But I'm going to multiply it twice because it's twice the difference. So that's the second one, right? Which is given in linear form. So I'm very happy with it. And it says when the 3 digits are reversed, so let's say CBA, the number decreased by 297. So that means the number decreased by 297. So for the larger value, ABC, if I put that as a multiple of 10, that's going to be 100A, 10b plus c minus now 100c, 10b plus a, that dropped by 297 is what the question says, right? So as you can see, these problems are the more difficult one because they don't give you the linear equation right away. So you have to think a bit, right? And then, you know, you can solve it simultaneously. Then you get a being 7, b being 5, c being 4. So the 3-digit number is going to be 754. So, you know, I want you to try yourself with your calculator also. And for the next one, so sure, you know, if it's nonlinear, things like the quadratic, or, you know, I've also seen questions, the questions from school, like the, you know, x squared, y cubic, you know, z4, x1, y half, you know, z cubic root, and then, you know, x cubic, y 4 and z1. Let's say these were given 2, 3, 4, things like that. Sometimes, yes, you need some algebra by hands, and for this one, I think it's very obvious that you can get rid of the x squared each, and then trying to reduce into the just one equation in terms of 2 variables, right? So this, you know, a question asks you to solve this by hands. So for example, if I try to, you know, get rid of the x variable by subtracting the second equation with the first one, then you get the you know, y squared plus 2z squared is equal to, what is it, 41. And then if I do, for example, you know, third one minus the first one, then you will get the negative 2y squared is equal to negative 16. Voila, I'm very happy to have the y value already so that we can find the z value. Then you can find the rest, the x. So x here is a plus minus 1, y is equal to plus minus 3, z is equal to plus minus 4. So those are the value that you can have. And for nonlinear case like this, you can actually linearize if it's a power form by taking the log on both sides. So if you take the ln on both sides, then, you know, you get to have, you know, sorry, so, you know, I think for this one, sorry about that, I think the base should be the constant, and then the power must be the unknown, sorry. So things like the 9x, 3y, 4z, 1 over 2x, things like that. Then you can put the log here, which you will then be able to linearize by using the property of log. So it's going to be x times ln 9 plus y times ln 3 plus z times ln 4 is equal to ln 2. So as you can see, this is a linear equation because the unknown is in the power of 1. So even though seemingly it doesn't look like a linear simultaneous equation, you should know how to linearize that, taking the log on the power function, or sometimes, yes, you need to do by hands, and do not be afraid of doing it. And same thing here, sure, as soon as I see that, I would just press menu 3, 2, and then use the simultaneous solver on the Inspire calculator. So please practice yourself. So I'm going to skip over that one because it's very similar to what we have done before. But yes, the 33 is also the hard ones, right? Because it goes with the unknown parameter m. And here it says find the values of m such that it's consistent. So consistent means no solution, right? So let's have a look. So for that, you need to have row reduction. So for this one, what you can do is that you can put it into the matrix form, right? So I'm going to have -3, 2, 3, 1, 4, -1, -5, -5, and 1, 1, -2, and -3. And then what I want to do is that you can use any coefficient you want. I will use the coefficient of y because it's in the multiple of 1, so it's easier for me to work with, isn't it? So if I operate the row reduction here, let's duplicate. And then, if I use the third row to get rid of all the coefficient on the other parts, such as a 1, 1, -2, and -3, 2, 2, -4, 2, and -6. So if you get rid of the component of the other parts, it's going to be 5, 0, -7, and then m -8, right? So if you add them, so if you subtract, it's going to be -5, 0, 7, and then 7 minus 2m is what we have. And I can use the second row, right? This time, just simply add on the first row to simplify further. So if I did, if you just add the second row onto the first one, then you get 0, 0, 0. And then the rest is going to be -1 minus m. So m must be -1 for the infinite solution. But if m wasn't -1, then we have no solution, right? So make sure that we know how to distinguish. Because this is going to indicate the intersection between three planes for which you don't need to know. But that's how we can also give the nature of the solution, because it doesn't have to be always unique, right, for the three unknown variables. So please make sure you remember that. So section 1.9 on the syllabus is talking about the laws of the logarithms for the HL students, right? And for that, sure, we know many of the logarithmic laws, and among them we have a change of base, right? So make sure log AB is the same as log CB over log CA, or also, if you let the C to be B, then I have 1 over log AC. So you can interchange the base and then the number, right? That's great. So if I have that, the right hand side will be the same as 4 over log XY. That's lovely. So that I can rearrange to the other side, so it becomes perfect square. And do not confuse yourself. This is a perfect square of the logarithm. You cannot take him in the front, right? So make sure we avoid making those mistakes. And then if I take the square root on both of them, it's going to be plus minus 2. Please make sure logarithms can be negative. So then if I use if I exponentiate with the base of 2, then you get the y is equal to x to the power plus minus 2, which becomes then, x squared or 1 over x, right? But make sure, because we use the x and y as a base, not only are they positive, but also they cannot be 1, right? Because we don't allow the base to be 1. So make sure that for the base, it cannot be 1 for the logarithms, right? So those will be also the condition that we have to specify, not only writing down the expression. Yeah, and then the other things, you're really just simplification, for this one will be same as e to the power of ln x4, then it's going to be just x power 4. You know what you're talking about. For this one, it's going to be simplified. So please make sure you know how to simplify with the logarithms, because it's a very, very popular to ask. There are many questions involving with the simplification with algebra, previous exams. So please know how to do that, right? The splitting, like the simplification, log 36, log 6 squared, 2 log 6, and then it's going to be 2 over 6 can be factorized by 2 and 3, so it's going to be log 2 plus log 3, where we know 2 and 3 will be represented by a and b, so 2a plus b is what we have, right? For that one, it's going to be log 2 cubic, 3 squared, it's going to be then 3 log 2 minus 2 log 3, so we have, 3a minus 2b is what we have, right? So that's how you can simplify. So index law, we talked about it before. I'm going to move over because it's not that big of a deal. But section 1.11 for the AI syllabus is super important because it talks about the infinite geometric series. So not only should you remember the infinite series, but also, yes, make sure you know the condition for the convergence. The common ratio must be bounded by positive 1 and negative 1. So another way to write down this inequality is that the common ratio is between negative 1 and 1, right? Make sure you know this. So that's great. So my common ratio here is going to be u2 over u1, which is 1 over 4 a squared minus 3a over a, so that I got 1 over 4a minus 3. Then I know for the condition for the convergence is going to be bounded by absolute value of less than 1. So in that case, if I open up the inequality, it is going to be bigger than negative 1, smaller than positive 1, right? So that's what we have. And what you can do is simply add by 3 on each side. So it's going to be 2, quarter, and then 4. And if you multiply by 4, that it's going to be 8a 16. So make sure within this bounds my series will converge. You need to always specify your condition for the convergence, especially for the geometric series. So that's lovely. That's great. And then find the value of n when up to m it becomes a 76. Sure, why not? So we have the first term being a, so that is a great. And then the SM, where we will use the geometric series formula, which is a u1 1 minus r to the power of m over 1 minus r, right? So that's gonna be a, and then 1 minus common ratio, which is a 1 over 4 a minus 3 to the power of m over the 1 minus 1 over 4a minus 3 is equal to 76, right? And then, as soon as we have the series formula, we are going to just simply use the expression. And I think this is a segment of a problem. In that problem, they also give you another equation in terms of m so that you can solve simultaneously. So in this part, it does not contain that. So you don't have to worry even if it does not tell you right away. Okay, so don't worry about that. All I care is that you are able to come up with the formula once you see the series. Okay, or I think I meant to put the infinity there. Yeah, I think that would make more sense, isn't it? So sure, the first term over 1 minus the common ratio, is a 76, so that you can solve the a, right? So now I'm very happy to solve it because it's simply using the linear the equation in terms of one variable. So that's great. And so sure, infinite series, you're going to see many problems with the area, length, possibly so area, length, yes, those things. The fractals is going to be very popular. If you can, please visualize, right? So Zoe learns that because the energy loss by friction, the basketball is dropped to the ground, it would bounce 75% of original height. This is just so popular diagram, isn't it, for the infinite series? So you should really know how to visualize this quickly and make sure that for the vertical height it's gonna be multiplied by 2, right? So this dropped by the initial height 2 and it goes up and down, right? So what we then know is the initial height is the 2, and then the next, after the first bounds, it's going to be 2 times 0.75. The next one is going to be 2 times 0.75 squared, right? And then if you want to find this for the infinite times, right, then if you want to just get the length of the vertical heights, then it's going to be 2 plus, twice of the first term, because make sure it went up and down, right? So it's going to be double after the first term, isn't it? So then we simply keep adding all this, right? So then make sure you perform the infinite geometric series within this bracket, not the other one, because it's not in the same sequence as the others, because it gets double for the previous one. Okay, so then I will use the infinite series here. So 2 times 0.75 over 1 minus 0.75 for that yellow highlighted part. Then you can use calculator to get all those values. So what I'm trying to say here is, yes, you're going to see a lot of real life application problems for the infinite series. If you can, please visualize. And most of the time, I think they will give you the graph and try to use it. Another popular one is, like the fractal with the shape like this, and I believe they can either ask you about the area or the length, but if I was going like that, half of the length only, I think it will give you the geometric series in each odd term. So that one, and that one, and then you have to also group by this even term, and then the even term. So those get the geometric series. For this type of problem, you have to do the infinite series twice, because you want to get the A1, A3, A5, and then A2, A4, A6. So they perform the geometric series, and you get the infinite series of each of them and combine them together. It's also a very typical problem with this infinite series in real life situation. That's great. So yes, this is also indicating that we will use the geometric series, and what the reason I've written here is that you are able to spot the common ratio, right? The first term is, in this case, when the index is 1, because that's the least value in here. So the 3 over 4, 1 minus, and make sure your common ratio is here, not 3 over 4, but only the 1 over 4, because that's the one that has been put into the power of the index k, simple k. So I'm going to put just 1 over 4 here. And here, yes, I'm going to do the same thing with the common ratio, and this time negative 2 over 5. I mentioned it before, but if I have, for example, 3 times 4 to the power of 3 minus 4x, sorry, 4 to the 4k, when the k is, for example, the index of a sigma. And here, make sure that you're able to spot the common ratio. It's going to be 1 over 4 to the power of 4. Make sure base does not guarantee that it's a common ratio. Try to put into something to the power of k or n or I, depending on the index of a sigma, and be able to get the common ratio. Okay? Yeah. The modeling here, let's have a look. So, one of those worthy problems is, if you can visualize, is the best, right? Teacher has taken his daughter to the playground while she was on the swing. He noticed that the amplitude of each successive swing was significantly less than the previous one. He had to give her a push every now and then. Going back at home, he decided to analyze. Okay, so yeah, like for the AI, really, one of the tips that I want to give you is that keep it short, right? So there are many, it's going to be always about the applied, right? It's going to be application and interpretation, right? So it's going to have a lot of a backup story, but for this type of problem, you realize, it's actually talking about it. I'm sure it's going to talk about the geometric sequence, and for that you need to know what your common ratio is going to be. So my common ratio here, after all reading this passage, I'm confident that I can keep it short by finding out the key word such as the common ratio. So here it's going to be 0.89. That's going to be my common ratio. And another information that we are given here is that the first term, right? It says the first term is the first oscillation was given to be 1, right? So then, you can solve most of the problem, right? So then, if you want to have, for example, third oscillation, that's going to be, 1 times 0.89 cubic in this time, right? So then you can put in your calculator to find it. And for part B, after how many oscillations, he will need to push the swing again, right? So what you want to do is to solve the exponential equation. So you're letting 1 times 0.89 to the power of k minus 1 is to be 0.5. And for this one, because it's nth order, I would use, because it's a one-to-one equation, I would use nth order. So if you did, k to be approximately 6.9. But as you see, this is a sequence, and you need to always write down the integer value. And most of times, it's always a rounding up. It's going to be rounding up. So, what we're going to say, oh, yes, it just became 0.5. If it had been 6th attempt, it would have been slightly bigger than 0.5. I want it to be less than 0.5 so that the father needs to push. So then we know that it's going to be 7. So please round up the value for the discrete case is what you're doing. All right, so I want to specify this type of wordy problems. Yes, it's going to take some time to read all this passage, but really, you got to keep it short. As soon as you see, it's a swing, very likely the geometric. Where is my common ratio? They have given me the common ratio. They have given me the first term, and I'm very able to solve sequence of series and all that jazz. Okay, so make sure you are able to spot the data. So 1.12 for the topic 1 is something with the complex numbers. So make sure you're able to work with the Cartesian form, polar form, and Euler form. And for the Cartesian form, yes, complex equality can be one. So for this one, so we're gonna, for complex equality, if the complex values are equal, the real part as well as the imaginary part must be the same. So here, if I expand it, it's going to be a squared minus b squared plus 2abi. Distinguishing the real part and imaginary part is equal to negative 16 minus 30i. That is great. So the first equation you're going to have is the a squared minus b squared is equal to negative 16. The imaginary part here is going to be 2ab is equal to negative 30. Then you can solve it simultaneously, obviously. And yes, it requires a bit of algebra, isn't it? Because, for this one, yes, you can sub it in and use the function, right? Because it will be eventually so non-linear function, so I don't want you to use nth order because you may have more than one solution. But if you can solve by hands, please do so. So solving manually is required in AI as well. Do not rely on the calculator 100%, right? So if I quickly just rearrange, then it's going to be b is equal to negative 15 over a. Then if I sub it in, it's going to be a squared at minus 225 over a squared is equal to negative 16. That's great. So 8 to the power 4 plus 16a squared minus 225 is equal to 0. And a squared, yes, let's do some algebra, mental algebra. So what is it? 9. Is 9 okay? Nope. What else? Oh, it is okay. Haha, sorry. 925, right? So then negative, positive, but the imaginary part, the real part, they have to be real number. So I will let a to be plus minus 3. So you can find the b as well, right? So please be able to compute this manually. Do not rely too much on the calculator. Obviously, there will be some parts you have to use calculator, but not those, right? And also, yes, we should know how to convert things in a Cartesian and polar form. Without using calculator, sure, you know what, you can use calculator, you're right. So if we quickly go to the nth bar and then go to the calculator, so make sure you put in the document setting, being able to put the complex number. But if you're interested in the polar form, that's what I would do. So then I can put, for example, negative 1 plus I, right? So it's going to give me the modulus and argument. But here's the thing. You also need to practice getting the exact argument, exact magnitude, because for some special angles, they are going to ask you to find the exact angle. So when the question asks you to find expression or exact, there's no way then other than doing this by hands. For this one, sure, the modulus is going to be, 2 cis. And please make sure, for the a complex number, it's very important that you are able to demonstrate on the Argand diagram. So it's both are negative, so it's in the third quadrant, right? So tangent theta is 1 over 3. I'm not going to say theta is a power of 6 because that's not in the third quadrant, so you got to use a reference angle. So what we're going to do here is that, yes, we're going to rotate by negative pi, add by pi over 6 to put it into the third quadrant. So my argument is going to be negative 5 pi over 6 is what we have in the complex number. So make sure you're able to get these using the by hands, okay? So for that one, it's going to be 7, 1 minus root 3i, that's lovely. And it's going to be 7 times, what is it? 2 modulus cis. What's going to be the argument? Real imaginary part in the fourth quadrant. What's going to be the argument? Pi over 3, fourth quadrant, negative pi over 3. So make sure you're able to compute this by hands because it really checks your trigonometric understanding as well. You can surely put on the calculator, but it does not do the justice for the exact value. So for the exact value, it is important that you're able to compute these using by hands, using your trigonometric understanding. Yeah, you can use, so sometimes, they might ask you use without calculator. So for that, we need to grind, right? So it's going to be 10. For cis, the real part is going to be the cosine, the imaginary part is going to be the sine. So we have a cosine negative 2 pi over 3 plus I sine negative 2 pi over 3 is what we have, right? So for the cosine negative 2 pi over 3, which quadrant is it? It's in the third quadrant. Everyone is going to be negative. So 10, negative half, negative I, root 3 over 2 is what you got to do. So make sure that you're able to convert between forms. That's important. And also, yes, product. Why is it asking? Because they want to test you two things. Make sure cis theta times cis phi is what? The product. So you're adding the argument. That is great. And then also make sure cis theta to the power of n is cis and theta, right? So those two things you must memorize. I think that one of the recent exam questions had this very, very nice problem which uses this complex identity. So make sure you know how to, right? So for example, if I do, z1 times z2 for the part A, it's going to, modulus is going to be just multiplied. So 8 cis, however, for the argument, it's going to be added together. So that's a pi. And cis pi is -1, so -8 is going to be the answer. So make sure you know two things. Of course, you can ask quotient, right? Then we can divide, right? But whenever you multiply or divide, polar form is the best kind. And then you can expand it later for the Cartesian form. So if I used, for example, part B, if I do z1 over z2, that's going to be 4 cis. And yes, you know what we're going to do. We're going to subtract the argument because it's a division. So it's going to be 2 pi over 3. That's lovely. But I want to write in Cartesian form, expand by the cosine and sine. So it's going to be 4 cosine 2 pi over 3 plus I sine 2 pi over 3 is what we have. So that's lovely. So it's going to be 4 times cosine 2 pi over 3. It's going to be, what is it, in the second quadrant. So it's going to be negative. So negative half. But however, sine is a positive in the second quadrant, so I'm going to put root 3 over 2 is what it is. Okay, so then you can expand it. Then you can solve it. Okay? Sure, I think we should put square root on the first one. So here, this is one of the questions that you must be able to do. So here, every time you see something to the power of n, make sure you try to put it into the polar form or Euler form so that you can use the DMT. So z here is going to be 2 cis. It's a 1 over root 3 for the tangent, so it's going to be pi over 6, isn't it? So z to the power of n is going to be 2 to the power of n cis n pi over 6. And then, yes, if you want your imaginary part to be 0, that means the sine must be 0. So sine with the argument of n pi over 6 is a 0. And make sure you know when the sine becomes a 0. So sine becomes a 0 when the inside of a sine is an integer multiple of pi, where I'm going to say k is an integer. Then, pi cancels out. So when n is in the multiple of 6, integer multiple of 6, then I'm going to have the imaginary part being 0. Imaginary part being 0, such as a 0, plus minus 6, plus minus 12, etc., etc. And also, I want to remind you, when does cosine become 0? Cosine becomes 0 if theta is equal to even pi. So odd pi over 2. So k pi plus pi over 2. Make sure you know how to describe when the cosine becomes a 0 and sine becomes a 0. Okay? It's going to come very handy not only for the trigonometry, as you can see, for the complex number as well. Same thing here. If I got the a squared b over c squared, I do not want to use Cartesian form yet. Use it for the polar form, simplify, and then solve it. So for example, if I got the a squared, right, that's going to be, what is it? 2 cis pi over 3, square that. And b is going to be, what is it? Square root of 2 times negative positives is in the second quadrant. So that's going to be cis 3 pi over 4. That's lovely. I don't have to put into the power. But for C, voila, I got the real part, imaginary part. It's in the fourth quadrant. So that's argument is going to be negative pi over 6. That's great. So for his argument, so his modulus is going to be 2 cis negative pi over 6. So we're going to do product and division. However, for the first one, that's going to be 4 and 2 pi over 3. So that's great. Okay, so we can divide. The modulus is going to be 2 to 2. That's great. And then the argument is going to be, what is it? You're right. We're going to add for the product and subtract by the quotient. So then you can simplify the argument, and you can use it for expanding out in the Cartesian form later on with the real part and imaginary part. But here, really, what they're saying here is that you're able to convert things between the Cartesian form and polar form and use their property respectively. Okay, so that's very important. And yes, the sum of complex number is very popular for the last part of a section A or a very lengthy section B problem. We can combine them together. So what they're saying here is that the vertex source B is this, and then what we want to do is we want to combine them, right? So we want to combine the vertex. So if you combine them, we have what is it? 10 cosine 30t plus 15 cosine 30t plus 5. So, if this combining the sum of sines and cosine using complex number is very popular, but you always have to specify their period is the same. You cannot use this method unless the period is the same. So 2 pi over 30, both of them period same, hence you can combine the phase. Okay. So how are we going to do? Well, you do know it is going to be described as the real part of 10 times e to the power of I, and then the argument for the first one is going to be 30t plus 15 e to the power of I, 30t plus 5 is what we have. Okay, and then what do we have? It's going to be the real of 10 times e to the power of sorry, the first one is just fine, right? But what we have to do is to take out the second part. So that's going to be e to the power of I 30t times e to the power of I5 is what we have. And then you factorize. How do you factorize? You're going to factorize with the common factor of e. So e to the power of I 30t is what we have. Then if we combine them together, it's going to be 10 plus 15 e to the power of I5 is what we have. And then I'm going to use calculator to simplify that as a single polar form. You got to use calculator for that. So if you use a calculator for that, what you end up getting here is, okay, so that will become a single complex number. In the Euler form, you get the 20.3 times e to the power of, what is it, negative 0.790 I. So now I can combine them together. That's going to be, what is it, 20.3 for the modulus. And for the argument, if you factorize by I get 30t minus 0.790. Right, that is a great. So that's going to be then 20.3 cosine, because it's the real part of whatever the argument that we had for his domain. Is how you can combine them. So make sure you factorize well. As you can see, this is not entirely 100% calculated problem. It requires you to being able to factorize and use the law of exponent. And then for the leftover, that we use calculator to put it into the single form of a complex number. That has to be done by a calculator. And then you get the real part, which is a cosine. So that's how you get the sum of sine and cosine. So, what I'm saying here is, I don't need to really read all those voltages connected milliseconds. I don't care. What I do care here, my friend, is that it's going to be sum of the sine and cosine, and for that I know that I'm gonna use, what is it, the Euler form, and then use a calculator. So those things is what you need. You gotta keep it short. So it's a very lengthy sunrise and all that. But for me, as soon as I see, those two functions, I know that it's going to be either adding or subtracting, right, of a complex number, and then we try to perform the computation. So for this one, what do you reckon? So it's the length, isn't it? So then I know it's going to be the sunset minus sunrise, right? That's it. It's going to be just simply the duration, right? So what you can do is, again, just use the imaginary part, isn't it? You can use the imaginary part, so that's lovely, whatever that is, right? and then to do the same thing. You're going to be able to perform the same thing and being able to come up with this. So this is very similar to the previous one, but here's the thing. What I really want to encourage you to do is that you always check the period. And because it's got the same coefficient of the t, I'm sure you're going to get the same period. Hence, I can use this formula. Okay? So, whenever it's a lengthy, you don't have to be scared. Please make sure we know how to attack on the certain topics, certain skill set. Okay, so now we're going to move into the matrix algebra, but let me take a 5 minutes break and then come back to you. Okay? Okay, let's have a look at the matrix algebra from the section 1.14 for 1.14. And yes, we need to always be able to interpret what it means by working with certain number or matrix. So for here, what we want to do is to get those unit price of hammer, screw, die, driver, and can of paint on a store A and B, right? So what you can do here is to demonstrate the requirement for the matrix. So what I need to have here is the matrix that will demonstrate the requirement of an activity, right? So what we need here is I need to buy 1, 1, 2. Okay, 1, 1, 2. And then the friend needs to buy 1, 2, 3. So I'm going to put 1, 2, 3. So that's I and that's my friend, right? So, and then if you want to get the total price, right, you can do now you can now get the matrix multiplication, right? So the dimension here is what 3 by 2, and then here the given price matrix is a 2 by 3, so I can perform the matrix multiplication. That's great, right? And then so if I get the matrix for the price, I get the 14, 6, 38, 12, 4, 14, 44. Sorry. Then you can use calculator. So if you simply use calculator, what you end up getting is your dimension here is going to be who? Hold on a sec. Sorry, it asks me to get the PR. My bad. It's asking me to get the PR. So what I'm gonna do here is switch the matrix, and then looking at the dimension again, in between the column and row here is same, so you're gonna get the resultant matrix as the 2 by 2 for the leftover. And if you do the row and column all together, it's gonna be 2 by 2, so you get 96, 140, 104, 152. So that's what you got the matrix here. And it's asking find your cost at store A. So I, friend, store A and B. So my cost at A is gonna be 96, and then your friend's cost at B will be 152. Do any of the elements PR tell you and your friend the cheapest way to buy all your items? No, because it's asking about each item for each store, right? So the cheapest way so you can say at what store it's going to be, right? For what item is what you can determine. Okay, so you always have to interpret those numbers. That's what the AI stands for. You need to know what my numbers or matrix or vector represent in a situation. That's the essence of AI. And it's very asked often on the matrix algebra. So for here, sure, we need to create our matrix here, right? So, the previous one gave you the matrix, but for this one, we have to come up with the matrix, right? So it says, Sonia invested a total of this much amount, right? And then 3 different index funds. Oh, wow. After 1 year, what happens? Combined the value of all investment was this much. The data collected on each of these investments show that each investment made an average of annual gains of this, respectively, during the year. If Sonia invests twice as much the money in here, it says calculate the, what is it? Alright, let's move on to the next problem. Here it says, given those matrix, A squared in the linear form of the following. So, it's a linearization of a matrix for the A. what we can do is just a squared, and you can just perform on the calculator. It's absolutely fine, right? However, what we want to do is to get those values first. So if I put it in the calculator, I get -1, -4, 2, 7, and you're going to compare that by linearization of a P and Q. So what you can do here is that it's going to be, what is it? If you multiply constant multiple P on the matrix, it's going to multiply on every entry. So it's going to be P, 2P, a -P, -3P. That's great. And then if I multiply Q on the identity matrix, it's going to be Q, 0, 0, Q. So that's great. So if I put them all together, you're gonna get the P plus Q, 2P, -P, -3P plus Q is what we have. And I got another matrix like this. So that's great. And then what you realize here is that you can compare those entries all together. So here P is going to be -2, but that Q is going to be 1. So that's lovely, right? That is lovely. So now you know that the A squared is going to be, what is it? -2A plus the identity matrix. So that's great. You can now use it for linearization of A cubic. So it's going to be A times A squared. But we know that this A squared can be linearized by the following. That is lovely. And if I do the distribution, I get the, what is it? -2A squared plus A identity matrix, which is the same as just A, right? And I can use the linearization once again because I already linearized the perfect square, right? Then I do the distribution again, so it's going to be 4A minus 2I identity matrix plus A. And then if you combine them together, that becomes 5 multiple, and the minus 2I is what we have, right? So that's the power of cube. And you can do the same thing for 4, 5, etc. So how would you do A4? Yes, it's going to be A times A cubic. You already know, you're going to use this cubic linearized form. And then while doing the expansion, you're going to get the A squared, where you can use -2A plus I as well, is how we're going to do. Okay. Sure, you're not going to be asked to find the inverse of a 3x3 matrix, but you are going to be asked to find the inverse matrix of a 2x2. So first thing is that you need to check the determinant is non-zero, right? So if I do the determinant here, it's a -4 plus 6 is 2 and 0. I'm very happy. It has the inverse. So for that one, it's going to be, what is it then? 1 over determinant of the matrix. So it's going to be 1 over 2. And then switch the major diagonal, so -4, 1, put a minus sign on the minus, so it's going to be 2, -3 is what we have. And then if you want to double check whether this is my correct inverse or not, what I would suggest is that you multiply with the initial matrix and see yourself that you get an identity matrix, right? You always want to double check, my friend. So boom, I've done that. And if I do the row and column, what do I get? -4 plus 6, that's 2, 8, -8, 0, 0, 2, voila. I do get identity matrix. I'm very happy that this is my inverse matrix. So be able to compute by hands, okay? You can put it in, you know what? Yeah, sure, you can put it into the power of -1 on the calculator, and you can easily find it, no problem, okay? Let's move on to the next one. So it's given this, find the matrix Q. So, the reason they have asked this one is that they wanted to see if you know the order of the matrix multiplication. So to get rid of that, I would put the P here. And then to get rid of this, I'm going to P inverse to the right. So it's going to be the right inverse. So now you just have to put the following matrix multiplication on the calculator, and you should be able to get the Q very easily. But, you need to make sure that the matrix algebra, the multiplication is not commutative unless it's for the identity matrix or the inverse. Okay, so make sure the order matters. Okay, I don't want to put this, I don't want to interchange them. If you multiply the inverse to the right, do that on the right on the other side as well. Okay, so that's just to check that. So yeah, you're going to have a lot of a wordy problem like this, no problem. Because as soon as I see that, I know that I should use the matrix multiplication. So you can now replace that, represent that as the matrix multiplication as the following. It's going to be 2, 1, 3, 3, 2, 1, 502 x, y, z is equal to 135, 21.5, 156. If you want to get the x, y, z, then be my guest. What you can do is to multiply the inverse to the left. So it's going to be the left inverse, all right? To the power of -1 of this column vector will get you the x, y, z. So make sure the order matters, right? And you know what? Yeah, you're right. You can do the menu 3 too and solve it linearly, but then they do ask you to express that in terms of the matrix, and for that you need to follow the direction. You need to always make sure you follow the what the question asks. Okay. So now, whatever the x, y, z, that's gonna be the cost, isn't it? So state clearly what the variable x, y. Oh, sorry, we didn't specify that, right? So it's gonna be the unit price of the football, right? Unit price for who? Football. And then the next one is the baseball, and it's gonna be the basketball. So we just will end up getting the unit price of each sport. So it's gonna be 21, 16.5. 25.5, and you can use these values for whatever the purchase that you have to make 4, 5, right? Then what you can do here is that it's going to be then, what is it, 4 times 21 plus 5 times 16.5. If you put that in the calculator, you get $166.5. And then if you want to calculate the amount left for the basketball, what you can do is from the total, you subtract that whatever the value was, then you get the remaining. And then if you want to talk about the number, you can divide the total value divided by the unit price, isn't it? Then you roughly get how much? You roughly get 11.9. But then remember, if we're talking in integer, we're talking about discrete value, so you cannot round up for almost incomplete parts. So we're going to say 11 basketball is what we need. Okay, so make sure you are able to, represent the data in numbers or matrix, but you got to know what it means. You need to always give the meaning of those variables, those numbers, in whatever the form you're using. That's the essence of what the AI stands for: application and interpretation. Okay, sure, characteristics equation, our favorite. It's going to be used a lot for, Markov chain, for the probability, and then, couple linear differential equations or second order differential equations. So make sure you know how to do it well, right? So determinant of U, sure, 2 minus lambda, 1, 4, 5 minus lambda is equal to 0. Yeah, right? Then you can expand them, and I'm sure more than certain that it's going to be a quadratic equation. So lambda squared minus 7 lambda plus 6 equal to 0. So most of the eigenvalue, eigenvector problem, your characteristics equation is going to be always factorizable to a certain extent. If it's not, use a quadratic formula, no problem. So here lambda is going to be 1 over 6. So that is great. Then you need to find the respective eigenvectors for those problems, right? So what is the definition of eigenvector? A vector that I use for the matrix multiplication will be the same as the scalar product with the vector. So that's very lovely. You don't need to expand all of them because it's going to give you the same equation anyways, because so then I'm going to just only one of the row. So it's going to be 2x plus y is equal to x. That's lovely. Then x is equal to negative y. So I'm going to use negative y, y. So if I get the multiple of y, I get negative 1 and 1. Then voila, I'm going to use negative 1, 1 as for my eigenvector. Okay, make sure you know how to get the eigenvalue and eigenvector. Well, they didn't ask you to find the eigenvector, all right? But I did it anyways because it's important for you to be able to do that too. So please be prompt. Okay, and you know what? Sure. You need to know a certain property of the eigenvalue and eigenvector. If you had the eigenvalue of the lambda for the a, and for the negative a, it's gonna be negative lambda, right? And you can prove it also. If you have an eigenvalue for lambda for the a squared, it's gonna be a squared. That's lovely, right? For the inverse, you're gonna have reciprocal, right? So that is a great to memorize. So it's gonna come very handy. So make sure. And also another one is if it's coming conjugate pair, right? For the radical conjugate or complex conjugate, it's going to always contain the conjugate pair. So make sure you are aware of those certain rules for the eigenvalues. It's unlikely that they're gonna ask you to show this, but knowing this will definitely quicken your computation. Okay. I mean, you can easily prove. I mean, if I quickly show you the part B, you can prove it, right? So by the definition of the eigenvalue, we have a matrix times the eigenvector is equal to eigenvalue to the eigenvector, and that if that is a given, I want to find a squared whatever the eigenvector. I don't know what the eigenvalue now is, but I can multiply by the eigenvector also. But then that the lambda squared a squared can be described as a times a and then eigenvector, for which you can then rewrite this as a times what? The eigenvector, right? So that's great. And then what you realize is that the maybe I wouldn't start with that actually, but maybe I would do the multiply a on both of them. So let's multiply the matrix on the left. Okay, so then I get, what is it? A squared eigenvector. And now that one is the definition of the eigenvector with the matrix. So it becomes lambda times the eigenvalue eigenvector. So then you see that the eigenvalue also becomes a perfect square. So make sure you know this neat formula. And sure, why do we use eigenvalue eigenvector? Most of the cases we want to diagonalize, so that it's going to be easier for you to compute for the very higher power, right? So you don't want computer to multiply the matrix multiplication too many. If you know an algorithm that could quicken the computation, computer likes it. Okay, so if you do the characteristics equation again, 8 minus lambda 2 negative 1 5 minus lambda is equal to 0, you end up getting the characteristic equation of a lambda squared minus 13 lambda plus 42 is equal to 0. So if you factorize, I got the lambda minus 6, lambda minus 7 is equal to 0. Therefore, lambda is going to be 6 or 7. So that is lovely. And for that, you can find the eigenvalue, eigenvector respectively. So I'll help you try. Why not? So 8, 2, negative 1, 5, xy is equal to 6, xy. Let's try with this. So it's going to be 8x plus 2y is equal to 6x. Lovely. So it's going to be 2y is going to be negative 2x. So then we have, what is it? Oh la la, the x is equal to negative y. Then I'm going to plug it in. I got negative y and y. So it's going to be, I'm going to factorize by y, negative 1 and 1. So my eigenvector is going to be negative 1 and 1, right? Remember, your eigenvector is not unique. You can use whatever you want. But obviously, we prefer this most simplified integer value, right? Anything is parallel is fine. So for 7, if you do the similar computation, the eigenvector you're going to end up getting is negative 2 and 1. So if you want to diagonalize, be my guest. So what we're going to have is that the P is going to be who? Made out of the eigenvectors, negative 1, 1, and negative 2, 1, then your diagonal matrix is going to be made out of the eigenvalue on those diagonals. So it's going to be 6, 0, 0, 7. And make sure it follows the order of the eigenvalues and its respective eigenvector. Okay? Sure, if you then, you can now diagonalize your matrix. So your matrix is now going to be, what is it? The P, you can write P inverse first. Doesn't matter, right? And then the, what is it? The inverse of that, right? So that's great. So we did what the question has demanded, and then as requested. And now, if you want to put m to the power of n, no problem. You can just plug it in. What is it? To the power of n in the middle for the diagonal matrix. So it's going to be 6 to the power of n, 7 to the power of n. That's it. Right, so this just helps the calculator to compute faster, right? So that's great. And the reason I brought this is that if you actually put it into the characteristics equation of this, what you're going to end up getting is actually a radical conjugate, right? You're going to get you're not going to get a neat rational integer. You're going to get irrational numbers. So for that one, the lambda is going to be 1 plus minus root 2. But what I want you to remember is this. Let's try to get the eigenvector of, for example, 1 plus root 2. All right? So then I get 3, 1, negative 2, negative 1. And then the 1 plus root 2 is equal to 3, 1, negative 2. Oops, sorry, what am I doing? My bad. xy, and then I multiply that with the eigenvalue. And this time, let's use 1 plus root 2. Okay, that's great. I'm going to just one of the row here, so let's use this one. So I got the 3x plus y is equal to 1 plus root 2x. I get it. Okay, so that's great. And if I combine them together, y is equal to, what is it? Negative 2 plus root 2x. Okay, that's great. So your xy eigenvector is going to be x and negative 2 plus root 2 x. So you can factorize everything by x. That's great. 1, negative 2 plus root 2 is what I have. But here's the thing. You don't have to sweat for the 1 minus root 2 because it's also going to contain the conjugate eigenvector. So again, if you know more rules, it just helps you to compute fast. So if you got, radical conjugate or complex conjugate, your eigenvectors are also going to be in the conjugate pair. So you don't have to worry for the next one, right? So make sure you know this formula, right? That if eigenvalues are a conjugate pair, eigenvectors will be also the conjugate pair as well. Okie dokie. Sure, for example, if you perform the characteristics equation, let's say on the part C, right, what you end up getting is the eigenvalue will be plus minus I root 5. Okay, that's great. And you can get the eigenvector also. So if I use I root 5 for the eigenvector, what you end up getting here is that it's going to be negative half plus root 5 over 2 I 1. And you know what? For the negative I root 5, I don't need to sweat because I know it's going to be also the conjugate pair for the eigenvector. So you can see yourself that you're going to get this. But here's the thing. If you write this right away without computing, would that be wrong? No, not at all. The more the merrier. The more formula you write, it's okay. They're going to be very generous. The examiners are very keen on giving you the highest possible marks within the scope of your answer. So you can use it whatever you want as long as it's correct. So that's great. For this one, sure, it's what we have done, right? So it's going to be diagonalization, right? So you can write the C as a P inverse D. P doesn't matter, the location of this eigenvector matrix is fine. So if you do the characteristic equation, you get the lambda to be 2 or negative 1, and you can find the respective eigenvectors, isn't it? So I'm going to get, what is it, for eigenvalue of 2, it's going to be 1, 1. And then for the negative 1, you end up getting negative 2, 1. So then you can, write this one as a 1, 1, negative 2, 1, right? So then I have those product at the first and the last. And in the middle, it's going to be, what is it? 2, 0, 0, negative 1. I got the inverse there. And then if you want to put into the 2015, quite a large number, you just have to put 2015 on each side of the entry. But make sure you put a bracket for the negative, right? And then you can leave it like that if you want. Also, you can compute, no problem, right? Why not, right? So, what I would suggest is, I will leave it like this. So that's the matrix algebra. Let's have a look at the more applications later on with the topic 4 on the Markov chain and topic 5 with the couple linear differential equation or second order differential equation. Okay, let me take a 5 minute and then go over the topic 2 together. Okay, see you in a bit. All right, let's have a look at the first question with the gradient linear line equation, your favorite, rise over run, etc. So make sure also if they want the form in a different way, you do that, all right? So if I get the gradient, it's gonna be 2 over 10, right? Yes, I got 1 over 5. And then you can use the point gradient formula. I love that one. So y is equal to 1 over 5, x plus 3 plus 1 is what we have. But also, if they want things in integer, what I would suggest is you get rid of that rational coefficient by multiplying by 5 on it. So 5y is equal to x plus 3 plus 5. Then you can rearrange to express a, b, c in integers. So yes, there are many different forms, but the question would typically ask you to write in certain form. You gotta follow those instruction. If that was my gradient, what is going to be the perpendicular gradient? Yes, the -5, because I want their product to be -1. Great answer. Let's move on. Yes, what is very important here is you need to understand always about the domain and range. If I got the square root of x minus 4, you want the inside to be bigger than equal to 0. So x bigger than equal to 4 would be my domain. That's great. Then you can just plug those values in. If you put 29, for example, h of 29 is going to be square root of 25, easy peasy, lemon squeezy. It's going to be simply 5. That's okay. But also, if the question demands you to find a range, I really want you to be able to sketch the functions roughly. If it requires a calculator, do so, and then try to see what the domain and range is going to be by looking at the graph, especially for the range. So I'm gonna, but square root of x is a typical shape. I do expect you to be able to graph it quickly, and for the range is going to be simply just bigger than equal to 0. Easy peasy, lemon squeezy. Let's move on. Right. And for the composite function, it's super duper important to understand the diagram, okay? So for the composite function, what I want you to remember is the following. If you're looking at, right, fx, let's say a to b, and then gx, let's say, is a c to d, okay? And if you want your composite function to exist, what you need to do is that you first analyze the inside, which is the gx, isn't it? And then you analyze the outside, which is the outside is the f function. But then the range of the inside must be the subset of the domain of the outside. This must be demanded, okay? It's a very, very important condition for the composite function to exist, so I don't want you to forget that. So if you're analyzing the g composite a, for example, what you're looking at is the h function first. I got the square root of x. You should know the domain and range right away. So domain and range is bigger than equal to 0 for both of them, for both the domain and range. That's great. That's the hx. And then we're looking at the gx, which is a quadratic, right? And for the quadratic, the domain is all real, sure. And the range is going to have a minimum at 0. So it's going to go from -4 to infinity. Yes, you know what? AI 100% calculator based, but would you use calculator for getting those domain and range? No, you shouldn't, right? It's going to take a lot of time to sketch them all individually, right? And so make sure that you are able to do them without the calculator, okay? Sure, so yes, I'm very happy to see that the range of the inside is the subset of the domain of the outside, so this would exist. And you need to understand this, my friend, because, the common mistake is this. Look at this. So, you know what? Let me just plug that in. If you plug that in, square root of x, perfect square, I get an x minus 4. I'm having a linear function for the composition, so I claim that domain is all real. But that's a wrong answer, right? It's incorrect because it's a composite function. My initial function started from 0, right? So that, my friend, in this case is going to be the domain of the composite function. So even if I see x minus 4, I need to say x is bigger than equal to 0, inspired by the function inside. So it's very important, okay? So if I do the h composite g, my friend, let's switch around and see if that subset condition is met. Right, so as you can see, no, it's not going to be a subset unless you restrict, my friend. That is very great. That is very, very important. So you want the inside function x squared minus 4 to be bigger than equal to 0, my friend. Yes, for inequality, you want to visualize it, but I wouldn't graph it on the calculator because it's very simple to solve it, right? So do not rely too much on the calculator. That's the principle that we're talking about during this section. So here, -2, that's great. I want things to be bigger than equal to 0, so above the x-axis. Then I'm going to restrict my domain to be, what is it? X is less than -2, or x is bigger than equal to 2. Then my range is now going to be from 0 to infinity, which in that case, it's going to be a subset of the domain of the outside. So that is great. So then my composite function would exist. Okay, so make sure you know how to find the domain. And this time, the range then is going to be from 0 to infinity for the composite function for the second kind. So I'm very happy. So make sure you're working with the composite function, but do not say just because you see the linear that the the domain is going to be all real. This is the linear function after the composition, so you need to check on the condition for the inside function for the domain. Okay, so that's great. Another very great question. So if you look at this function here, if you just quickly visualize on the graph, let's do that, my friends. So if we quickly sketch on the 84. So let me graph it. So clear, sorry. And then I'm gonna put, what is it? The x squared plus 3 over x squared plus 1. So that is great. So if we just quickly graph that, we get a sort of a normal function lookalike function with the horizontal asymptote of 1. So that is great. But as you can see, you need to be able to demonstrate why it's not going to be having an inverse function, because simply does not pass the horizontal line test. So it does not pass the horizontal line test is what we're going to say. But you can restrict the domain to make it one-to-one function so that it's going to have an inverse. So, either you can restrict for the bigger than equal to 0 or less than equal to 0 so that it's going to be a one-to-one function. It really depends, right? And when you're looking at this rational function, what you notice is that I want my x to be less than equal to a. So x, if you let that to be less than equal to a, then you get a rational function like this. Then it passes the horizontal line test and it's a one-to-one function. It will have inverse. So that's lovely. Now let's try to find the inverse function. What we typically do, my friend, is we interchange x and y. That's great. So it's going to be x is equal to y squared plus 3 over y squared plus 1 is what we have. Okay, that is great. And then I'm going to rearrange. Then I have, xy squared plus x is equal to y squared plus 3. And then let's, what we typically did is to, rearrange by the y, factorize by the y. But as you can see, I face a problem because, well, not really, haha. Actually, it's quite lovely. So yeah, let's use that. So y squared is going to be now 3 minus x over x minus 1. That's great. Then I have a y is equal to plus minus the square root of 3 minus x. And I can claim that as my inverse, but not quite yet, because the inverse must be unique, my friend. And for this one, you need to look at the domain of the original function. So domain of the original function will be the range of the inverse function, right? Because they interchange, right? If it was a to b, the inverse function would be b to a. That's the definition. So my range of the inverse function must be less than equal to 0, which then suggests that I should have the minus outside, is what we have. Okay, so sure, be able to restrict the domain to make it one-to-one. For that, yes, you may use your calculator, and those points that you need to have the restriction on is typically from a turning point. So make sure you're trying to find the maximum minimum and then see which part you're going to use it for, bigger than or less than for the one-to-one function part. Okay, that's great. Sure. So for part A, we're looking at the g function here. So that's great, right? It's a linear function, so one-to-one. Domain range was already all real to all real, so I'm sure the inverse will be all real to all real as well. So you just have to swap around. You don't actually have to find the expression of the inverse to find the domain range, but they did ask you to find it, so you should interchange, right? And then yes, for this one, you can use easier composition, right? So what you can do is get rid of that g inverse by compositing the original function to the right. That means you're going to do the same thing to the right here as well, right? So 2 times. So the composition of this then will give you the, the f function here on the left, right? So 2 composite gx is what you can also have. Okay, so but what do you think this is going to be if I was doing the 2 composite g? Very good. Now here's a constant function. Whatever the value you get 2. So it's actually quite lovely, so that it becomes simply 2. Okay, so but then the thing is, you need to understand how to get rid of inverse by compositing the original function, and you need to respect the order because the composition is not commutative. That's great. Let's move on. So yeah, what I want to do is talk about the function and calculator, especially on the graph, right? But then the thing is, I want you to know the general graph without actually using the calculator on, right? Because there's some general function that we can quickly sketch. If it's a linear, y-intercept is the key, as well as the gradient, and yes, it's a negative. I know it's gonna be decreasing, so that's that. And for the quadratic, you're right. You need to see if it's a factorizable, Or if it's not factorizable, I should do the completing the square. Yes, you're right. You can do, you could graph it. But for me, if it's a quadratic, why bother? Because I know it's negative coefficient giving me the concave down, right? And you can easily find the maximum at the axis of symmetry, right? So I know my axis of symmetry is going to be, using the formula, it's going to be 3/4. So you got to plug that value to find the y value, to find the maximum, which is going to be then used, for example, defining the range of this quadratic function. So what I'm trying to suggest is that, yes, you are able to put this on the calculator. I don't mind. But if it's a simple function like this, just be able to graph it. It's very important. And yes, if it's a factorized cubic, then yes, we got the, x-intercept, -1, 0, and 1. Sure, if it's got the negative leading coefficient, it's going to eventually go down. Everything's a multiplicity of 1. Then it's going to be simply just pass through and going down. If it's a simple like that, just be able to sketch with by hands, will you? All right. Rational function. What's very important? Grade the horizontal asymptote, right? So we're looking at the denominator being 0. That's -12, my friend. Okay. And what's going to be the horizontal asymptote? You're right. We're looking at the coefficient of the top and bottom of the linear case. It's going to -12. The horizontal asymptote is also -12. Right, so horizontal line, you need to put the y is equal to constant, right? And then the vertical line is x. And how do we determine the shape? We try to find the intercept. So if, for example, if you plug 0, I get 1. So 0,1, and then 1 is the right rational function. Is great. So that's how we can see the rational functions. So be able to sketch them quickly. Exponential functions, so important, right? And make sure the role of the constant, my friend. My constant here, 3, indicates the horizontal asymptote, so I wouldn't hesitate to graph it right away. That is great. So y is equal to 3. That's lovely. And let's try to sketch by finding the x-intercept or y-intercept. So he always has y-intercept. That's great. So if you plug 0, e to the power of 0 is 1, so it will pass 1 there. That is great. Hold on a sec. Yes, it does, right? So it passes that, right? And then, this would have been a growth, but then I multiply negative, so it's got reflected. So the graph is going to look like the following. So that is the exponential function. So make sure you know the concept of the exponential function. The constant is always the horizontal asymptote. And as you can see, the horizontal asymptote will be achieved as x goes to -infinity. So it's very common to sketch this way. Okay? And please know how to reflect around depending on whether you multiply on the range or the domain. Okay? That's lovely. So, let's put a bracket here. And yes, it's the logarithmic function. What's very important for the logarithmic function? Very good answer. The vertical asymptote. Whatever the value of x, that makes the inside of log 0. So I'm going to put a half on it. Right? So that is great. So I got the half. Right? And then, it depends on the reflection. I multiply the -1 here again. Right? Well, before that, let's try to find the x-intercept. Let's try to find the x-intercept. So if I let that to be, for example, 0, right? If I put that 0, then it's going to be ln 2x minus 1 is equal to -2. Then 2x minus 1 is going to be e to the power of -2. So x is going to be 1 plus 1 over e squared divided by 2. All right, so that is certainly bigger than half. So my x-intercept is here. So either it's slowly going up or slowly going down. But as you can see, my friend, it's multiplied by the negatives. It's reflected by the x-axis. So I'm going to sketch my graph like this. So yes, you know what? You could have put this on the calculator, but would you really? Right? As an HL student, you should know one of these essential functions, sketching quickly by hands to get the idea of what the questions look like. Logistic graph, so important, right? There are many things to say, right? But one of the typical thing is that it's got the 2 horizontal asymptote. Make sure you put the constant here being 1. Then you can see that the horizontal asymptote is going to be 200 and 0, right? And then the y-intercept here is going to be 200 over 3, so around there. And yes, we're going to sketch our function like this, right? That's the logistic growth, sigmoid, right? But here's the thing, my friend, where does the inflection point happen? Yes, you can prove it. You can find it using the differentiation, but doing the second derivative here is a very, very extra work. I don't want you to do that, all right? So for that, what I want you to do here is to remember for the logistic growth, my friend, that it happens at the half of the horizontal asymptotes. It happens that when the y is equal to 100, then you can find the time using the calculator, especially the answer over, because this is a one-to-one function. Please be able to draw quickly is what I'm saying. Yes, the sinusoidal function, very important, isn't it? So if you're trying to get the graph, oops, maybe too large. And yes, you need to understand the role of this horizontal line, my friend. That's the principal axis. So I'm going to sketch y equal to 1 like that. And the amplitude was 3 plus minus 3. So my maximum is going to be who, my friend? 4. My minimum is going to be negative 2. That is great. And it also starts at what? 2. It starts at 2. That's great. And what's the period? Yes, 2 pi over b. That's 12. My period is 12, so I need to go up to what? 14 to have the length of 12 on the horizontal line. And then I multiply by negative, that's got reflected. So in the middle was 8 here. Then instead of drawing up and down, I'm going to sketch down and up. So please make sure that we are able to, graph this quickly. You know what? Yes, you are more than welcome to put this in the calculator. However, here's the thing. We're going to have a look at some cases of graphing functions on the calculator, be aware of it. However, the thing is, we need to know the general graph so that you can set up your domain, right? Using calculator does not mean putting it's a magic box, right? It's not the genie in the lamp, right? It does not give you the answer. You need to use your mathematical understanding, especially for sketching or graphing. What you are going to be asked to do is to set up your x minimum, x maximum, y minimum, y maximum. And for those, yes, knowing how to sketch roughly really, really helps. So make sure that you are able to sketch those essential functions as we have discussed. Okay, but yeah, you know what? Sure, we will get to, graphing with the calculator. So for this typical function, it's very famous, right? However, let's just try to use our calculator and tell you what I mean by knowing the function is the essential thing. It's the first thing rather than relying too much on the calculator. Let me show you, my friend. Let's do x times square root of 1 minus x squared as the question suggested. So I got this. However, maybe for my problem solving, I wouldn't use this graph as it is now, right? Because look at this. Whenever possible, please define the domain. And for me, I know my domain needs to be 1 minus x squared less than or equal to 0. So that's going to give you bigger than or equal to negative 1, less than or equal to 1. For that, I know my domain, so it's going to be between negative 1 and 1, which is going to help me to visualize much better. So for me, what I would do is, okay, I'm going to press menu 4.1. Please remember, menu 4.1 is the window setting. Because I know my domain was from negative 1 to 1, I'm going to go negative 1.2 to 1.2 just to make more fitting for the graph. But as you can see, my y value is not that fitting enough. So I would do menu 4a, zoom fit. Menu 4a, zoom fit. Then it makes my function much more fitting, and it's just better for us to work with. And it takes a split second, right, to realize, oh, I got my domain, I need to restrict it. So then in that restricted domain, I don't have to bother too much on my y value because calculator is going to do the justice. Okay? So that's one thing. Respect the domain. You need to set up the x values. You need to set up the y. You need to set the x values, but not for the y values, not so much. However, you gotta be. Oh, sorry. So yes, if you look at this, look at this. Imagine, right? I was using the standard zoom, and then I did the 1 over 100 x times square root of 1 minus x squared. So if I didn't respect the domain, look at this. If I didn't respect the domain, if I visualize this, it shows a straight line. And I might have been thinking, oh, okay, this must be looking like a linear line. No, because you didn't scale it enough. To see the scale well, the first thing is, again, to do the domain. So I'm going to go from, let's say, negative 1.2 and 1.2. And then for the y value, it's not going to change any y value because calculator is going to do the justice for you. If I do the zoom fit, as you can see, look at it. The y scale is now 0.006. It's a very, very small value. I think it's very unlikely for you to be able to come up with those values to set up the region. However, who can do it? Calculator can do it. And then, but for that, it's not a genie. It's not genie in the lamp. You need to set up your domain by yourself. All right. But you gotta be very careful, my friend. Let's have a look at this cubic function, and then why we gotta be careful by using the zoom fit too much. Because I know my cubic function is not bounded, right? It goes all the way up and down, right? Its range is all real. So if I try to set up the cubic function, let's say x cubic minus 2x plus 1, look at this. If I perform the zoom fit on this, it is going to look like a perfect x cubic because it wants to negate that local maximum minimum, which is quite trivial to his range actually. So if I do the zoom fit in this one, it does not show you any turning point, and I don't want you to do that. I don't want you to do that. So if you have a function like this which is not bounded, do not, especially for the polynomials or exponential, do not use the zoom fit because it might give you too big of a scale, and I don't want you to do that. Okay, that's great. Okay, let's move on to the next one. This is very important. I want you to put 5-star on it. This is really, really important. This is really important to emphasize my point that you need to understand the math before relying too much on the calculator. But because look at this. We are looking for the battle, all right, of a quadratic and exponential. As you know who's going to be eventually faster. You're absolutely right. My exponential is going to be eventually fast, right? However, for first few values of x, yes, the quadratic seems big because he's got the very small scaling down with the exponent there. But if I quickly graph this, on my own like this, I know my exponential function may look smaller than him. However, I'm very confident that it will eventually caught up, right? It's gonna catch up. So you need to find several intersection points. But if you don't respect that, right? Let me try to put this on the calculator without thinking that eventually the exponential function is going to be bigger. So if I put quadratic function here to solve the inequality, right? And then I will put another entry here. Let's say 2.01 to the power of 0.3x. Look at this. It looks like quadratic function is a lot faster. So for solving the exponential function bigger, maybe you will find the two x-intercept, one being at 0, and then another intersection here, left and right bound. Intersection, lower, upper, 3.3. I wouldn't say my answer. I mean, you could mistakenly say that the solution is going to be from 0 to 3.3. However, as you already know, I'm very confident my exponential function will be eventually bigger. So I need to make my x value much bigger than 10 to see that eventual catch-up part, right? So that would be only possible if you know what you're talking about with the function, right? So here, with your will, calculator does not tell you, my friend, right? It's a linear algebra. If you don't have your input, you wouldn't have a good output. So we do it. We increase the domain. Let's have a look at the up to 50. And then now maybe I will make a zoom fit. So as you can see, look at this. Look at this. In this part, there's a part where the green part is going to catch up, right? And that's the part that I need to find it. But obviously, you want to maybe scale down a bit. So I would go to zoom menu for 1 and then halfen the window. Maybe y maximum as, let's half it. Maybe I'll put it divided by 2. Then yes, as you can see, you can clearly see there's another intersection going on there, right? So we need to find those intersections, right? It's going to be cut off, right, from the graph, and we don't want that to happen. We don't want to miss those information. So left and right, I get 32.9. So you can actually see there are 3 intersections. But if you don't scale it down on your own understanding, you wouldn't be able to see it. So very important, graphing with the function understanding is the key, okay? That's great. And yes, you're going to see a lot of modeling. For the linear modeling, yes, sometimes you might have, the piecewise function. I know it is piecewise because, yes, here's the thing, here's what you need to do. When you see a problem, you need to know what the question is going to ask you, right? So here it says, company charges a monthly fee 10 plus 0.12 per kilowatt per hour. So that shows that that's going to be my gradient. I know that. So my first function, in terms of electric use, I would use C actually. C of E is going to be, gradient plus the initial value, the y-intercept, right? That's great. But because it's a piecewise function, you need to set up your bounds. E is from 0 to going up to what? Sure, 250, right? You need to always indicate the unit here. It's gonna be kilowatt, right? Hour. That's great. So if it's bigger than 250, bigger than equal to, then what would you set up, right? It needs to be connecting, right? You don't want your build to be jumping enormously, right? So we don't want that. So if I put, for example, 250 here, and what do you get? It's going to be 250 times 0.12. I get 30, right? So it's 30 plus, for example, 10. So it's going to have a 250, 40, right? So that's the point that it's going to go up to from 0 to 250. And then after that, they charge you more because they put the bigger gradient. So it's going to go up like that. And because I know the passing point, I know the gradient, I can use the point gradient formula, which is 0.13 e minus 250 plus the y value, which was 40. And that's how you can use your piecewise function. Then you can figure out what the value is going to be. We found the expression. Total monthly cost is 300. So which piece are you going to use? It's a past the 250. So I got to use the second piece. You're going to put the 300 under the value. If you did, it's going to be 47.5, right? So that's the cost for 300 kilowatt hour. Okay, so piecewise function is very important that you define what the domain is going to be in that interval. Which piece are we using is the key. Okay. Sure, yeah, a lot of text problem, right? A lot of text problem. Because, for the taxation, they do this in a different interval. For that, you need to indicate what interval it's going to be. It's actually given by those income, right? So your text function here, depending on the income, is going to be also given by the, the interval. But, sometimes they give you the unit. They want the amount of the text to in thousands of s, right? So thousands, you want that in terms of thousands. So that means you want your income to be without the three zeros. So from 0 to up to 12.5, because now we're talking in unit in thousands. So 12,000 will be 12,500 will be translated as a 12.5. That's great. I don't give any chart, any text. That's great. So 12.5 income less than 50 is going to be charged with how much? 20%. That's great. So that's my gradient. And then my connecting point was at 12.5. So I used the point gradient formula. Income minus 12.5 plus a 0 is where we connect, right? So we were going like this and then move like that. And then at that point here, my friend, what are you going to do? I'm going to charge more. That's going to be 40%, double the tax. Oh la la. So it's going to be 50 going all the way up to who? Going all the way up to, what does it say? Next 100,000, next 100,000. So onto this, I added the, 37.5. That's why I went up to 50. Now I have to add 100. So I'm going to go up to 150. That's great. So then it's going to charge you, 0.45 for the gradient. I minus, and the connecting point here is going to be at 50. And then you need to find the y value from the second value when you plug the I to be 50 because you want it to be connecting. So if you do, and then work out the y value, you end up getting 7.5. So that's great. Okay. Oh, oops, sorry. Yeah, for that gradient is a 40. So 40%. So I should put 0.40 is what we have. Yes, that's better, right? And then the income now, anything bigger than that is going to be, any further income is going to be now 45%. So 0.45 income, piecewise function connecting at 150, and then the y value from here when you plug the 150 onto the previous equation. So that makes 100, and that makes 47.5. So it's going to be 47.5 is going to be the the y value that I would plot for the point gradient formula. So you got now all the pieces. Obviously, it's better to expand them out and then try to simplify as much as you can, right? So we got the 0 text, 20%, 40%, 45%. Well, it's too drastic. So 20, 40, 45%. We got the 4 pieces, right? So that's lovely. So you can have that. And then, calculate the tax payable. So 35, 70 is what you're going to plot, right? And then for 35, I'm going to use the second piece. For 70, I'm going to use the third piece is what you're going to do. Find the minimum income required to have the pay tax of 50,000. For that, you're using the y value. And you're trying to find the, the intersection for that is what you want to do. So if it's 50,000, I'm not going to put 50,000 here because everything was in thousands. So I'm going to put 50 there, and then try to see which function is going to give you 50 at the interval. So for this one, I believe you need to have the fourth piece is going to be connecting with the 50. There you go, because we know that this was a 47.5. So the piecewise function, linear piecewise function, very popular with the text question. So make sure you are understanding that. Okay, sure. Also a very good modeling problem for the quadratic, because quadratic can be, talking about a rational expression, because the rational relation for the quadratic equation is very popular, such as a distance, speed, and time. But also you can have, unit price, quantity, total sales. Right, this is also a triangular relation. So here, if you read this question carefully, I want you to pause the video and try to attempt on your own too. Florence purchased a number of handheld electrical games for 180. So that's the total value that we had. She decided to keep one for herself. I don't know how many, so I don't know the unit price. And then let's say X was the number of the games she purchased was 180. All right, that's great. But she now kept one for herself. So now she has X minus 1 many. Sorry, she has only 1 many, and then she sold how many? X minus 1 many. She sold the remaining games for $1 more than she bought them for. So that's to state that the unit price that she had initially for the purchase was 180 over X. But now she charges $1 more, right? And then that's the sales, right? But then what we want to do is, so she wants to make the profit of 10. So of that revenue, I'm gonna subtract by the cost, and I want this to be 10. Is what the equation you have, right? So it doesn't look like a quadratic here, my friend. However, if you multiply the x on the both sides, you end up getting a quadratic equation, because you're gonna get x times x minus 1, and what is it? Sure. So if that is 180x, however, if I take that x inside of the bracket, then I have x minus 1, and 180 plus x, and then the rest. So if you expand, you end up realizing, okay, this is actually a quadratic, right? So for this quadratic, if you expand and simplify, you end up getting x squared minus 11x minus 180 is equal to 0, which is easily factorizable with 20 and 9. So x must be 20, because we're talking about quantity. We want to only accept the positive value. It is how you work with this sort of a quadratic expression. But here, how have you got the quadratic expression? Because we are working with the triangular relation, such as the total price, or the distance, or also job, efficiency, and time is also another very popular sort of a triangular relation. So make sure for the quadratic, those are very popular, such as question number 82. So it says 24 kilometers every day. Okay, and he always maintains a constant speed. All right, if he had walked 2 kilometers, so the constant speed, I don't know, right? But he had walked 2 kilometers per hour faster than he usually does. He would have completed his walk 1 hour early. So that is going to be using the triangular relation, because we have a distance times speed, and we're going to use the time. So for the distance is 24, and if with his usual speed, he would have taken longer, of course. But if you subtract by the time reduced by faster speed, now I got 24 kilometers, but then the speed now was increased by 2 km per hour. So I'm going to add by 2 on the x. And this difference here is how much? Is a 1 hour much. So it's a rational equation, you're right. However, if you put it into the common denominator and multiply by the common denominator on both sides. So let's try to multiply by the common denominator x times x plus 2 on both sides of the equation. Then you end up having the quadratic equation once again, for which you can then solve it easily. If you expand and simplify, what you end up getting is the x squared plus 2x minus 48 is equal to 0, for which we can easily factorize with the 6 and 8 plus negative minus there. Therefore, x will be 6. So I'm going to use his constant speed was a 6 km per hour is what we're going to say. Okay, that's great. So we got looking at many functions, but now put it into the real context, right? For the linear modeling on the exam, very likely to be the piecewise function. Make sure you connect them. For quadratic, sure, it's, typical one is, the maximum minimum problem, but also those triangular relations are also examinable. But for the exponential function, it's always about the growth and decay. You're going to see popular questions like this where they don't give you the exponential function, but you have to derive it. But the way you derive, my friend, is that you understand the key features of exponential function. The key features of exponential function is that it's got a horizontal asymptote. And if you read this question carefully, you understand, yes, my temperature of the tea must decay to the what? The room temperature, which is a 22. So whatever that function is, I don't care. It's a times b to the power of but I prefer working with the exponential e. So but it's a decay, so I know that, so it's gonna be negative kt. But now I can solve one homework with the horizontal asymptote because it says the room temperature is 22. So I know my object is gonna decay to the horizontal asymptote of the room temperature. So I'm gonna add constant 22. So all you gotta do is now find the a and k. That's it. For which we require two initial conditions, and we have it. We had the initial temperature was 98, so 0.98. So that means if you put 0 here, that becomes 1. So A must be 76. That's great. And another temperature is now what? After 2 minutes, so it's going to be 2.94 is what we have. So 94 is equal to 76 times e to the power of negative 2t. Plus 22 is what we have. That's great. Then you can easily find, negative 2k, right? Because we used the time t there. So then it's good to go, right? So because then it's going to be 72 over 76 is e to the power of negative 2k. If you take a square root on it, then you can find the e to the power of negative k, which is going to be square root of if you try to use the 4, I believe it's going to be 18 and 19. So 18 over 19, right? That's great. That's great. So then, your exponential decaying function now can be given exactly as the following: 76 times square root of 18 over 19 to the power of t plus 22, which indicates this is my horizontal asymptote. So make sure in the real life context, if you think it's exponential function, you need to find the horizontal asymptote. The question usually tells you. Okay, so that's 83. And we're going to have a look at another question with 84, which is power function. But let me take a 5 and then come back to you. All right, let's have a look at the next question. The reason I brought this is that, yes, the proportional and power function is very popular, isn't it? So if you want to describe the relation, you need to know whether it's directly proportional, is it proportional to the square root, etc. We read that, yes, it's going to be proportional to the x. So we can change into the equality. So yes, then you can make by multiplying the ratio factor, and you can find this ratio factor by using the initial condition. What is it? It's going to be 5,12, right? So if you plug it in, then you can find the k to be 2.4, right? Then you can use all this value for the remaining problems. But yes, those worthy problems, you got to make sure you find the right relation and right coefficient, right? So now let's have a look at the next one. Power, proportional, cube wind. That's it. I don't need to read too much. So power is proportional to the cube of the speed. That's great. Then I can change the equality by power constant as cube is what you have. And where can I find the k? Sure, I'm going to use this initial condition. So it's going to be, 10, 2.05 times 10 to the power of 6. So if you plug that in, 2.05 times 10 to the power of 6 is equal to k times 10 cubic. Then yes, you can rearrange them around. You can find the k, right? So that's it. So then you can figure out the other values by plugging it in like a function. Then we're good to go. Okay. So let's have a look at the indirect. Yes, that's gonna be the reciprocal. So it's very likely that it's gonna involve the rational expression, isn't it? So if you look at the part A, P, V, proportional to inversely proportional to volume. So P, the pressure is inversely proportional to the volume. So the equation is going to be now P is equal to K constant over V. Again, using the initial condition, we got the 20, 45,000. That's great. You got to plug them in, and then K is going to be who? P times V. So it's going to be 20 times 45,000. So it's going to be who? 900,000 is what you have. So P is going to be now 900,000 over V is what you have. Then the rest is just, you got to plug them in, right? So just make sure you're able to find those power functions directly inversely. Easy peasy, lemon squeezy. And yes, let's have a look at the cubic modeling here. I got the modeling there, and once you see your equation like that, what I want you to realize is that yes, on the graph, it's going to look like this, right? Because I got the leading coefficient to be negative, so it's gonna go eventually down is what I'm saying. Okay, so make sure that's a real life situation, right? Because it's supposed to be t is a number of hours, is a time, so I need to make sure that it's bigger than or equal to 0. And then it's in hours, right? And it's a 24-hour period, so I'm going to define my domain from 0 to 24 is what we do. Then yes, all you got to do is just plug the 5 there, so that's fine. And highest to lowest, yes, you're going to use your calculator to find the maximum minimum. But yeah, you know what, let me quickly demonstrate on the graph. So for me, sure, I'm going to put the cubic function here, 23.5 minus 1.72 times x plus 0.2 x squared minus 0.0056 x cubic is what I've got, but I don't see anything because you didn't define the domain yet. So what I'm going to go here is menu for 1, press menu for 1. I'm going to go from 0 to 24, right? And then for the y value, you don't have to sweat because in this restricted domain, I'm going to ask zoom fit. So he's going to find the y value. Then you can easily find the maximum minimum on this graph. That's great. So you can do easily A, you can do B. States that the maximum temperature is 22. If the temperature rises above this, the air conditioning system should be switched on. So what you want to do is, yes, you're going to find the y equal to 22 and then find the intersection, right? So I'm going to put the 22 there, then voila. And anything that is above these 22 is going to be the y value that we need to attack on. Okay. Easy peasy, lemon squeezy. So, please be able to use calculator for modeling problem here. But, it's good to know what the graph is going to look like, because if I don't see it, that means if I don't see a graph that I'm expecting, that means there must be a problem with my entry or the window setting, right? So those things are required to solve a modeling problem. And yes, if you look at the question 88, it's the real life situation with the Ferris wheel. It's a very common question to ask in the trigonometric function. Make sure you're trying to visualize by the graph, right? So what you're looking at is that it starts at the bottom of the wheel and it goes up and down, right? So the progression is going to look like starting from the minimum, going up, going down is what we have, okay? So then we can see that it's good to go with the cosine function because it starts from the minimum. So that's great. So then, the amplitude is going to be always the radius. So the radius is a 55. So what I'm going to put is a height is negative 55 cosine. And then I look at the period here. 1 revolution is 20 minutes. Then 20 is equal to 2 pi over b. So b is going to be pi over 10. That's great. T plus, if I left it like that, that's going to be plus minus 55. I want my minimum to be 10, so it's going to be 65. So that is your trigonometric function. That's how you can find those ABC. That is great. Sure, let's have a look at the section 2.6. It's a very, very nice problem. You know, if you can solve this problem, you have no problem with the modeling, because modeling can be very tricky depending on the nature of a function. Let's have a look at this. So now we're talking about the text sphere, okay? And then now what they're saying is that for the first meters or seconds, depending on whatever you want to do, the minimum charge is 2.6. Okay, so that's the minimum. There's a minimum charge. In addition, either meters or time, whatever the piecewise function that you want to use, it depends on what the question is asking for. We use different rate, right? So you're gonna have a piecewise function, linear piecewise function, but I need to make two linear piecewise function depending on the distance and then the time. So let's have a look at the first piecewise function here, depending on the depending on the distance. So what they said was, okay, from minimum distance to what is it? Up to 234.8, I have my cost function given by the minimum charge to be 2.6. So that is always paying for the first 200 meters. That's great. And then from 234.8 to up to where? Sure, additional up to 9,656.1. Now we have for each additional 170.4, we charge them, what is it, 0.2. So that's great. So that's gonna be your gradient, my friend. That's gonna be your gradient. Okay, but the the gradient is rise over run. We do especially kilometer per hour. It's usually per unit, right? But right now it's for every 170.4. So that's gonna be your run. Your rise was 0.2. All right. However, your run is not every meter, but it's now every 170.4 meters. So what I need to then multiply here is to divide is the run. So 117.4 is your run. That's your gradient. It's very important that we are able to find the gradient. And yes, it's supposed to be piecewise function. So for that connecting part, that's going to be n minus 234.8, and then whatever the y value it was suggesting. That's my a second piece, okay, in this time interval. So that's great. So for the gradient, what you want to do is always the rise over run. All right, so it's not always the given gradient. You need to think about every per what the unit is. That's great. So let's have a look at the next one. So next one is going to be, what is it? Once the distance reached this much, there is a charge of 0.2 for each additional this. So now, yes, we can find another gradient. It's going to be 0.2 charge per, now what? 86.9, because to travel less for same charge, that means the gradient is going to be bigger, so it's going to charge you more, obviously. And then the connecting part here is going to be at 9,656.1. So I'm going to use the point gradient formula, n minus, what is it, 9,656.1. That's great. Then what do I need to add? I need to add the y value generated by the previous piece when you put 9,656.1. So if you do that, you get the y value of 18.65. So that's your y coordinate for the point gradient formula. That's how you can come up with a piecewise function like this. So yes, it depends on the context, depends on the function type. For linear function, the gradient matters, and yes, the question could twist the words like this that does not give you the gradient right away, but you need to interpret what the gradient is going to be. So being able to solve this problem really puts you in a good spot for working with the modeling problem. So that is great. Okay, let's have a look at the second modeling problem, which deals with the quadratic. This is also very, very important. You should really know how to solve this. So let's have a look. So small manufacturing company makes and sells X machines each month. The monthly cost C, this is the cost. And the income is obtained by selling X machines is given by this. So now you want to have what is a profit. So as we know, profit is the difference between what is it, the revenue and the cost. Here they use the income and the cost. So it's going to be, income was 150 x minus 0.6 x squared. I'm going to subtract with the cost, which is 2600 plus 0.4 x squared. So if you simplify, I get negative x squared plus 150x minus 2600 is the quadratic equation we have. That's great. And then if you want to, if you got a function, it's always important that you're able to visualize. And if I look at it, it's a negative leading coefficient, which I know it's going to be concave down. And I know I need to have an axis of symmetry for the maximum. So it's going to happen at the x equal to negative b over 2a. That's great. Okay. All right. So, you got to plug them in. So it's going to be happen at the x is equal to, in this one, it's going to be 150 over 2, so 75. And the maximum is going to happen when you put the x equal to 70, where x is the machine. So 75 machines will guarantee that you have the maximum. Okay. If the company does maximum profit, what is the selling price for each machine? Okay. So, so for the maximum profit, you're going to put 75 on the function, right? That's a profit. However, the question is not asking about the profit. Question is asking about what is it, the selling price of each machine. That's the income divided by what? The total number of sales, which is a 75, right? So it's asking for the unit price. You need to always make sure that you read the question and get what they want. They're not asking about the profit. They're asking about how much should I sell it for each item if I want to maximize the profit. So if I put 75 for my income function, you get 7,875, and I'm going to divide that by 75, which then you get $105. So you're not using the profit function for this one. We're using the, the income function. That's great. And so for thankfully they factorize for me, but you shouldn't be fooled, meaning just because I got the leading coefficient here seemingly positive, that doesn't mean that it's going to be concave up function. If you closely look at this function, you can factorize the second factor with the negative. So if I did, it's going to be negative x minus 20, x minus 130, which gives you actually concave down with the 20 and 130 for the x-intercept. That's great. Okay. And then it says smallest number for machines to company make and sell to make positive profit. So it needs to be slightly bigger than 20. So it needs to be 21, right? At 20, the profit is 0. It's not positive. So you need to then give x being 21. So 21, savage. So what we need to do is always read the question carefully. I want the positive profit. That means there needs to be put the x being 21. Okay. So let's have a look at the question number 91. Great question is exponential decay. So if I have a look at the speed function in terms of t and expand it quickly, I get 1,351 minus 351 times e to the power of negative 0.007 t. So it's going to be an exponential decay. I get it, right? Oh, sorry, but then, so I multiply the negative, this is exponential decay, but I multiply by negative, so you reflect it twice. So decay once, so its graph is going to look like that with the horizontal asymptote, yes, as a 1351. So you should know how to graph things very quickly, right? So it's reflected twice. That's great. Predict the speed after 1 second. So you can just put t equal to 1, no problem. Aim was to break the speed of 301. So you got to put the 301 there. Given that he was in free fall of 600 seconds, did he reach the speed of sound? Justify your answer. Okay, so for that, what you can do here is, so you are going to put t equal to 600, right? And then if you put t equal to 600, what you get is 1330, right? And then that means this means he will break the speed of sound, right? Because that will get you the around there, and the difference here is less than 301. So that's great. Okay, so we always should know how to spot the function, but it's always good to know that you're able to sketch. So for this one, yes, reflecting twice, horizontal asymptote of 1351 is a good case. Okay, so that's great. Let's move on to the next problem here. So yeah, I got the the trigonometric function, and it says that the high and low tide is 5.7. So you got the high the maximum value and the minimum value, which you can find the amplitude quickly, right? So it's going to be, what is it? 9.7 minus 5.3 over 2 is going to be your amplitude. So it's going to be 4.1 over 4.4 over 2. So 2.2 is your, what is it? The amplitude, the amplitude, and then the period, you know, from maximum to minimum, it took how long? 7 hours. So that's the half the period, isn't it? The full period is going to be like that. So 2 pi over b is now going to be 14. Therefore, b is going to be pi over 7 is my function. So 2.2 cosine pi over 7t plus 7.5 is the function you're looking at. Okay. Sure. So I'm after high tide. So I don't need to reflect it because, as you can see, it starts from the high tide. So, you know, for the trigonometric function, we know we're going to be very keen on finding the amplitude and period. The same thing for the logistic growth. Yes, we talked about it before. When we have that, we know that the horizontal asymptote is going to be 100 and 0, right? And it's going to have a sigmoid shape. And then you make sure that the inflection happens at when the population is 50, half of the horizontal asymptote, right? So that's great. The range, we can talk about it, is from, you know, well, you know, it's not going to be from 0 because that would have happened when t goes to negative infinity, but it starts from 0. So you need to find your y-intercept first, which is going to be 100 over 11. Okay, so from there to 100 is going to be a range. So that's great. Use the model to predict how long it would take to half the people to have access to the, so you can find that, and that's actually the point of inflection. And then the question could ask you to find, you know, the indirect question. So what they usually say is to find the maximum rate of change. You need to understand that the maximum rate of change is the inflection point. All right, so from concave up to down. So make sure that that's gonna be the same tone, same narrative, so that you're gonna find, okay, for the logistic growth, I don't have to differentiate twice. I can simply find at the half of the horizontal asymptote. That's it. Okay. Yeah. So horizontal asymptote, that's great. You can find you can use all these initial conditions to find it, no problem. Okay, but what I want you to do here is, I mean, it doesn't ask you about the horizontal asymptote, no problem, but make sure that you are able to figure out, you know, those coefficients using the initial conditions, right? So that's important. But I will move on because we already talked about the logistic growth a lot. For section 2.7, sure, it's a quadratic touching, right? So 5, and it's going to go like this. So obviously it doesn't pass the horizontal line test. So shouldn't have inverse unless we restrict the domain. It asks me to restrict domain for x less than or equal to k. So what you're going to do here is, sure, x less than or equal to 5, where it was a turning point. Then in that case, it's going to be one-to-one function because on that restricted region domain, it is a one-to-one. So I'm very happy with that. If you want to find the relation, then, you know, it's great that they have already put it in completing the square. So x is equal to 9, y minus 5 squared, and I'm going to rearrange. So y minus 5 squared is equal to, what is it, x over 9. That's great. And I'm going to put a square root. So it's going to be y minus 5 is equal to plus minus square root of x over 3. That's great. So your inverse function is going to be 5 plus minus square root of x over 3. And then, yes, you always have to check on the domain of the original function, which is going to be the range of the inverse function. So your inverse function should be always unique. You can't put plus minus. So I'm going to put 5 minus square root of x over 3. That's lovely. So that's your inverse function. Sure. So let's have a look at the next question. But let me take a 5 minute and then come back to you in a second. All right, let's have a look at the next question. It says to state the range of f and g. If you can sketch them, that's always the best, right? So for this one, sure, it's going to be, what is it, concave up quadratic, but make sure that it's for bigger than or equal to 0 only. So I'm going to roughly sketch the function like that. It's going to be restricted domain starting from, where is it? 0,3 over 75. That's the quadratic function. And for this one, sure, absolute value function, we know it looks like just a v, right? So that's great. And for that, the range is going to be simply bigger than or equal to 3 over 75. And for this one, bigger than or equal to 0. So yes, you know, you could have put this in a calculator, but I want you to realize how fast we can solve this problem without using the calculator, right? And for part B, yeah, you know, for this one, you just have to substitute in. The G goes inside of the F, and then, you know, I would encourage you to expand it. That's great. But the reason I got this question from the exam is that I wanted to show you that we are able to find the F for the inverse despite this being quadratic, because you already have restricted your domain, right? Because it passes the horizontal line test. That's lovely. So you can interchange x and y. X is equal to 2y squared plus 3 over 75. So 75x minus 3 over 2 is equal to, what is it? Y squared. That is a great. That y will be plus minus square root of that is what you have. And yes, it really depends on your initial domain. It says the initial domain was x bigger than or equal to 0, so your range of the inverse must be positive, and that's how you can find it. Okay. Yes, we're more than happy to use our calculator, but make sure for those questions that you can solve without the calculator, it's just much quicker. Okay, that's great. So yes, you know, there's also a very nice problem here. If you want to describe the transformation, apply the transformation for the quadratic, make sure you put it into the vertex form. So, you know, for my function here, fx, I will do the complete the square. So 2x squared minus 3 over 2x, you half in the coefficient of x and you square it plus, so 9 over 16 is what I have, right? Minus 9 over 8 plus 1 is what I have. So 2x minus 3 over 4 squared is what I've got. Does this look correct? Yeah. It looks all right, right? Yeah, it's fine. And then plus 1, minus 1 over 8 is what we have. That's great. So on this, what does it say? Reflection in the x-axis. So you're going to multiply the negative 1 on the function, so negative fx. That's great. Followed by the transformation, so negative f of x minus 1 plus 2 is what you're going to do. And then you do what? Horizontal stretch with the scale factor of 2. Horizontal stretch, my friend. That's going to be negative f of 1 over 2x minus 1 plus 2 is what you're doing. So you're going to apply this composition for your function, then you're good to go. So what you're going to have here, my friend, is that, we can do negative 2, and then 1 over 2x minus 1 minus 3 over 4 squared plus 15 over 8, right? Because you're adding it with, hold on a sec, sorry. You're supposed to multiply by a negative on each of them. So if you multiply a negative here, it would have been positive 1 over 8. If you add the, 2 on it, that's 17 over 8. So we got the 17 on the top. So that's how you get the, transformation. So make sure you're able to apply the transformation. It's very, very important. So, you know, if I got this, right, I want to describe the function transformation. What I like to do is describe horizontally as well as vertically. So for the domain, what you need to attack first is translation, and then do the horizontal stretch, right? And then for the range, you multiply first, and then you add by 2 is what you got to do, right? So that's what we do. Okay, so let's then try to describe it. So for the first one, you shift to the right by 3. And then, what does it mean by compositing with the 2/3? That means you're multiplying a number that is between 0 and 1 for the horizontal. That means you make it bigger. So it's a stretch out. It stretches out by a factor of, 3 over 2 by along the x-axis. So you got to get, it's a vector. So you need to say the direction as well. That's great. And then so the horizontal shift, we already talked about it. Multiplying the negative 2, there are two things here. So vertical stretch by vector of 2, right? So that's good. Vector, so direction, the vertical. So that's the direction. Vector of 2, that's the magnitude. And number 2, you multiply the negative, that's a reflection along the x-axis. That's great. And then shift up by 2 units is going to be the transformation. So make sure you respect the order of transformation. When you are describing it, my best bet is to describe horizontally and then the vertically. For the horizontal, describe the translation first and then the dilation or reflection. But for the vertical, it's the opposite. You multiply first. That means you work with the reflection and then the dilation and then you add. Okay? For modeling, we already talked about above, logistic growth and whatnot, so please revise them through. That's important. And yes, we got the bivariate modeling. That's great. And for the bivariate modeling, we got several things with the log, semi-log and log, etc. Right? So if I draw the diagram of a ln y against the x, so the y-axis is going to be ln y, so you got to put it into the logarithmic scale, right? So we're going to put ln y there. That makes 6.09, 6.39, 6.71, 7.02, 7.34. As you can see, it's increasing. So ln y over ln x. So then you're gonna get like sort of an increasing function. So it's gonna be ln y is equal to the gradient, and then the y-intercept. From the regression, you can get it, right? And then if you exponentiate, you get an exponential growth. So it's going to be e to the power 5.77 for the coefficient and exponential function, as we already have done. So make sure if it's a semi-log, if you put the log on the y, you got an exponential function. If you put the log on the x, you get a logarithmic function as usual. But if you put log, that's a power function, right? So make sure you're able to come up with those functions using the calculator as well as the algebra, right? So if I get for example, log here, so it's gonna be taking the log on both sides, right? So you're gonna have a ln t and then ln d, right? So that's great. So if you put that in, right? So roughly speaking, it's gonna be 0.336 all the way up to 1.59. It's gonna be 2.3 now. Oh, it's gonna be 4.77. As you can see, as the input is increasing, the y is increasing, so it's an increasing function. So ln d against the ln t. So you obviously going to get a linear function there as well. So you're going to apply the linear regression. So it's going to be ln d is equal to 1.97 ln t plus the y-intercept. So that's great. So I want to simplify it. So you can do that by exponentiate. So it's going to be d is equal to e to the power 1.6t for the leading coefficient. For the coefficient, and then the exponential function as it is. So it's for this one, it's going to be power function, isn't it? It's going to be power function. So t to the power 1.97 is the power function that we are supposed to work with. So make sure you're able to work with that. For this one, I don't know why I put into logarithmic scale, because the question didn't ask you to put into the log scale. For this one, it's just working with the the graph and then estimate the value. And obviously, if it's a power function, it's a power function. If you want to get those A and B, you can put log on both of them, right? If you want to approximate well, you can do the log function in both, but then, it's not that bad, so you can just use the raw data as it is. So that's the end of the topic 2 modeling, right? So for the modeling, function and modeling, what I want you to remember is the essence of a function. You need to know the natures. When we're looking at this exponential, it needs to be automatic that you're working with the, horizontal asymptote. If you're working with the log, you gotta work with the vertical asymptote. If you're working with the quadratic, you are very keen on finding the concavity, so that you talk about the maximum, minimum, things like that. Okay, let's move on to topic 3, the geometry, right? Trigonometry and geometry. So like this type of context problem is very important, that for the geometry, you need to know how to visualize. All right, so section 3.1 is a measurement, area, volume. You do it, you got to do it, right? And the reason I didn't write, because I didn't want to draw them, but yes, let's have a look at the 3.2 non-right angle triangle, sine rule, cosine rule. Typically with the bearing problem can be a very good context problem. Let's have a look at this. Pause the video, see yourself if you can visualize this. Okay, so it says from observation point A, true bearing of landmark is a C. So I put A, I draw the northern line, my friend. For the bearing is always about the northern line, isn't it? And then the bearing is from A to C is a 51 degrees. So I'm gonna roughly put a C right there. with the help of the degree 51. So that's great. And the bearing of another landmark D from A, my friend. So we go 270 first and then put 14 there. So it's going to be like that. So that's great. So we got the bearing here of a 14 degree. That's great. And then, that bearing here is going to be, what is it then? From perpendicular, you subtract from 90, then the complementary angle there is going to be 76 degrees. So that is a great, okay? And that's fine. And then from another observation B, which is due north of A, so it's in the north of A, so B is right there. And let's put that as 1,000 meters. Why not? Okay. And then from B, we draw another northern line, so we can extend it, no problem. And then we go clockwise direction. Bearing of C. So we go bearing of C. So we go to the C, and that bearing here was who? 115. All right. So that's going to be who? 65 degree. Okay. And another bearing is going to be 180. We add by 44. So that's great. Okay. We add by 44 degree. That's great. So that's what we have. Okay. So now we want to find the distance between C and D. So that is great. So let's do that. Let's try to find C and D. Right. So for that, you always have to classify the given information. So you got the length. You got if it's a 65 and 51 by the sum of the angles of a triangle, you can find the other one, right? So this one is going to be 11, 6, 180. If you subtract, you get the 64 degree, right? So this is going to be 64. Am I right? Yes, it seems right. Is it? Yes, it is correct. So that's great. And this is case of ASA. So as soon as you see the classification, I want you to realize that I got to use a sine rule. So it's a must that what rule you need to use is a sine rule. So that's great. Okay. Then what should we do with this sine rule? Well, I got that, length 1,000 there, right? Over sine 64 is equal to, what is it? Whatever that length that is, I'm going to call it B. B over sine 51 is what I'm going to do. So then you can figure out the B by rearranging, right? So using the calculator, you can find the length B. So that's great. Okay. So suppose you found the B. That's great. I want you to do yourself, right? It's very important. And you can do the same thing for A, right here. If I call this A, right, then, this and that gives you 120. So this is a 60 degree. That is a great, right? Then I can use the sine rule again. It's gonna be A over sine 76 degrees equal to who? 1,000 over sine 60 degree. So that's great, yes. So A is going to be who? Whatever that quotient that is, we multiply by sine 76, right? So that's great. Then I got all the information, isn't it? So if I look at the upper triangle here, right? Then I got a obtuse angle triangle, which is going to be, A, B, and then the included angle here is 109. That's great. Then I got 1,000 meters. So that's great. I can use now, what is it? Sorry, not 1,000. Sorry, I don't know that, right? I don't know that. But supposedly I found the A and B using the sine rule. Then I can use a cosine rule now, right? So it's going to be L squared is equal to A squared plus B squared minus 2AB cosine 109 degree. Okay. Then game over, right? So make sure you're able to work with this type of context problem and be able to use the rules depending on the classification. SSA, ASA, that's typically the sine rule, but make sure you always question about the ambiguity for the SSA. SAS or SSS is typically the cosine rule. So right. So make sure you always justify the use of those rules depending on those cases. But yes, for the 3.3, what's very important is that there's a context problem, and also it involves a lot of identity. The Pythagorean identity is in the syllabus, so you must be able to use it, right? So yeah, for the x, what you can do here is use the cosine rule, right? It's because cosine theta here is given as negative 1 over 5, and I got the case of SSS, so I can use the cosine rule. So if you use it, it's going to be, what is it? X plus 2 squared plus x plus 3 squared minus 3x plus 1 squared over 2 times x plus 2, x plus 3. then you can see that this is going to be merely a quadratic equation, for which I'm sure it was, I think it was a 2. So you can solve it. This is a quadratic equation, and what's even better is it's going to be factorizable, and I ask you to solve it. And then if x was 2, then it will be 4 and then 5 there, right? So that's great. And if I got the 4 and 5, and then I got the theta, so that's gonna be the area. So 1/2 times 4 times 5 times sine theta. And you know what? So yeah, you could have used the inverse cosine there, get the theta, and then plug it into the sine. No problem. But I again remind you, please, that the Pythagorean identity is in the syllabus. So if you can use it, use it, because the sine theta in this case is going to be positive because it's obtuse angle, 1 minus cosine squared. So it's going to be square root of what? 1 minus 1/5. So I got the square root of 24. So 2 to 6 over 5 is what the sine theta is, for which you can put it right away. And yes, for AI problem, it's very often they ask you, what is it? The exact. That means you cannot use a calculator because you need to describe all those exact solution in surds or in pi. Okay, that's great. So, and yes, 3D trigonometry is also very popular. The right pyramid of height 10 stands on the square base. Okay, so for those problems, it's very important that you describe the slanted height as well, right? Using the Pythagoras theorem, isn't it? That's important. So I got the height of 10 meters, right? So that's great. And the square base of 5, right? So then you realize so of that is going to be 2.5. And then you can figure out the slanted height using the Pythagoras theorem, right? So slanted height is going to be square root of, what is it? 10 squared plus 2.5 squared. So that's great. And then angle between the sloping face. Sloping face is this. So for that one, you need to figure out the, what is it? The point here and point there, right? And then we can figure out the, what is it? Diagonal like this. And then if this is a theta, you can use a cosine rule, right? So cosine theta, if I call that as A, right, then it's going to be cosine theta is equal to, what is it? A squared plus A squared, right, minus the diagonal, which is going to be 5 root 2 squared over 2A squared is what you have. So you can use a calculator for that, all right? Is what we can do. So make sure that you're able to use a lot of not only the right angle triangle, but also the sine or cosine rule for 3D shapes as well. That's very important. Okay, let's have a look at the visualization of the 3D case. It's a very popular shape, isn't it? So Sam and Marcus is standing right there, and then I go by 100 meters. Okay, and a large tree is standing due north of Marcus, my girlfriend from high school. So that is right there. My tree is right there, but it's obviously standing up, isn't it? So it's gonna stand up like that, right? So it's a 3D shape, isn't it? And then it's a bearing of 65 from Sam. So I draw another northern line on the Sam, and I'm gonna go the bearing of, what is it? The 65 degree there. So you have the angle here is being 25 degree. That's great. And then the top of the tree appears at the angle of elevation 25 to Sam. So I have a 25 to Sam right there. And then to who? Marcus right there, which is 15 degree. So that's great. And I want to figure out the height. And then of this typical shape of 3D, I really want you to remember it because it's so popular. You use a standing right angle triangle. So if I call that as A and B, right? And then I can figure out the tangent 25 degree is going to be H over A. That gives me A being, what is it? H over tangent 25 degree. And you can do the same thing for B is going to be H over tangent 15, isn't it? So I now have the information that I can describe on the base. It's going to be A, it's going to be B. And then we know the distance between Sam and Marcus is 100 meters apart. That's great. And then, now you see those using the parallel line of the, alternating angle. So it's going to be 65 degrees. So what rule do you want to use? Very good. I like to use the cosine rule for this. So it's going to be cosine 65 degree is equal to, what is it? A, which is the, so, if I use a different version, it's going to be 100 squared is equal to who? A squared plus B squared. So we're going to do that square plus that square minus 2 times AB. And then the cosine theta. So cosine 65. So as you can see, it's just a quadratic equation for which you can use calculator. And because it's a quadratic, what I would encourage you to do is to use graph, right? But then, yeah, I would use graph on this. But then for this one, I don't think it's gonna be a quadratic with it's just a perfect square, right? So I can factorize by h squared, right? So it's gonna be 1 over tangent square 25 degree plus 1 over tangent square 15 degree minus 2 times cosine 65 degree over tangent 25 degree times tangent 15 degree, right? So you can rearrange that, then put a square root on it. You can find the h easily. So make sure the shape is so popular in the 3D that it's definitely examinable. So circular measure in degree, I wouldn't go over too much because I prefer working in radian. And for the HS students, that's more likely. Sure, perpendicular bisector, we talked about it. What is it? If I got those two coordinates, find the midpoint by finding the average, negative gradient, negative reciprocal. That's it, right? But yes, I want to talk about the Moroni diagram. So, the name sounds so fancy, but you don't have to be scared. I want you to always be confident. And what I mean by that is that you always should be confident solving the Moroni diagram, because at the end of the day, it's just a linear line equation. It is just a linear line equation. Okay, it's just a linear line equation, so I don't want you to be scared. Okay, it's not that bad. So for this one, what we can do is an internet weather website uses a reading taken at 3 different stations. A visitor to the website will be told the temperature of the station near. So it's talking about the nearest neighbor, right? Interpolation, right? So what we have here is those sides to be those A. So if I put this in the lattice diagram, so it's gonna be A here. B is 3,1. That's great. And the C was 3,5. So that's great. So I don't have to be scared, because it's always about what? It's always about the linear line equation. We can always manage, no problem. So then we try to draw the perpendicular bisector, of course. So it's going to be given like that, given like that, and given like that, no problem, right? So then what's important is that you try to find the vertex, which is going to be intersection, right? No problem, no problem. Okay, so then use so we can do that. And then particular time the visitor to website at a point 1,4, and the reading of different station are A, B, C. So what they mean by that, it depends on the region, right? It depends on the region, so if your 1,4 is around here, then you're gonna have to read the the temperature in that region is fine, right? So in this cell. So here we're gonna go with A. So for the Moroni diagram, you shouldn't be scared, because it's at the end of the day, it's just working with the linear line equation. It's not that bad. Okay. 3,5 is right here, right? So good. So that's okay. So that's fine, right? So let's have a look at 107. So yeah. So for this one, as far as possible. So that's gonna be the toxic dump, largest possible circle, right? So if we quickly draw the Moroni diagram on the xy plane with the given given sites. So it's at the origin, I got 20, 0, and then what is it? 0, 30, and then I got 60, 40. Okay. So that's what we have, right? So then you can roughly get the perpendicular bisector, no problem. So here I'm gonna get roughly here like that, and then between here, that's going to be, what is it, 15, that's gonna be 10. It's pretty obvious. And then sure, the other lines are going to be perpendicular bisector between these two at that intersection, so it's gonna go like that. And obviously we need to find the perpendicular bisector between these two, so it's gonna be like that. So we sketch like that, and then it's gonna go like this between these two, but you got to create these two as well. So let's say that's roughly speaking goes like this. Obviously, it's not on scale, but obviously you need to make the line equation, no problem. But for that, I need to create the line equation because I'm interested in the vertex, right? So for this one, it's pretty obvious because it's horizontal and vertical. I'm very happy with that. So that's 10, 15. That's one vertex. And for this one, you need to have at least 2 equations out of these 3, right? So if I try to use the Moroni diagram and then the vertex at the around this, that, and this point. So if I try to find this line equation between these 2, right? So it's going to be so let's try to find this one here. So for that one, it's going to be y is equal to 60 minus x. That's great. Okay. And if I try to get this one, right, with the 10, 15 passing point, so that one is y is equal to 2 over 3x plus 50 over 6. So that's great. So then you can find the intersection here by equating these 2. So if you do so, you end up getting 31, 29. So you got 2 vertices. And then what you need to do is now try to find the radius around the circle, isn't it? You got to now find the radius around the circle. So from here to, any of the points, so that radius here is going to be, what is it? The 10, right? Sorry, it's not 10, sorry. So the radius here, so you got to use any of these three coordinates, but from the inspection we can definitely see that this is a larger circle. So from this point you got to use the adjacent sides to find the distance of the radius. So you can choose any value you want, right? So from here to here you can use the distance formula, 60 minus 31 squared plus 29 minus 40 squared. So that's going to be the radius of a circle. That is going to give you the largest possible circle in this one. So this should be the the dump station, right? So make sure we're always trying to find the vertices by using the intersection and then the radius from the vertex to any side adjacent to it. For example, I wouldn't use that one. Sorry, I wouldn't use sure, I wouldn't use this point here, 20, 10 for the radius on that point because it's not adjacent. Okay. Oh, well, you know what? It is adjacent. Sorry about that. This one got me confused. Right? So yeah, it is adjacent. So yeah, any point here will give you the radius. It's just being the same, so it's fine. Okay, so for Moroni diagram, it's either the closest neighbor interpolation or the largest possible circle, largest empty circle. So those 2 things are the only thing that you have to worry about. The rest is just the coordinate geometry, distance formula. It's not big of a deal. Okay, you don't have to worry too much. So for this one, if I quickly just draw the Moroni diagram with those coordinates, right? So negative 2,7, 4,7, and then C is 6,3. So that was A. B and D will be negative 2, negative 5. So that's part D. That is great. And then we can just, I'm very happy to have those vertical line, horizontal line, because perpendicular bisector is very easy to compute, isn't it? So for me, if I draw in green, right? So between 7 and negative 5, if you find the average, that's going to be 1. So 1. Y equal to 1 is a perpendicular bisector between A and D. That's great. And then, between, what is it? These 2, that was a negative 2 and 4. So yeah, at the 1 is also, it's great vertical line, right? However, you got to be careful with the perpendicular bisector. Oops. Maybe it's too far ahead, right? Like that. Between that perpendicular bisector and this guy here. So, maybe it wasn't on scale enough. Sorry about that. So I'm going to move it up like that and move it like this. So roughly speaking, let's say the perpendicular bisector was here, right? And then connecting these 2 vertices here, and between the perpendicular bisector and this and that, you can also get with the median value, the median, and then the perpendicular gradient. And you can easily find this. Well, it's not on scale. Sorry about that. but you can get those equations and the visual is going to be like this, right? So we construct the Moroni diagram. That's correct. To find the coordinate of the vertices, so that means you got to find the intersection. So I think it's a very fortunate to have those horizontal and vertical lines. Then that's going to be very easy for me to find the intersection, because you need to have just one line equation each, because you can plug those y value or x value there. So if you do, the first vertex you're going to get is a 1,3, and then you got 0,1 at the y-intercept. So that's great. So around this vertex, adjacent line is going to be those three. So then you got to choose one of them to find the radius. Around this vertex here, however, the adjacent points are going to be A, D, C. So you got to use one of them, right? So for this one, I would probably use, D here, and then the, for example, A there, no problem, right? Then you can find the radius, right? So no problem. So that's great. For this one, it's also adjacent A. So you can actually, A is for both of them, right? So you can actually, I think it would be better to use the A to find the radius 1 and radius 2, right? Then you can figure out which one has a bigger radius and then choose which one should then be chosen as the station that we're going to put, right? So that's great. So it was negative 2,7, and then one was a 1,3, and then if you do 1,3, the distance formula gives you 5. If you do the 0,1, using the distance formula, it becomes 2 to 10. So as you can see, if you square both numbers, it becomes 25. This becomes 40, and obviously this is much bigger. So at that station, it's gonna be the largest empty circle at the center, at the vertex of 0,1. It's not big of a deal. Yes, for exam problem, it's gonna be very lengthy, but I don't want you to be scared for the Moroni diagram. Just because it sounds so exotic doesn't mean that it's gonna be difficult. At the end of the day, it's just a line equation. Okay, so make sure whether it's asking for the interpolation or the largest empty circle. Okay, so I'm going to move on to the circular measure with the radian for the HL contents, but let me take a 5 and then come back to you. Alright, let's have a look at the circular measure, right? So for this problem, what's important is that you are able to see that it uses the, radian measure, right? So, I want to figure out the shaded region here. So what you need to do is that I'm very confident being able to work out all the area and length on the circle if I have two information, the radius and theta. And I'm very happy with the radius, but I don't have the angle there. So what you can use is, many information there. So, I got the 5 and 5, and I got the chord. I got the chord, which is a 7. Oh, hold on a sec. Is that 7 or this is a 7? Let me check. PQ is a 7. Never mind. That PQ is a 7. My bad. This PQ is a 7. So, okay. So for that, we got a triangle like this. It's SSS, right? Then you can figure out what is it. The angle here, for example, theta and phi, using the cosine rule, isn't it? So if I do cosine theta, right, what is it going to be? It's going to be 5 squared plus 7 squared minus 6 squared over, what is it? 2 times 5 times 7 is what we have. That is a great. And I can get the cosine phi as well, which is going to be 7 squared plus 6 squared minus 5 squared over 2 times 7 times 6. So you can figure out the theta and phi respectively. That's great. And then if you want to figure out, for example, here, the segment, what is it? So segment is sector minus the triangles. The formula goes by the r squared over 2. For the red one, here it's going to be 2 theta, right? So 2 theta minus sine 2 theta. In radian, please. Everything what we are writing down here is the radian measure. So here for the pink, I'm going to use 2 phi, right? So it's going to be 6 squared over 2 phi minus sine 2 phi. That's correct, right? So make sure that you're going to add them. So for the first one, radius is a 5, so it's a 5 squared. So we're going to add them together to figure out the shaded region. So make sure you're using calculator for that, right? Or also for this one, it's also a lovely problem here. Make sure that we are always willing to, draw the extra lines on our own to gain some information. So here I'm given the 2 radius there, and I'm given the r just here, right? And then for this segment, what you want to do is to separate as a first segment and a second segment. For that, you need the angle theta here, and then the CAD was a theta, and what else? The other angle was given as, let's say, alpha is the CAD, and theta is the CBD, right? So this is a theta. Sure, then we're going to use the segment formula, right? The segment formula was r squared over 2, and then the angle minus sine theta, which is the difference between the sector and then the triangle. So for number 1, segment, that's going to be given by the radius r. So it's going to be r squared over 2, and then the that one is not given by him, it's given by this radius and then the segment there, isn't it? So it's going to be 4r squared over 2 alpha minus sine alpha. And number 2 is going to be who? R squared over 2 theta minus sine theta is what we have. So we're going to add them together to represent the segment. But of course, I don't know r and theta. So in the process of this question, obviously, that would give you the hints of these angle and all that, so you can sub it in. But the whole point of me bringing out this question is that, yes, we need to know the formula for the segment. And for the sector, yes, just to quickly remind you, please don't forget r squared over 2 theta, and then the arc length is going to be who? R theta. So you can describe this as a RL over 2 also. So for the circular measure, anything in the radian, we're very confident. And yes, for 3.8, it specifies that you must know the Pythagorean identity, so one way or the other, you must be able to use it. Okay, so for example, if you want to get sine and cosine using the given sign, obviously you can use calculator, but that's not the spirit of it. Spirit is that you're able to use the identity, right? So for example, for sine x given being negative 3 over 5, and look at this, this is in the fourth quadrant. So then only cosine is a positive. So for cosine x, it's going to be positive square root of 1 minus sine squared x using the Pythagorean identity. So it's going to be positive 4 over 5, right? And then, tangent is a sine over cosine. So tangent x is going to be simply 3 over 4, right? So make sure, however, you're right. It's in the fourth quadrant, so tangent must be negative, okay? So for this question is asking about whether you're aware of the Pythagorean identity, as well as that you are able to check whether it is going to be positive or negative depending on the quadrants, right? And yes, we're going to solve this equation, but however, I'm going to use calculator. But for that, yes, please remember, my friend, please check the domain, right? It says from 0 to 3 pi. Remember, we're dealing with the trigonometric function. Trigonometric function can have infinite many solutions, so it is therefore obviously going to define the domain. So we always must check the domain. It says from 0 to 3 pi. So what we're going to do is go to the calculator, and then we're going to graph things. And then, yes, let's put 2 cosine x. And then the next entry is going to be, what is it? Sine 2x. No problem, right? But we press menu 4-1. Please memorize menu 4-1, checking the domain. So I'm going to go from 0 to 3 pi. Right, then as you can see how many intersections we see quite a few. So we see 1, 2, 3. There are 3 intersections, so your solution should contain 3 of them, right? So if we do the analyze graph and find the intersection, boom, boom. So I got 1.57. You can do the same thing for the other 2. That's how you find it. So for periodic function, periodic equation, make sure you respect the domain. Okay. Yes, another identity problem, really. So for the first one, sine squared plus cosine squared, Pythagorean identity, that's going to be 3 plus 4 cosine squared x. Lovely, right? And if you want to describe just in terms of cosine, what do we need to do? Sure, I'm going to change the, 4 cosine squared minus 5. In this Pythagorean identity, replace the sine squared as a 1 minus cosine squared, and that's great. So it's going to be 9c squared minus 5. Right? You can try to simplify the other ones as possible, right? So that's great. So make sure this manual work by hands is also going to be tested. Okay, so even for the AI, so make sure you're aware of those identity problems, okay? Yes, and then let's go for the section 3.9 where it says that it's a affine transformation. So for affine transformation, I want you to know 4 things: translation matrix, dilation, enlargement, dilation, enlargement, so enlargement vector, matrix, rotation, and reflection, right? And it comes very handy if you know the trigonometry well. So I want to know the nature of a transformation. If you want to know the nature of a transformation, my friend, please use the determinant of the matrix. If it's 1, you know it's a rotation. If it's -1, it's a reflection, right? So make sure you understand that, right? So what I like to do here is, for my image, x prime, y prime, let's try to put into the matrix. It's going to be 1, 1, -1, 1, and I got the x and y. That's great. So let's try to see the nature of a transformation. It may be neither, right? But your best bet is just to apply the determinant and see if it gives you either positive or -1. Then it's very easy to analyze. So if it's going to be 1 minus -1, becomes nothing. Ha ha ha. Oh, no. So, yeah, sure. So, hold on. Oh, sorry. I forgot the 1 over square root of 2. My bad. So, it's going to be, what is it? Oops, sorry. So, I gotta multiply by the 1 over root 2 on each of them, isn't it? So, sorry. So, 1 over square root of 2, square root of 2, square root of 2, square root of 2 is what I have, my friend. So, if I get the determinant of that, you know, what you get there is that the product of square root of 2 is simply just half, isn't it? So half becomes 1. I'm very happy that's a rotation matrix. So you got the cosine theta being 1 over root 2. Sine theta, my friend, is a -1 over root 2. So the best way to get the angle is just to divide it, right? Then you get a tangent theta being -1. You know what? You can put this in the, in the calculator and use the inverse tangent. You can do that, but for me, I want you to be good at the trigonometry so that you know the special angle for tangent being 1 or -1 is determined by pi over 4. But then, sine is negative, cosine is positive. It should be in the 4th quadrant, right? So rotation is gonna be done by the angle -pi over 4. So I'm gonna say clockwise rotation by pi over 4. I'm gonna say clockwise rotation by pi over 4 around the center is what you're doing. Okay, that's great. So if I try to get, what is it, the nature of a matrix here, once again, I'm gonna get -5 over 13, 12 over 13, -12 over 13, -5 over 13 is my rotation matrix. And let's do the, what is it, determinant. And if I do the determinant, it becomes a positive 1, right? So again, this is a rotation matrix. And what do you have? Cosine theta is equal to -5 over 13. And then the sine theta, my friend, is -12 over 13. So if I do the rise over run again to get the tangent ratio, right? What you get there, my friend, is that boom, boom, I get tangent theta being 12 over 5. But please be careful. Here's very, very careful. You got to be very, very careful here, my friend. If you simply use the inverse tangent here, you're gonna get an acute angle. You're gonna get an acute angle. This is gonna be acute, my friend. This is gonna be acute. But as you can see, I need to make sure the tangent and sine and cosine, both of them are negative. Both of them are negative. So it must be in the 3rd quadrant. So if you do just inverse tangent, you wouldn't get that answer at all. So you got to be very careful that you understand that I need to rotate by, what is it, the 3rd quadrant there. So what I'm going to say is, so sure it's going to be clockwise, anti-clockwise, sorry, by the angle by pi plus the inverse tangent to represent that it's in the 3rd quadrant. And that is not possible to get using the inverse tangent, because inverse tangent ranges from -pi over 2 to pi over 2. It's going to only give you positive, negative acute angle. So this really comes in the understanding of, what is it, the trigonometry. It's very important that you understand that. Okay, sure, that's how you get it. So let's have a look at the next one. So for this one, I want to know the nature. What do you do? Try to do the determinant. So if I get the determinant of the first matrix, it's going to be 1 over root 2, 1 over root 2, 1 over root 2, -1 over root 2. Sure. So if I try to get the determinant of that, my friend, what do you get? I get the -1. Voila, that's a reflection. Then I need to know my what line am I reflecting of. I need to know his gradient. So for that, here cosine 2 theta, right, is 1 over root 2. Sine 2 theta, my friend, is 1 over root 2. Okay, that's lovely. That is lovely. So here, if I do the rise of a run, my friend, I get a tangent 2 theta becoming what? 1. So 2 theta must be pi over 4, right? Theta must be then pi over 8. That is great. Then the line of reflection is going to be tangent pi over 8x, for which you can use calculator to find the gradient, right? So make sure that we are able to, get the nature, and then also figure out what angle, what gradient of either rotation or reflection is going to be, okay? Sure, enlargement. So if I have a k, 0, 0, L, that's a stretching factor for horizontal k. That's a stretching factor L, vertical stretching factor, right? So it's going to, this is a circle equation, isn't it? And what we're doing here is I'm enlarging the x and y by a factor of 2 each. So I'm going to do the function transformation. If you want to enlarge by a factor of 2, you got to composite with the half, right? And then for the next one, it's going to be y over 2 minus 1 squared is equal to 9. So that's the new circle, right? That's going to be the new circle is what you're doing. Okay, that's great. And then, because everything got double, isn't it? Everything got double, my friend. So what you understand is that the radius was 3. So the radius got double. I'm sure now the new radius is going to be 6 because everything got double, right? So you need to understand what transformation we're doing, not only numerically, but you need to be able to explain, okay? So this is rather interesting, isn't it? Because if you look at it, sure, I got the enlargement factor 2, but what about negative 1? What does it do, right? So for that, you can just multiply. You can simply multiply what's going to happen for my x and y if I apply this transformation matrix. So let's do x and y. My initial x and y now gets changed as the following. Let's have a look what's going to happen. If I do the matrix multiplication, that's going to give you, what is it, 2x and negative y, my friend. And that's the one that I'm going to composite there, isn't it? So if I composite that, it becomes, so for the image, that's my new image, is now becoming 2x minus y. So then my x and y, what I'm going to composite is x prime over 2 negative y prime is what I'm going to composite with. So if I did on my equation here, what do you get? It's going to be 3x over 2 minus 2y prime is equal to 6. So if you multiply 2 on both sides, you end up getting 3x prime minus 4y prime is equal to 12. So that's going to be the new image. That's going to be another line equation, but different gradient is how you can explain things. So what you can do is transform your x and y, and then substitute your image on the initial function is what you can do. Okay. Oh yes, very, very famous. It's going to be one of the either paper 2 or paper 3 problem. Snowflake, Cox fractal, Cox snowflake, Cox curve, or snowflake is something to do with the affine transformation and also the sequence of series. So let's dive in. But before doing that, let me take a 5 and come back to you. Alright, let's have a look at this lovely problem with the fractal. It's a typical Cox snowflake, which can definitely be on the paper 2 or paper 3. Let's have a look at how this iteration and recursive relation can be described. So if I look at the expression for the length of the nth iterated curve, so if I draw a large triangle like this, right, and then as you can see, the next iteration is going to be making a smaller triangle like this. But as you can see, if I had a 1, right, this is a 1/3, but now I have a 2/3 of the curve. So each length, okay, is added by what is it? 1/3 of its initial value. Right, because it's instead of a 3 many 1/3, I have 1, 2, 3, 4 many 1/3, right? So now you all together, that's going to be, what is it, 4/3 of the initial value times the original. And then this process is going to be repeated for all the other sides as well. So now, as you can see, my common ratio for the length of the nth iterated line is going to be 4/3 to the power of n. So it's going to be the common ratio with the 4/3 is what we have. It says find the length of the curve as iterated infinitely many times. So if you do this infinitely many times, the length is a common ratio with a value that is bigger than 1. So it's gonna diverge, right? So that's great. If instead of starting with a line, you start with an equilateral triangle, and you get a cooked snowflake. So sure. And then find an expression for the number of the small sides after n iteration. So we're looking at the number of, number of small sides. Okay, so for that one, as you can see, we are adding, we had one line, but now have 4 lines, right? So then the next one is going to be 16 lines. So it's going to be, 4 to the power of n many lines. And then find the length of each side after the n iteration. So for that, we're gonna have how many length. So if I had that 4 many, I got 3 sides. So it's going to be 3 times for many of the sides here. So that's gonna be the, the length expression, for which if you do the parameter, it's going to be, the expression for the number of smaller sides. Oh, sure. So for a triangle, it should be 3 to the power of 4. So sorry, so the answer for this one is for part C, right? So number of smaller sides after n many expressions. So it's going to be 4 to the power of n. And for a triangle, because I got 3 sides, it's going to be 3 times 4 to the power of n. So that's the number. And then the next question is find the length of each side after n many. So I'm looking for the length. As you can see, this became 1/3. It became 1/3 after the iteration. So it is going to be progressed as a 1/3 to the power of n. It's going to get smaller and smaller. And if you want to figure out the parameter, now you're looking at the number of the sides with the length. It's going to be the product. So that's going to give you 3 times 4/3 to the power of n, for which you see that it's still got the common ratio that is bigger than 1. Hence the parameter is going to diverge. So parameter is going to diverge. Okay, find the number of smaller triangle, which is the missing one side. So for that one, except for the original triangle, okay, each side is made into 4 smaller sides, right? That is great. Each of which creates the triangle. So we have how many? So 3 times 4 to the power of n minus 1 many, because we are now getting rid of the original. And then the what we need to also realize is that the if you want to find the area, as you can see, all this everyone here is equilateral triangle, which has the same angle, hence they are similar. And then what you should realize is that the ratio factor for the length was 1/3. That means for the area, by the unit, by considering the unit, it's going to be 1/9. So for the next triangle, you're multiplying 1/9 on each cases, right? So for example, for what you need to do here is that the if we repeat this process, the area is going to be 1/9 for the common ratio. So 1/9 to the power of n is going to be the, the common ratio for my geometric sequence for the area, where we know that the first initial value with the unit length of 1, the formula for the equilateral triangle is √3/4, right? So then that's my initial value, right? And then times 1/9 to the power of n is the area, right? So if you want to find the total area of the series, is that I can put it into the infinite series, right? So for example, if you want to get the infinite series, what you can do here is now, okay, I got the first term, which is √3/4, and then what is it? The common ratio is now 1/9. So as you can see, this is an interesting shape because the perimeter diverges where the area converges. Okay, so also a very nice iteration problem with the affine transformation, especially with the paper 2 or paper 3. So if you're interested in going over it, please give it a try. Okay, and then question 118 talks about the, what is it? The combined transformation, hence the affine transformation. So what you need to do well is to create the matrix well. A is the reflection matrix, so we know that's given by cosine 2 theta, right? And then cosine 2 theta, sine 2 theta, sine 2 theta. However, make sure you put a negative on the sign, so it's going to be minus there, right? And then minus here, right? So that if you do the, determinant, you see that it's gonna be -1. So that's great. So on this, where do I get the angle? Is that by the reflection line y equal to tangent theta x. So the gradient here was 1, so the theta must be pi/4. If you plug those values in, what you realize is that it's going to be cosine pi/2, which is a 0, and sine pi/2 is 1, 1, 0 is what we've got. That's great. Okay, so that's your matrix A. And then your matrix B is going to be very similar, but it's a rotation matrix. So it's going to be cosine theta, sine theta, sine theta. And then I got to put the negative on the first here. So that if you do the determinant, it becomes +1. That's how you can verify. So now I'm going to put theta to be, what is it? Anticlockwise, a positive angle, pi/3. So if you plug it in, what you get is the, 1/2, negative √3/2, √3/2, and 1/2 is the matrix that we have. And now I want to do AB. So let's do A times B here, right? So then if you do the matrix multiplication, what you end up getting here is a √3/2, 1/2, 1/2, negative √3/2. So that's the AB, right? This is AB, and I want you to realize what you do, the first transformation you're imposing is the B, right? And then the A. So it's always the order goes to the left. So that's great. And then what the question says is that I got the A and B. Determine the nature of a composite transformation. So this is what we had, right? And then what you can do is you can get the determinant of this matrix, right? If you get the determinant of this matrix, then you can see whether it's going to be +1 or -1, and then decide what transformation has been done. If I do the determinant, I got -3/4 minus 1/4. That's -1. So it should be reflection. So then I have a cosine 2 theta being √3/2. Sine 2 theta is half. So what you want to do is you put the division on it. So tangent 2 theta is 1/3. So 2 theta is pi/6. So that's great. So theta is going to be pi/12. So that's lovely. So then I know that AB matrix altogether can be described as the reflection matrix by y is equal to tangent pi/12 x reflection. Right, so that's how you work with the, the rotation, to describe the composite transformation. And you can do the same thing for the BA. Okay, use matrices to explain why the order is generally important in the composition of a two linear. So yeah, then it's very likely that if you do the BA, it's going to give you a different reflection or or rotation depending on the nature of the determinant. But you will realize that it's going to be still the reflection, however different gradient. So the order matters is usually not commutative. And yes, remember determinant of A, B is the same as determinant of A times determinant of B. So for this one, the sign I think would be the same. However, the value inside and hence getting the angle will be different. So what you need to say here is, yes, the order matters because as you can see, if the order changes, even though it's the same reflection, the gradient of the reflection line changes. Okay, sure. So now I want to do the vertical stretch of a circle, which is going to generate an ellipse. And for that, what matrix do you have to multiply if it's a vertical scale? So 1005/3 for the vertical line, because it's going to only attack on the y value, isn't it? Then you can do that transformation here. So, it's going to be x and y. That's my new image, right? X prime, y prime is what you have. So it's going to be, what is it? X and 5/3y, right? So then you realize, okay, my x is going to be x prime, but my y is going to be, what is it? Substituted by 3/5 y prime, right? So then if you sub it in, you realize it's going to be x squared plus, what is it? 3/5 y squared is equal to 9, because it's a new image 9. Oh, sorry. So I should put the squared outside. So as you can see, that's going to be the new shape, which is going to be giving you an ellipse. Okay. So that is great. And then what you should realize is that the, you want to find the area of it. So for that, I get the area of a circle first, which is a pi r squared, which is pi times 9. I had 9 pi. And then what you do here is you get the determinant of whatever the enlargement factor that you were using. And then that's going to be the scale factor for your new area. So it's a 5/3. So we're going to multiply that onto the initial area. So it's going to be 5/3 times 9 pi for the newly changed area. So that's going to be 15 pi units squared is going to be our area. So make sure that if you want to get the area for the transformation matrix, get a determinant of your enlargement vector, get a scale factor, multiply that to the initial area. Okay? So that's great. Let's move into the 3.10, which is a vector. So yes, you need to know a lot of different operations, and yes, getting the unit vector and desired length is very important, because later on it's going to be used for the kinematics, right? So for part A, same direction with the length of 3 units. So you can convert that into the unit vector first. So 2, -1 should be divided by √5. And now I want the magnitude to be 3. That's how you get it. So this technique is going to be used for the velocity vector. So you make sure you know how to do it. So for 3D, it doesn't matter. -1, 4, 1. I'm going to divide it by my own length, which is a 16, 1, 1. That's 18. But I multiply 6 on top of it so that I get the desired length. So this method, again, is often used for finding the velocity vector. So if you simplify and then put it in each component, you get -√2, 4√2, √2 is what we have. So make sure you know how to get desired length. Vector line equation, sure, make sure that you know how to get the position vector and then the direction vector. Right, so sure, so for part A, if I put it in, so position vector, you can choose anyone. So 3, -1, 5, I'm going to use that for direction vector. I'm going to multiply by my arbitrary constant. So you get a direction vector by looking at their difference, right? So if I do so, it's going to be, if I do B minus A, that's going to be -4 to -3. That's my vector line equation. If you want to see if it's going to be on the line or not, you let this to be 0, 1, 5 for the position vector. And for example, making the the y component to be 1, you gotta let lambda to be 1, right? So that your y component is gonna be -1 plus 2, hence giving you 1. However, if you compare with the other component here, for example, for the x, if you do 3 minus 4, you get a -1, which isn't 0, you see. So I know it can't be on the line equation. So that's how you describe it. Okay, sure. Intersection, use a parametric form. You compare it with the x component, y component, etc. So for the x component, it's going to be 1 minus lambda, 7 plus 2 mu, and then what is it? Lambda is going to be 2 plus 2 mu, and for the z component, 5 plus 2 lambda is equal to 7 plus 3 mu. Okay, we got it. However, right, so if I solve it simultaneous for the x and y, you get the mu to be -2. Okay, if I got the mu to be -2, you can get the lambda as well. And that's going to be -2 also, right? Isn't it? Let me see. -2. Yeah. So we got that information from the first and second one, but you got to put into the third one as well, because sometimes it may not work for the third z component. That means it's going to be skew. But if you plug it in for the -2 on each, So that becomes, what is it, 1. That becomes 1 also. So yes, they do intersect. So you can use any of the parameter to find the coordinates. So if I use, for example, lambda to be -2 for the line equation here, it's going to be then giving you 3, -2, -2, 1. So that's going to be the point of intersection. So make sure you know how to solve it simultaneously, and also to see whether it's going to be skew or not, okay, by comparing with the z component as well. Okay, so sure, the vector form here, this is the parametric form, so that's okay. Okay, a different straight line. So sure, how can we show that this is going to be a different one? So, you got to indicate the position vector. It's going to be -5, -3, and 1. And then the direction vector is going to be what? 4, 4, 1. So as you can see clearly, the direction vector is not parallel because it's not same multiple. It's not constant multiple. So we know it's going to obviously represent a different line equation. Easy peasy, lemon squeezy. Okay, so now we want to. So for vector, it's always nicer if you can visualize a problem. So I've just visualized it for you of a line equation, and then this point, external point 1, 0, -2. How do I know it's going to be not on the line equation? Well, if you put x equal to 1, lambda has to be 1 for the first equation, but if you let lambda to be 1, then my y is 5, which is not true. So I know it is an external point. And so, and again, please make sure every time you have unknown coordinate on a line equation, do not use x, y, z, but try to use a parametric form. So it's going to be 2 minus lambda and 1 plus lambda. That's great. And then you use the distance formula between them. If I use the distance formula between the parametric form of a line equation and then give an external point, and then use the distance formula, it's going to be square root, my friend, is 1 minus lambda squared plus 3 plus 2 lambda squared plus lambda plus 3 squared, and that is given to be 5√3. And as you can see, you're going to get a quadratic equation, quite possibly giving you 2 values of lambda, because you can have a cases of isosceles triangle. So that can be a point, and that can be another point. That's still going to give you the same length of a 5√3. So make sure every time you have unknown coordinate, try to put into the parametric form. So if you solve the equation, you end up getting lambda to be 2 or -14/3. So that's lovely, because you can put now back into the parametric equation to get those 2 coordinates. Okay, so make sure unknown coordinate, parametric form, we move on. Okay, yes, as we already have done, if possible, then you find the intersection. The first thing you should check is whether they are parallel or not. If they are parallel, obviously that's not going to give you any solution or infinitely many solution if it's a coincidence. But not parallel doesn't mean that it's going to have always a solution. So you always have to double check. Okay, so for example, when we are working with the for part D, we look, you can let this x and y to be the same, right? And if you solve it simultaneously, right, you're gonna get lambda to be -5 and mu to be -2. You put that back into the z component and see yourself if it's gonna be the same or not. For the z here, it's gonna be 3 minus 10, that's -7. And for the z here, if I put -2, that's -5, minus 2, that's -7 as well. Okay, so then as you can see, yes, they do intersect, right? So if it doesn't, while being on parallel, that's gonna be skew, so you gotta be careful with those situations. Yes, this is a very important one. For the kinematic, you always have to respect the velocity vector. I got the speed, my friend, I got the direction, so you gotta now find the velocity vector by making the unit vector on the velocity. So, how do I make it the unit vector? You divide by its magnitude is square root of 4, 4, 1, that's √9, that's a 3, and then you multiply the speed. So that's the velocity vector. You multiply the time t, and then the initial location was 2, 0, 0, and that's your displacement vector. That's your the equation for the position vector of the airplanes at the time t. That's the displacement vector. So that's how you find it. But make sure you always remember, for the velocity vector, you got to think about 2 things: speed and the direction. Okay, sure, this is very important. There's a big difference between intersection and collision. So yes, for a line equation, imagine that you have that, and then imagine that I use another line equation, but not necessarily the same parameter. It doesn't matter, right? So for that, it may intersect at a different parameter. But for the collision, it must happen at the same time. And for things that are crossing in their path, does not necessarily happen at the same time, because one velocity might be slower than the other one, right? So for example, if you use the same method for finding the intersection, they intersect at, let's say, 3, negative 2, 7. So that's great. However, if you look at the parameter for solving those equations, t here would be given as 1. And then the lambda here will be given as, let's say, 2. But as you can see, it's not happen at the same time. That's not going to give you the same time t for them to be at the same location. So even though they do cross over the path, however, it does not happen at the same time, we say that it does not collide. So you need to distinguish the big difference between the intersection and then the collision, my friend. All right, another lovely problem with the modeling. But let me take a 5 and then come back to you. All right, let's have a look at the next question for the kinematics with the vector, right? So what we are given here is that I'm having a velocity vector given. So I'm very happy with that, right? And then for the AI, what's important is that you try to keep it short, right? And it's a very lengthy jet, student, pilot, flying, all that. Yes, it's important information, but what's more important is that it is something about the vector. So I need position vector, I need direction vector. That's what I care the most. Okay, and then what they are saying here is, yes, his initial position was 40 kilometer east, 16 kilometer north, and then the height was 4.5. So that will be the position, the position vectors. So it's gonna be 40, 16, and 4.5 plus t, and then the velocity vector negative 160, and negative 64, negative 12 is what I have for my displacement vector. That's great. So that's part A. It's being very kind, because it's got me the velocity vector already. I didn't have to change all the unit vector, all that jazz. That's great. And it says, given that the jet continues to fly in the same velocity, verify they will pass directly over the airport. So for kinematic questions, right, sometimes it will only require to have the same coordinates for 2 axes. For example, the same location on xy or yz or xz. So what I meant by that is that if you quickly visualize, right, aircraft is flying over it, right? So, and if it's flying over it, that it's going to have the same xy location. So it doesn't necessarily have to be the same for the z, which represents the height. So among the 3 components, you're gonna just equate the x and y component for the location of the the airport control center, where we will call it at the origin for the relative location to the airplane. So if you let that to be 0, then you end up having the same t value, which becomes a quarter, right? So if I have the same location for x and y at the same time, then it does mean that it does fly over the airport. So that's great. And it says, given that it continues to fly in the same velocity, so yeah, we already have done the B1. Find the time which it happens, we did that, so that's at the quarter. So if we convert that into the minutes, right, so that's gonna be 15, right? So we just have to go by 15 minutes further from the original time. So the original time started at 11, so we know it's going to be the 11:14. Okay, so that's great. So that's how we measure things on the part 2. So if you look at the part 3, calculate its height at that point. So what you need to do is that, I will plug the t now onto the z and see what height we get. So if you plug the quarter here, it becomes negative 3 plus 4.5. That makes 1.5. So it's a 1.5 kilometer above, right? So that's great. When Jack's aircraft is 3.3 kilometers above the ground, it continues to fly on the same bearing, but adjusts the angle of descent so that it will land at the port. Okay, so for a vector, it's always good to visualize, isn't it? So I'm visualizing its location. It's descending, and as control center is over there, and then at what time, if you go 15 minutes further, the height was how much? It was 1.4 kilometer, right? But it says that the 3.3 kilometers, so it's a way above, isn't it? At that time, for which I don't know, it's going to change the course of direction. so that it's actually going to go directly to the airport, is what they're saying. Okay, fair enough. Let's try to get it. So what you want to do then is what time it was, right? So and now you're going to change the z component of your velocity. Remember, you're changing now the z component of the velocity because the bearing on the xy plane didn't change. It's only the course of the direction that it descends. Okay, and for that, if we let now the z component to be, what is it, 3.3 kilometers, right? If you let 3.3 to be the same as the z component of that displacement vector, then you can get the time. So you get the 1/10 for the time. That's great. Okay, so when I have that, which you can convert it into the minutes by multiplying 60, so that's the 6 minutes after you change the direction. So from what is it, the 6 minute, right? And then how long did it take to go to the control center? Before it was 15 minutes, right? So now why am I getting all this minute is because you wanted to get the velocity component for your z. That the velocity is the distance over time. So now you got the distance here, which is a 3.3, and then you got the time duration, which is 9 minutes, but if you convert that into the decimal, that's going to be 0.15. So that's great because I can do now the rise over run. So I can do the 3.3 over 0.15, which gives you 22. However, it is descending, isn't it? So what you want to do is to give a sense of descending by putting a negative sign on it. So now the velocity vector for the descending, that goes directly to the what is it? Not above the control center, but to the center will be negative 22. Okay, so that's how you can figure out all those components. Make sure if it's component of the velocity, you follow the rise over run method, right? The distance over time. Okay, so that was what it was required for that section kinematics, right? And then let's go to the section 3.13, 13 here. So it's a dot product. Sure, we need to know how to find the angle, and it's defined to be modulus of A, modulus of B, and cosine theta. So what we are given here is that we are given the length, so 3√10, and then cosine 71 degree. You can put it on the calculator to find it. Okay, so if you do that, you roughly get 3.089. And what I want you to remember is that because it's a positive, then the angle has to be acute. We already know that, and that's how you can interpret the meaning of it, right? So if it's negative, we know it's going to be obtuse angle. Okay, it is not perpendicular because it's not 0. Given the AB are parallel, okay, find the modulus of A. Okay, so if they're parallel, right? What we know here is that the theta will be either 0 or pi, right? Because either going in that direction or the opposite direction, right, will still be considered parallel, right? But then now I got my dot product being negative, so it must be something with pi, isn't it? So what we can do here is modulus of A, modulus of B, cosine pi is what I have, is the dot product. And then dot product was negative 12, where this will be negative 1. And then B is a unit vector, is 1. So then modulus of A must be simply 12 units. Okay, so that's also another algebra. And yes, if you want to find the angle between the line equation, be my guest, you need to compare with the direction vector, isn't it? But because of the difference with, depending on the multiple of lambda, you can have acute or obtuse. We don't want to confuse nobody. So what you do is cosine theta, put absolute value on the direction vector, right? And then do the dot product, and divide by its magnitude. That it is what it is, right? So that's what we're gonna do. Over the magnitude is what we can do, right? So make sure you put an absolute value on top of it because you don't want to have an obtuse angle. We always try to get the acute angle for the line equation again because it's confusing with the direction vector can be negative multiple. Doesn't matter. So if you put it in your calculator, you're gonna get 81.8 degree. Okay, so make sure if you want to compare the that the angle between line equations is always about the direction vector. So that's great. I find the vector perpendicular to both of them, it's indirectly telling you to do the cross product, right? So 2, -3, 1, cross product, 1, -1, 3. Okay. And then I'm going to do the normal vector, I, J, K, 2, -3, 1, 1, -1, 3 is what we have. And then what we're going to do is a column row. That's great. Okay. And let's do it. So I is going to be -9 plus 1 minus j. Make sure that it's always alternating. And I get rid of another column here. So it's going to be 6 minus 1 plus k is what we have. That is great. And then we're going to have, what is it? -2 plus 3 is what we have. And we end up having then -8 and -5 and 1 is what we have. And if you want to verify whether you have done correctly or not, and I suggest that you always try to check, this is supposed to be a vector that is perpendicular to both of them. So if you perform the dot product on any of them, it should give you 0. So if you quickly check, -16 plus 15 plus 1 does become 0. I'm very happy this is my normal vector. So do not just compute, please verify, especially the cross product, because it's very common to make mistake. Okay. Yes, area, what is it? You get the magnitude of the cross product, you halfen it, that's how you get it, right? So for example, if I want to get the area of a triangle on the part A, what you got to do is that you got to get AB vector, which is going to be 2, 2, -1, and then you do the AC vector, which is -1, 2, -3, and then you get a cross product first, which then you get the -4, 7, 6. That's great. And now you get the magnitude of it to find the area. So if I do the magnitude here, what you get here is that it's going to be square root of a 16, 49, 36. It becomes square root of 101. That's great. And then for the area of a triangle, I'm going to halfen it. So half of 101 square root is going to be my area of a triangle. So that is very lovely. Okay, so make sure cross product can be used for area and also volume sometimes, right? The parallelepiped is also a very common question, so make sure you know how to work with them, okay? Yes, a vector component, you just have to know the formula really, okay? So make sure that we are able to use dot product or cross product to find the components, okay? And if I quickly give you the component of A in the direction of B, the formula will be then A dot B modulus of A. It's relative to B, so that's the component of the A in the direction of B. And then another formula for the perpendicular to B was the the modulus of A cross B over modulus of B is what we do. So if you quickly check them out, right, the dot product is simply 5 simply 0. Yeah, it will be simply then whatever the magnitude is going to be 0. Okay, that's great. If you try to get the cross product, you get the 1, 11, 16. Okay, and then you get a magnitude of B, which is the root square root is 27. So if you work it out, it's going to be square root 14. So that's going to be the component of A that is perpendicular to B. Okay, so you need to always make sure that you know this formula. Okay, the direction or the perpendicular is just to check whether you know the formula or not. Okay, for the graph theory, I really didn't have time to draw them, so maybe in another chance I will try to go over it. But let me quickly move over to topic 4, which is the most important topic for you. Okay, but let me take a 5 and then come back to you. All right, let's move on to topic 4. So it's just to quickly check your sampling technique for the statistics. So let's have a look. The professor wanted to select 20 students from his class of 300 students to collect detailed information on their profile. He uses his knowledge and expertise to select these 20 students. Is this sample random or non-random? I think it's non-random because he's using his knowledge and expertise to select 20. So it's not choosing randomly. He's using his experience to choose certain people. So it's definitely non-random, right? In this is this an SRS? So for this one, systematic sample, certified, convenience, or judgment sample. So I think it's going to be a judgment sample, isn't it? Because not JavaScript, but judgment sample, because he's judging based on his knowledge, right? So, and then for part C, what kind of error if there would be any kind of sample? So, well, because if you think about it, right, he's choosing certain people based on his preference, right? So I don't think this can be represented for the general, right, public. So this is going to lacking the generality. So that is great. So let's have a look at the part D. Suppose a professor enters the name of all students enrolled in his class on a computer. He then selects a sample of 20 students at random using the statistical software package. Explain whether the sample is random or non-random. And this is going to be random because computer is going to do the random, right? So random. So that is great. So for part E, what kind of sample this is? This is going to be simple random, right? So simple random sample technique. Do you think any error will be made in this case? Well, we might still have the difference in the, well, it is still selected by the, from the choice of the teachers, right? It's not the computer chose everyone at random. It was already filtered, right? So it's still not going to represent the general public. Okay, so you need to know what it means by the random sampling and give actual justification. And for that, it's not that bad, because if you think logically, then the answer is already there, right? So it's not something of a computation, but it's purely just, justification style problem. Yes, 138. Let's have a look. So 1,000 people, I got the percentage, and then what we did was that I got this sorted out. I got sorted out people to survey, and then that's obviously going to be stratified. It's going to be stratified sampling, right? Because we are using the probability on the from the probability from the population. Now I chose a sample and I tried to sort based on the probability. That will be the stratified sampling. So that is great. Okay, let's have a look at the next one. So if you quickly read by pausing, pause the video and quickly read, and then it says opinion poll is to be given a sample of 90 members to a local gym. The members are first divided into men and women, and then simple random sample 45, separate sample 45 taken on sampling method. So what sampling method have been taken? And it's going to be random quota, right? Because we're giving the quotation to each man and woman, right? So within each gender, individuals are chosen randomly, so that's going to be the quota sample. Okay, so make sure you know how to sort of explain, and it's just that you need to be aware of those terms. What's a stratified, what's a quota, what's non-random, random, things like that. You have to give those names. Yes, the reason I got this cumulative frequency, that you should know how to find the median, right? So 220. So it's going to happen at 110, but not the y value, but then the x value is going to be your median. But the reason I got this picture is because I want to specifically remind you that if the question asks about the middle half, my friend, that's another way of saying interquartile range. Okay, make sure if the question says middle half, that's not median. Okay, that's not in the middle, it's the middle half of it. So that's the difference between the third quartile and then the first quartile. So make sure, from 220, you multiply quarter. What is it? That's a 55, isn't it? Is it? Yes. And 55 should be around there, right? And then 165 is around there. You find their first quartile, third quartile, find their difference. So this is another fancy way of saying interquartile range. I don't want you to forget. That's it. That's all I gotta say. And yes, for the whisker plot, sure, you know what it means by the, minimum, first quartile, median, maximum, and then the, sorry, my bad, minimum, first quartile, median, third quartile, and then the maximum, right? And then you should know how to get the outlier bounds by using the interquartile range. But then the one thing that I wanted to mention is that, sure, you can easily get them, right? So if I get the for example, year 9, if I just zoom in for you, right, you can zoom in your document as well. You can easily find those values. So let me quickly find the year 9 for you. So 6, 30, 45, 60, 70. And then year 12 is going to be 36, 60, 84, 96, 105 is what we have. And then yes, interquartile range, you can easily find it. But, not only that, sometimes you need to interpret, what I mean by that is you need to know, okay, so now we have these values, how are we going to use it is what the question can be. Determine whether the following statements are true or false. On average, year 2 student spends about twice as much time on homework, right? We want to know if it's true or false. And what do you think? Well, I don't know, right? I don't know about the double the time, right? So we cannot tell. So we don't know the average. We can only figure out the order, such as the median, third quartile, first quartile, things like that. So we cannot tell, right? Over 25% of the year 9 students spend less time on homework than all the 9. For that one, yes, right? Because the lower quartile for the year 9 students is much smaller than the minimum value of the year 12 students. So in that representation, right, we can say over 25%, okay? So that's great. And yes, another thing that I want to remind you here, my friend, is that, whenever you have descriptive statistics, so there are two things that I want you to remember. Expected value is sure it's going to be the sum of samples divided by the number of samples. And for the variance, I want you to remember two things, my friend. The definition is, yes, it's average area of a square, isn't it? However, if you have this sort of a simultaneous equation, you got to use the alternative. So sum of the sample squared over n minus the average square. So you got to use this one, my friend, to solve things simultaneously. So if you look at the part A and part B, so if you try to solve part A, yes, 1 plus 3 all the way up to P plus Q over 8 is the average. And then for the second one, so I the P and Q are missing, 2 parameters missing. I need 2 equations for that, right? And if you look at it, so it's going to be 1 squared, 3 squared going all the way up to P squared plus Q squared over 8 minus 5 squared. That is 5.25. So make sure you're able to work this, simultaneous equation sort of a technique for two unknown parameters, right? And it's going to be just quadratic equation if you think about it. It's going to be just a quadratic equation. And because, it looks very likely it's going to be, but it says integers, so it's going to be factorizable. So if you try to solve it, it's going to be P is equal to 6, Q is going to be 9. So make sure you know this formula to solve them simultaneously. So that is great. And sure, the reason I got this picture is that, so yeah, sure, it's a cumulative 92. And the frequency is 52 here, and then cumulative frequency here. So I just have to add this, so it's going to be 144. So that's great. However, the reason I said you want to find the mean is that you got to tack on the median, right? So 15, 19. What are you going to do? 17, 21, and 24, and 33, and use those values with the frequency to find the one variable stats, right, in the descriptive stats. So that's okay. And then the reason I got 143 is that we want to do the algebra of expected value and variance. Make sure that E of AX plus B is A times E of X plus B, and the variance of AX plus B, my friend, will be A squared variance of X. Okay, and so and also I got the total sum, I got the number of samples, so the average is going to be 25.2. You should be able to tell that. But for example, if I have additional 5, that's X plus 5, isn't it? So the average is going to be increased by 30.2. However, standard deviation is going to remain unchanged, right? Because the adding doesn't change the spreadness. Okay, only the multiple does. So, and if you look at the week 3, right, it says 5% less. So we are multiplying 0.95, right? And then for the variance, it's going to be 0.95 squared times 25, because the standard deviation was given as 5, okay? Make sure you understand that. Sure, the bivariate statistic, yes, you know, the linear regression, please know how to do it, right? So we just have to, you know, create the column on the calculator, right? And then press menu, you know, go to stat calculation, and then here you can choose, you know, mx plus b, sorry, c, or, you know, a plus bx, doesn't matter, you can choose whatever you want. And then the correlation coefficient is going to be r, not r squared, that's the coefficient of determination. There's a big difference, my friend. Okay, anyways, sure, and then what does it say? Explain why your regression line cannot be used to estimate the income of the day 14. Okay, that's great, right? So because, you know, you got the data like that, but anything within the data will be called interpolation. But anything off the data will be considered extrapolation. Right? So if you think about 14 degree, it is the extrapolation because it's far less than the given data. And so you're going to say it's not going to be as accurate as we hope because it's extrapolation. You got to give those names whenever you are trying to give the statistical analysis. Let's go to section 4.6. Our favorite is the probability. You need to know all the laws. You need to know, you know, what is it? The additional law, complement, intersection, independent, etc. So, you know, for example, here, if you want to find probability of V, it's very likely, it's got a bunch of conditional probability, isn't it? So it's very likely that it's going to use the law of total probability. So if I got the probability of C by using the law of total probability, you know it's going to be probability of C and D, or probability of C and D prime. And then the way we can describe the intersection is that it's going to be probability of D given C times probability of C. Maybe it was better to do probability of D, my bad, right? Sorry. Yeah, we do the law of total probability on D. So probability of D and C, or probability of D and C prime is what we have. That's great. And then you can convert them into conditional probability. It's going to be probability of D given C times probability of C plus probability of D given C prime times probability of C prime is what we have. That is great. And then D given C is a quarter, and C was a 9/20. That is a great. And then, you know, D given C prime is a 1/5 times probability of C prime will be, what is it? 11/20. So adding all that will give you the probability of the easy peasy lemon squeezy. Okay, so if you quickly simplify, you get it. Okay, but the thing is, you know, now it's asking for the independence. For the independence, you know, I want you to remember two things. Yes, you know, the very common one is if independent, then, okay, the product. I mean, it's vice versa. If the product, then yes, it's gonna be the if that product implies intersection, that's also meaning independence, if and only if. However, another definition is, yes, B, probability of A given B, A does not care whether B happens or not because it is acting independent. It's going to be probability of A is what we're expecting. So what I'm suggesting here is, you know, the probability of D given C, if they were independent, should be probability of D as well. But if you actually compute this, you will realize it's not quarters, it's not independent. So you don't necessarily always have to use this product method for proving independence. You should be aware of this conditional probability method as well, which is a lot quicker, okay, if you have that information. So please use that. Okay, let's have a look at the next one. So sure, you know, this is what I'm talking about. If they're independent, I don't care about the conditional probability. It's going to be the same as the probability of A. This is going to be the same as the probability of B. That's lovely. And as soon as I see the union, what is urging us to do is additional law, right? So it's going to be probability of A, probability of B prime, minus probability of A intersection B prime is what we have. That's great. And I want you to remember that, you know, A and B prime is given there, so it's a quarter. And then 3/5 minus, remember, it's intersection. So what we're going to do here is to use it as a product. So 1/4 times 3/5. And yes, if A and B are independent, their complements are independent. A prime B, A and B prime, A prime B prime, they're all independent. So I can simply use the product principle here again because we were given A and B were independent, okay? Then the question is solved, okay? So it's easy peasy, lemon squeezy. Also very lovely problem here. So the part A, I will leave it to you. You know, so you know, for this one, yes, you will use additional law. For this is a pure part of B. So this is going to be probability of B minus the intersection. So make sure you know how to convert things with the complements or union, okay? All right, so then let's get it. So I want to get the probability of A. I want to get the probability of A. All right, and you know what? Sometimes, if they're giving you this formula, so I should use it, isn't it? So on the union part here, I'm going to replace that as a probability of A plus a probability of A prime and B is what I have. That's on the left, okay? That's same as a 4 over 9. So that's great. Okay, and then I'm trying to get the A. All right, and then maybe I should try to use one of that with that condition, with that intersection. But as you know, intersection is going to be same as the probability of, this is going to be same as the probability of B given A prime times probability of A prime, right? So that by the conditional probability. So if A is what I'm looking for, I'm going to call that as X. And then that intersection will be described as a probability of B given A prime, which is given as a 1 over 6. And A prime is a 1 minus X, that's great, is equal to 4 over 9. So if you solve that linear equation, you end up getting X being just 1 over 3 is what I have. So that's great. And then you can use this probability to get the B also, because now you can use the law of total probability, isn't it? Because, you have this is a probability of B given A times probability of A plus probability of B given A prime times probability of A prime by using the law of total probability. So that is very lovely because it's 1 over 3 and 1 over 3 plus 1 over 6 times 2 over 3. That's it. So if we just work it out, it becomes 2 over 9. So make sure you're able to convert those law of probability fairly quickly. Okay, so another thing about the discrete random variable that is going to have either 3 cases, right? 3 major distribution that you have to be aware for the discrete random variable. One, the simplest yet could be most challenging is the table form, because it doesn't have any rule, right? For the binomial or Poisson, it always has a rule, right? So we can use the formula, but for the table form, maybe sometimes, or most of the time for the exam question for that matter, you have to create the distribution. You have to figure out the probability. So let's have a look at this, on the gaming problem with the fairness. Okay, let's have a look. So there's an entrance fee on the $N. He then selects a one number from 1 to 3, 4, rolls 3 standard dice. If chosen number appears on all 3 dice, he wins the 4 times his entrance fee. All right, that's a big win. If numbers appear on exactly 2 of the die, he wins it 3 times. Okay, so let's have a look at the profit. Okay, what is it? He wins how much? 4 times his entrance fee. Right? He wins 4 times his entrance fee. But however, I want you to remember that it's not going to be 4n, because he needs to pay for the bill for the entrance. So it's going to be 4n minus n. So it's going to be profit over 3n, isn't it? And for that probability, it's going to be, probability of having exactly same number 3 times, right? 3 dices, all number. So 3 numbers. That's going to be how many out of how many numbers? 4, so it's going to be 1 over 4 cubic. So that's 1 over 64. So that's great. And now what about 2n, right? So for 2n, I need to have how much? I need to have his number exactly 2 of the dice. He wins 3 times. So yes, that's going to be 3n minus n, right? Because you got to pay for the entrance fee. So for that, I need to have, probability of 2 numbers. So, it's actually binomial distribution, isn't it, if you think about it? So what I want to do here is 3 attempts, right? So 3 choose 2. And then what do I do? Success, I want to happen 2 times. Failure, I happen 1 times. So that's going to be 3 times 3 over 4 times 1 over 16. So it's going to be 9 over 64. So it's going to be, yes, the binomial distribution. So if you want exactly win $1, but it's going to be, the profit is actually going to be 1 minus n, isn't it? Because you got to pay for the entrance fee, and it's going to be having just the one number. It's going to be then x equal to 1. So it's going to be 3 choose 1, and 1 over 4 happens only once, 3 over 4 happens twice. So if you put that in the calculator, you're going to get 27 over 64. So that's why we have that probability. So then, you got all the rest. So 9 over 64, and 1 over 64. So if you add all this probability, should end up being 1, so the rest is automatic, right? So we got those probabilities. So that's great. And if you want to get the expected value, as you know, for the discrete random variable, it's the sum of the product of the random variable and then the probability. So if you do that, you get 27 minus 33n over 64. That's lovely. Okay. And then now look at this. Game organizer wants to make profit. Remember, this is the modeling for the player. This is a profit for the player, you see. If organizer wants to make profit, the player needs to lose, and his expected value needs to start becoming negative. It is what you're going to solve it. So you really have to be in the context. You're not talking about the winning for the player, but losing for the player so that the organizer is winning. And then if you solve it, then n is going to be bigger than 0.818, so that yes, the minimum entrance fee, we should charge it as 82 cents. Okay, so that's how we're going to charge it. So make sure if it's talking about the fairness, the expected value being 0. If he wants to make profit, expected value has to be positive. However, this game was for the gamer, not for the organizer. It was for the player. Hence, negative expected value for the player will be the positive expected value for the organizer. So you have to translate that a bit, right? So very lovely problem. So whenever you have this table form, you got to be aware, because it can be more challenging than the typical distribution we do, because binomial Poisson's got rules. But for the table one, often it doesn't have rules, so we have to create one. Okay, sure. So yes, the binomial distribution is very important, isn't it? And make sure that you are always keen, okay, on defining your random variable. I always want you to count always define what you're counting. So if you look at part A, I want you to read this question carefully, okay? Let's read the question carefully. When you look at it, all right, I want you to know that we are counting, number of a problem guessing, okay? It's so important you define the random variable, because depending on what you're counting, the distribution can change. It's just like function, when you're dealing with logarithmic function or polynomial function, obviously the domains are different, right? You gotta define differently. And here I'm gonna say yes, even though the question doesn't tell you, binomial is the only distribution. They don't tell you that it's distributed binomially, but that's kind of a paradoxical, because then you will realize, oh, it must be something with the binomial. Well, it is, because we got the fixed number of trial, right? And I got the fixed probability of success, because I got the 4 choices. I'm guessing one of the choices is going to be a quarter. So that is a great. Okay. And then, then you can use, calculator to find it. So for example, more than 10 correct. More than 10 correct. Let's get this probability. So for that, it's going to be CDF, isn't it? Because it's involving inequality. Probability of X bigger than 10. But for me, we need to grow accustomed to use the less than equal to, because the calculator is programmed for the CDF. So it's going to be 1 minus probability of X less than equal to 10. That's lovely. So let's try to use our calculator for that. I'm going to go to distribution and scroll down. Binomial CDF 20 quarter. And then 10. Okay, so I'm going to subtract it from 1. All right. So that is my probability. So obviously, being able to guess more than 10 is very unlikely. So 0.00394 is my 3 significant figure binomial 20. Yeah, that sounds great. But I don't want you to be fooled by this question. So look at this, probability of X bigger than or equal to 10. For that one, you got to be slightly careful, because the opposite case will be 1 minus probability of X less than 10. But for the calculator, my friend, for the discrete random variable, you got to do probability of X less than or equal to 9. So make sure that is not the same between the discrete and the continuous. Okay, we got it, right? And then the mean and standard deviation for the binomial, make sure the expected value of the binomial is NP. So that would be simply 5. And then variance of the binomial distribution is NPQ, where Q stands for the failure. So 20, quarter, and 3 over 4 is what we have. So that 5, that's going to be 15 over 4 is what we have. That's the variance. That's great. Okay, and then obviously you can put a square root to find the standard deviation. I ask you to do it. But if you look at the part C, this is very important because I want you to read the C quickly. Pause the video, read over the C, and tell me what you think about. You're right. If you look at C, my friend, you see, so suppose that 5 students guess the answer to the test. What is the probability that at least 2 of them? I am not counting, my friend. I'm not counting the number of questions guessed. But what am I counting? You're absolutely right. I'm counting the number of students. So it's very important because then I need to assign the different random variable for the maybe possibly different distribution. But luckily, this is a discrete random variable with a fixed number of trial. I got the 5 students only. Okay, that's lovely. On top of that, my friend, I am not choosing the student randomly. I'm only trying to choose a student, what is it, that have guessed more than 10 answers, right, correctly, which is coming from the random variable x, and which we already have got it from the previous question. So that is a mixed distribution, mixed random variable. So yes, binomial, the probability of success can come from the another distribution. Like this time, it came from the binomial, it can come from the normal, it can come from the Poisson. So it's a very popular sort of a type of question. So for that, you always should try to define the random variable differently. Okay, so that's my binomial distribution. That's great. And then I want to do, what is it? At least 2. So I'm going to put probability of y bigger than or equal to 2 is what you have. And it's a very good example to demonstrate that it's important to indicate CDF correctly. So it's going to be 1 minus probability of y less than 2. For my calculator, I'm going to do probability of y less than or equal to 1 is what I'm going to do. And so sure, let's go to binomial distribution once again. Binomial CDF, my friend, but in this time, the fixed number of trial changed. The probability of success also changed because I'm dealing with the different random variable. My upper bound, I'm going to put it as a 1, and I'm going to subtract from 1 or again to get this 0.000154. And if you think about, choosing more than 2 students, at least 2 students who have guessed 10 questions correctly, is it very likely? Of course, it's very unlikely, right? So then, yes, having the small probability seems reasonable. And also, when you're solving probability questions, yes, thinking like that is important. You need to consider, okay, am I doing a good job? In this situation, is that likely? If it's unlikely, you're expecting probability to be very small. If it's not, then some computation must have an error. So make sure that you're willing to change that. Okay, that's great. So let's move on to the section 4.9, which is normal distribution. So for the normal distribution, what I want to remind you, my friend, is yes, often it's always using the calculator, right? But then sometimes you use the symmetry. And also using the symmetry, I want you to remember, my friend, if it's a 1 sigma away, that's a 68%, right? If it's a 2 sigma away, that's a 95%. If it's a 3 sigma away, that's a 99%. I want you to remember that. And yes, for the normal distribution, every time, if you're given the mean, just right in the middle, right? The median is the mean because it's symmetric. And it says 87 to 103. Okay, so that's how much a sigma away. That's a 1 sigma away. That's a 95 plus 8. That's 95 plus 8. Oh, sorry, that's minus 8 here, right? It's a 1 sigma away. I don't even need a calculator for it because I know it's going to be, 68%, because that's the property of a normal distribution. No matter what the mu or sigma is, because of its nature, if it's 1 sigma away, it's going to be 68%. So I'm very happy with that. Okay, if I do 103 and 111, right, 103 to 111, that's 2 sigma away, because that's a 95 plus 2 times 8, right? Yes, it is. So that's great. So it's that probability. So then if it had been 1 sigma away, half of that was a 34, right? If it was 2 sigma away, that's 95 divided by 2 gives you roughly 47.5, isn't it? So if you subtract from 34, then you get 15.5, easy, right? So make sure you are able to work with this 1, 2, or 3 sigma away quickly using the symmetry. And yes, the question can give you like this, for this one, I don't think it's possible to use a calculator, but only rely on the symmetry. So let's try to use the symmetry here. So if I've got that, right, and in a Bell's curve, I will instantly write the mu there. That's great. And if it's less than x, let me put the x here, and then the probability here was given k, right? So the marginal error here is going to be, what is it? The mu minus x. So that's the gap that I would do to find the symmetry. And if you look at the 2 mu minus x, that's actually mu minus x further to the right from the mean. So it's actually symmetric. So this is going to also give you the k. Well, that's lovely, because now if you get CDF less than or equal to, you just have to subtract from 1. So it's going to be the same as a 1 minus k. So make sure you are able to sketch the curve and try to get the marginal error, and then try to use the symmetry. Okay, that's great. And also, yeah, property of what is it? The normal distribution, median, mean, it's just the same, so it's gonna be 1. That's it. And yes, this is also another exam problem, but also uses symmetry, doesn't it? So make sure that you're trying to draw the Bell's curve in the middle, the average. That's great. Minus 5. As the marginal error is 5 here. Its probability less than is a 0.2. That is great. And then what do you do? A mu plus 5 will be then 0.2 as well by the symmetry. And for this conditional probability, I can change that as a probability of x less than mu plus 5 intersecting x bigger than mu minus 5 over probability of who? X bigger than mu minus 5 is what we have. If you look at the numerator, it's in between, right? Because it's less than mu plus 5, bigger than mu minus 5. So that's the 0.4. So if you subtract from 1, that's going to be 0.6. All right? And it says bigger than mu minus 5, that's a 0.8. Okay, so if you try to find the common factor of 0.2, so 3 over 4 is what we have. So yes, one of those things, even if you can use calculator, you wouldn't be able to use calculator because we need to use these type of symmetry, okay? Sure, that's sort of a summary for the normal distribution. Let's continue more on the statistic, but let me take a 5 and then come back to you. All right, let's have a look at the next question here. So sure, we are working with the, the bivariate with the PMCC. So I'm sure that you're able to find the PMCC correctly by using the data. But, for the Spearman, yes, that we need to rank all those values, right? So that means we need to know who's going to be the first, who's going to be the second, all that, right? So for the area, the first value is going to be the least value, so 2.3. And 2.8, 3.3, 4.4, 4.3, sorry, 5, 5th, 6th, 7, 8th, 9th, 10th, 11, 12 is what we have. That's great. And let's have a look at the number of maple trees. So that one is first is a 17. 18, 24, so third, fourth, fifth, and sixth, seventh, and yes, this is a very important example. If you look at 32, that's same order, so that will accompany the 8th and 9th. So we got to put the average value on that. So 8.5. 8.5, that's lovely, right? So that's great. And then we move on to the 10th right away. So 10th, 11th, and that's it, right? So 37 would, 11 will be the, 37 will be the 11th and 12th. So now you're doing the regression on this ranking. You're now doing the regression on the ranking. So if you, for the rank data to the regression, you're gonna get Spearman's rank is going to be approximately 0.970, right? So that's great. Scary to explain why you expect PMCC and Spearman's coefficient to have a similar value. Yeah, because, there are positive linear correlation scatter diagram of the raw data. So we will see that it's going to be very similar, right? So ranking, Spearman's rank, why do we do it? It's not to check the linear progression. It's to check the monotonicity, whether it's increasing or decreasing. For the regression, it may be non-linear as well, but we just want to check the monotonicity. But if it's a strong positive linear, it is going to be linear and increasing. So it's going to be giving both satisfactory result to the PMCC and Spearman's rank data. So please know how to rank them, especially for this redundant data. You got to find their average, okay? That's great. And yes, our favorite is going to be working with the hypothesis test. So for this, the wingspan of a species butterfly is known to be normally distributed. All right. With the mean 10 centimeter and standard deviation 1. Okay, so both are the mu and sigma is given. I'm very happy. And the geologist that he says that he may have found a new subspecies with a larger wingspan. Okay, so then, you know, why am I emphasizing that word? Because it implies that it's going to be one-tailed test. It's going to be a right tail because it's going to be something bigger. So of these, you know, statistic questions here, what you have to be very keen on is that you spot which test you should do, whether you should do the two-tail or one-tail for your alternative, okay? The mean of sample of 6, so sample size is given, so that's going to be the static, right? And then the test scientist's suspicion is that the 5% level of significance, so that's great. So let's try to, you know, if you make the hypothesis, it's always about the alternative and null. So null hypothesis is always something unchanged. So I'm gonna call the mu has not changed. So it's going to be, what is it? Still a 10. And now what are we saying? The alternative is going to be the bigger, right? Because it was a wingspan was bigger. So I'm gonna say mu is now bigger than 10 is what I'm saying. Okay, so for that one, it's always good to visualize. Right, so what you're looking at here is the p-value will be to the right, because it's the right test. So that's great. So let's try to figure out. So for the distribution, you know, what you need to do here is that the x is now distributed normally of, what is it, 10 and 1/6 was the, what was it? That was the, sorry, of 1. That was for the population, right? But for the sample mean now will be distributed 10, and also, what is it? It's got the sample size of 6, so it's going to be 1/6. So your standard deviation will be 1/6. That's great. Okay, so, you know, what you're trying to get is a probability of now x bar bigger than, what is it? The 11.2 is what you're trying to get. And let's see what probability we're going to get. So if I quickly check for you, normal distribution, right? CDF -1000, comma 11.2, comma 10, comma 1/6. Sure. So then I subtract from 1. That is great. So that gets me 0.00164, which is what is it, less than 0.05, because that was a level of significance, wasn't it? And your p-value is smaller than the alpha, so that means there's enough evidence that we reject the null, right? So there's evidence that the mean wingspan of this butterfly is going to be bigger. Okay. So, you know, what we typically do is try to use the p-value to make decision. And yes, you know, I don't need to maybe perform all that normal distribution. If you can simply just go to menu, statistics, stat test. Let's try to use the Z test. And for that, I'm going to use stats. Okay. And for here, our initial mean was a 10 and sigma was 1. And then, what is it? The x bar here was given as the average mean was 11.2. And then for the n, I'm going to choose n. And it was a right tail, wasn't it? So if I do that, then p-value is going to be the same. It's going to be 0.00164, which we already have got. So you can use that as well, right, for the hypothesis testing. And so let's have a look at the second hypothesis. The first one was the normal distribution. For this one, if you read, pause the video, if you read, what is the alternative? Sorry, what would be the hypothesis? Yes, we're checking on the proportion. Independent, so, you know, then you got a sense that it's going to be very much like a binomial distribution, because that's that it requires independent trial from the Bernoulli trial. Okay, what set of hypotheses should polling agents consider if they are only interested in increase? Okay, so I think what they're talking about here is for the alternative hypothesis, I looking at one tail or two tail? So for this one, sure, my null, it would be, yes, it did not change. The proportion is going to be 0.42. But then the alternative is going to be what? It's increased, so proportion got bigger. So that's going to be, what is it? The right tail. But if it's any change, that means it's not the same. It's not the same, so you got to put the not equal to. So that's going to be two tail is what we are doing. Okay, so that's great. Okay, so that's just to ask you to have an eye where it's going to be, what is it? Setting up the correct alternative hypothesis. Yes, the chi-square test for the independence, you just have to do the two-way test, right? So that's it. So you just want to create the matrix of that and ask calculator to solve it. And but if you were to do this manually, right? So because it's talking about the independence, what you you need to get not only the observed frequency, you also need to get an expected frequency, right? So what's going to be the expected frequency? Instead of writing the A, what you need to do is onto 120, you got to multiply those independent probability, which is coming out of these values here, right? So that's going to be 32 over 120, and then 42 over 120. So that's how you get the the expected frequency on that table. But what we can do is a two-way test on the calculator right away. So all you got to do is just create the right matrix. So if I quickly create the matrix for you, it's going to be 3 by 3. Okay, and then let's put the observed frequency here. So I'm going to put 8, 6, 18, 13, 8, 23, 21, savage, 7, 16. So I'm going to, store this. Okay, I'm going to store this to an alphabet A. So whatever I do, whatever I put number, if I press A again, it's going to return. That's lovely. And what we're going to do here is to go to, menu, and then go to stat test. So two-way test is going to be checking with your independence, and for that I can put the A, the observed matrix. That's it. If you do that, it gives you not only the degree of freedom, it gives you the static and p-value. P-value is 25%. It's more than enough. Very good. There's not enough evidence to reject the null hypothesis is what we're gonna say. Okay. So two ways of checking this data. P-value very, very high, so 25%. It's very good for the null hypothesis. So it's not significant. So no reason to reject the null hypothesis. Or if you look at the static, the chi-square static, it's a 5.30, right? And 5.30 is a relatively smaller than the critical value here, where it measures the spreadness, right? So it's less than 9.4. So that means it's good for the null hypothesis. But obviously we want to rely a lot on the p-value because it's easier to check. But sometimes they ask you to use a static to make judgment, so that you need to know how to do them both. Okay, and this is a very lovely problem because for the combine means if you get the the expected frequency less than 5, you need to combine those category. Right, and for this one, yes, I think it would be useful for you to get the expected frequency from the probability. So instead of doing the 9, you know that we are going to do, the 9. So that's not the expected frequency. Expected frequency is going to be 100 times 18 over 100, 27 over 100, things like that. So not 100 here, right? Okay, so if I do that, that's a 4.86, which is less than 5. So now what we need to do here is I need to then combine this cell to the next one because expected frequency was less than 5. Make sure you are able to combine them, right? So if I combine together, then it's going to be less than 12,000, so 120,000. What are they talking about? Why is the money so high? Wow. 120,000, good salary, yes. Anyways, so if you combine them together, what happens is gonna be 20, 23, 13, and it's gonna be 7, 13, 24. Lovely. then you got to put that matrix. You got to put that matrix to get the static, right? So then the problem solved, right? But here's the thing. If you ask me, if I didn't combine and use that matrix and get a p-value and static, would that be different? Yes, it would be different. So you need to combine them if they ask you to combine, because those matrices would not give you the same p-value or static. Okay, so you need to make sure to combine them. Okay. Yeah, but for this one you don't need to worry, right? Because now we have you will have the observed frequency bigger than 5, most of them. Because 9 was barely 5, and everything is well beyond 5. So we're sure that expected frequency is gonna be much bigger than 5. And using the calculator, we give you the p-value straight away if you use the two-way method. Okay, that's great. So now for the 161, what is it going to check about? So I got the by temp package of sweets, and in total she has a 600. According to the packaging, the color should have every evenly distribution. So this is talking about goodness of fit. This, my friend, is talking about the goodness of fit, and it's talking about the uniform distribution with the 20%. So not only should I get the expected frequency, I'm gonna get the that's observed frequency. Not only am I getting the observed frequency, you need to get the expected frequency as well, right? What you're gonna do is onto 600, you're gonna multiply this equal probability of 20%, and then you're gonna get the expected frequency to be 120 each time. That is great. So what we're gonna do here is to get the expected frequency, write down the degree of freedom. How many categories do we have? 5, and we subtract by 1. That is it, right? So then what's gonna be the null hypothesis? It is uniform distribution with the 20%, and the alternative is that it does not follow, right? And then what you got to do is, again, use just simply calculator. But for that, yes, we need to create the spreadsheet here. We're going to assign those columns with the observed frequency as well as the expected frequency. Okay, so let's dig in. So every time, my friend, you're creating the column, make sure you name them. So I already used those values. So many alphabet. O is the observed frequency. So let's write it. So I'm going to write 104. 32, 98. Okay, so those are my observed frequency. And the expected frequency, my friend, is going to be 120. All right, so that is a great. So on this, what I'm going to do is menu, stat test. What do you do? Goodness of fit. That is great. And the observed list was who, my friend? O, right? The expected frequency was E, and then the degree of freedom will be, there were 5 categories, so 5 minus 1, 4 is what we're going to do. So then, yes, you get a p-value, which is 3%, is less than 5%. It's no good news. It's no good news for the null hypothesis. So what we're going to say here is that yes, so we do have enough data to reject the null hypothesis that the uniform is that the distribution is uniform. We're going to reject the null distribution. Okay, so that's how you find it, right? So make sure that you're able to find the static. And my static, here chi-square, that difference now is bigger than the critical value. Or you can say p-value is less than the level of significance. Either way, it's a good evidence. It's enough evidence for us to reject the null hypothesis. Okay, so make sure you know how to do the chi-square test. And for that, yes, you need to have the expected frequency, for which you then need to perform the probability, isn't it? Because here, now I'm going to check whether the normal distribution is good or not. I got the mu and sigma. I'm sure you can get the CDF of each probability, isn't it? So that's great. So you get the CDF of them, you multiply that for the total value to get the expected frequency. So if you fill up the table here, yes, 6.8, and then it's 68.92. I really encourage you to do it by yourself. 148.56 is the expected frequency. That is great. And then like we did, you create the observed frequency list and the expected frequency list. And then all the observed frequency was bigger than 5. I don't need to combine nobody, right? And then you just put it in. You put in the goodness of fit test with the degree of freedom, how much, we have how many category. Again, the 5 categories. So in this case, 5 minus 1 is going to be my degree of freedom. So 4 is going to be your degree of freedom. And then I encourage you to get either the static or the p-value. Okay, and this time p-value will be bigger than 5. Sorry, bigger than 10% actually. Therefore, there's no enough evidence to reject the null hypothesis that the exam result follows the given distribution. Okay, so please be able to get this observed and expected, and you're good to go. It's not that bad. It's not that bad. All right, so goodness of it, for the binomial distribution, no problem. It's really the same thing, isn't it? If you think about it, it's really the same thing. What you got to do here is, X be the number of questions answered correctly by what is the distribution. So yeah, what you're gonna do the same thing. What we're gonna do here is that you get the the observed frequency, and you get the expected frequency. And how do you get the expected frequency? You're right, my friend. I'm gonna just get the PDF, right, for the binomial distribution of 10,1/4, and then you got to get all the probability here. And then how many categories do we have? 1, 2, 3, 4, 5, 6 categories. So degree of freedom will be 6 minus 1, 5. That's it. So if you get the expected frequency by multiplying 150 with whatever the probability PDF that you have here, right? That one is going to be 150 times CDF, probability of X bigger than or equal to 5, right? And get that expected frequency, compare that, put it onto the goodness of it, then the p-value you should get is the 0.114, which is well above 0.05. So then there's not enough evidence to reject the null hypothesis, is what we're gonna say. Okay, so then we therefore accept the null hypothesis. Okay, we can conclude that the data is from the binomial distribution. Okay, that is great. So, it's not that bad. It's really, the reason I got those normal binomial Poisson is just to ask you, right? Just to ask you whether you can see that your expected frequency is going to have a frequency that is bigger than 5. And then, hence, you don't have to combine. If it's less than 5, you must combine them. And then, decrease the degree of freedom, right? And the same thing here, for this one, now I gotta use a Poisson distribution. So X is distributed Poisson of lambda 5, and you perform that expected frequency here, then you're gonna get 9.54, 6.32, 6.32, 5.26, 8.56. So that will be your observed, and this will be your expected. And the same thing, goodness of it, how many categories do we have? Everyone has a bigger than 5. I'm very happy. 5 category here, minus 1, degree of freedom will be 4. Your p-value will be who? If you put it in the calculator, you should expect to get 0.0107, which is less than, it's bigger than the level of significance. That means we are going to accept the null hypothesis, okay? So that's fine, it's fine. However, let's have a look at the 165, which uses a t distribution. So let's talk about what we mean by a t distribution here. It's very, very important. Yes. Either z-test or t-test, what you need to assume is that the population is normally distributed. So there's a underlying premise on that, okay? So your population needs to be normally distributed. But it's the matter of whether you have the population variance given or not, right? So if it's given, then you use the z-test. If it's not, then we're going to use the t-test. So yes, and for this one, yes, you can simply use a calculator for it, right? Because you got you already have the mu. It's going to be left tail. You got the mean. And yes, lovely, I got the sample. And what is it? You already have unbiased estimator, right? That's great. Sn minus 1 is the unbiased estimator for the standard deviation. Very good. Oh, sorry, for the variance. That will be the unbiased estimator. And then we need that. We need that for defining the static for the t-distribution because it was the average minus mu, but instead of a sigma over square root of n, we do the Sn minus 1 over square root of n. That's the value that you usually see if you do the one variable stat, right? However, this question was a little tricky here, isn't it? Because that will be the sample variance, right? Sample standard deviation. So for that, you need to change a bit, right? Because we know that the Sn minus 1 is equal to square root of who n over n minus 1 Sn, right? So you need to then convert into the Sn. So for the part B, it's a little tricky here because now I need to use this, but then what you are given here is that the Sn minus 1 over square root of n, then will be the same as Sn over square root of n minus 1, right? So for part B, for finding the static, you got to be very careful. 121 minus 124, I get it, over, however, now I'm given the Sn, so I'm going to use 10, okay? But as you can see, Sn minus 1 over square root of n is the same as Sn over square root of n minus 1, where n was 9, so it's going to be over square root of 8. So that is the correct value to find the static. So make sure that you know how to compute depending on whether you're given the sample variance or the unbiased estimator. Cannot speak. Okay, so that is a very important to observe. And same thing here, if you want to find the static here, what do? It's going to be, 0.864 minus 0.85, but it's Sn instead of Sn minus 1, so I'm going to do 0.012 over square root of 5 is what you do, okay? But if you quickly put that on the calculator, right? So for the part B, you get roughly negative 0.8485, okay? And then if you put on the t distribution, right? Probability of a t distribution less than that value, you get 0.2104, right? And then look at this. My level of significance was 5%, right? So it is way bigger than the p-value. So there's no reason to reject the null hypothesis is what you're gonna say, right? It's very important that you are able to. Oh, hold on a sec. However, my bad. It says what? It says what is it? Two-tailed. This is supposed to be two-tailed, so we need to compare with the not 5% because it's two-tailed, right? You gotta compare with the 0.025. However, it's still a lot bigger, right? It's a 21%, 21 savage. It's a lot bigger than 2.5%, so there's no enough evidence to reject the null hypothesis. Hypothesis is still going to stay. Okay, that's great. And if you look at the part C, again, get the t value here and then try to use the t distribution bigger than it. This is supposed to be the right tail, so I'm going to use t here. And if you do that, you get 0.02387, which is less than 5%, right? So then I'm going to say there is enough evidence to reject the null hypothesis is what you're going to say. So, make sure that we are able to convert into the unbiased estimator for the t distribution is the very, very important concept. Okay. All right, so let's have a look at 166. Okay, so it says the historic temperature in July as the test is measured each day. Average temperature is recorded. The standard deviation is that, so we should determine whether there is sufficient evidence that 5% the significance of the temperature is above the historic average. So please read the question, pause the video and read. Okay, and it says part A, explain why is it possible to use the t distribution in this case. Okay, sure. Look at this, right? We had calculated for how many days? 62 days, right? So if we have enough sample, what you can say is the population is going to so if we have enough sample, the random sample is going to be normally distributed by the central limit theorem, and from there we can now take the t distribution because now underlying distribution is the the normal distribution. So yes, it is true by the central limit theorem, as we have enough data. So that is great. And let's have a look at part B. So what's going to be a null? So yes, my mu is going to stay the same, 28.2. And then the alternative, would it be one tail or two tail? What do you think? Sure. So, what they're saying here is above the historical average, above. So I'm going to say, oh, actually, it got bigger, so it's going to be actually two-tail, isn't it? So for that, what you need to do is to, either get the static or use the t distribution, t-test on the calculator. So, let's try to compare with the t-static. So if you want to, find the t-static, so that's going to be, what is it? X bar minus mu, unbiased estimator over square root of n, or X bar minus mu sample divided by square root of n minus 1 is what you're going to do. So in this time, what are we going to do? Right? What are we going to do? What we are given here is that the standard deviation was 3.2. That's the sample, right? So what you got to do is the second one, right? So that's great. So what we're going to do here is a 28.5 minus 28.2 over 3.2 over square root of we had 62 data, so 61 is going to be the static. If you put that on the calculator, you get 0.7322. So that is a great. Okay, and then what tail was it? This is one tail, this is the right tail. So what you want to do is a probability of a t-distribution bigger than, what is it? 0.7322, and then get the probability. And if you do, you get 0.233. That's your p-value, which is way bigger than the level of significance, which was the 5%. So there's not enough evidence for us to reject the null hypothesis, is what we're going to conclude. Okay, so make sure that you know how to find the static and get the distribution. But yes, why bother? Maybe I could have just used, what is it, on the t-distribution on the calculator. So if you go to the calculator here, and then press, what is it, menu, statistics here, t-test, let's do that. And then let's use what, stats here, no problem. And if I've done that, my average on the previous one was a 28.2. That's great, 2. And then the x bar was 28.5. And then the the sample was sample standard deviation was 3.2, and then the n was 62, right? And then it was a right tail. So if you put that, you can find the p-value here as well, which is 0.231. So then you know that it's going to be, what is it, you're gonna be then this is going to be one with the we're gonna accept the null hypothesis. Okay, sure. So we are checking on the t-test and the z-test depending on the existence of the variance of the population, and let's go over more in the next problem. But let me take a 5 and come back to you. All right, welcome back to the revision session here. Okay, so the little correction, when we were using calculator for the previous question, right? We set the n to be 62. But yeah, sure. So sorry, we should have used 61, right? So that's why we had the slightly different p-value and static. But yes, we should do the n-1 because we were using the sample variance and sample standard deviation. Sorry about that. So yes, we should put n-1. Let me correct that. Okay. So yes, I would have used n to be 61 on the calculator directly. Okay, so that's great. So let's move on to the next part here. So 167, a store claims that the mean price of a bottle of wine has fallen over the last 12 months. The record shows that 12 months ago, the mean price was this, and the random sample of pieces of 389 different bottles of wine is now taken from the store. Okay, that's a lot of data. So we know by the central limit theorem that the underlying distribution will be normally, and then we can assume that, right, by the central limit theorem. So here, yes, don't be afraid of making a null hypothesis. It's going to be the mu being, 13.45, and then the alternative will be mu is fallen, so it's going to be left tail. So that is great. And then the the static now is going to be given by 13.30, so that's great. But you need to know the sample standard deviation is now, so that's Sn, right, is 0.25, right? So then for the n, I'm going to use 389 minus 1 for the calculator, right? So that's great. Okay, so let's see what the value is going to be. Okay, sample standard deviation is a 0.25. P-value to test the store's claim is a 2% level of significance. Okay, so for this, what we need to do is that we're gonna use t-distribution, because although we know underlying population is normal distribution by the central limit theorem, we simply don't have its variance, so we gotta use t-test. Okay, so let's go to calculator here. So what we're gonna do is a menu, and then t-test, and then we're gonna use the stats, and then okay, and with the mu was 13.45, and then the static here was 13.3 has fallen, and then the sample standard deviation was given as a 0.25. That's great. But for the n, yes, gotta be careful. N was a 389, so I'm gonna subtract that by 1 on the calculator. So 388 is what I'm gonna do, and I'm gonna use the left tail. So that's what we have here. The p-value is almost 0. Oh my god, p-value is almost 0. That's significantly less than the 2% level of significance. That means there's enough data to reject the new hypothesis in the favor of alternative on a 2% significant level. So since we have accepted the alternative, we can conclude that the mean price did fall. Okay, so that is great. So that's how you can figure things out using simply the calculator. And yes, we should be able to put on the data, right? So explain why it is reasonable to assume that the carrot weight is normally distributed. Well, because we got enough data. There are how many? 20 carrots. Enough data to use the central limit theorem is what is our the assumption, right? So it is reasonable. But then what you can do is to use the data instead of stats for finding out the t-test. So if we quickly go to the spreadsheet, let's go to the calculator and then go to list and spreadsheet, and here I'm gonna put t to put all the data. So that exactly, so can be bothered, right? So and then what you can do here is using technology, you can find the t-static here, right? And then the p-value also, right? So if I use the menu stat test t-test, so here let's put data. What are you going to do? The list was the t, right? And then that's the column that you have defined, right? And then the new new hypothesis, the mean was 50, and then the alternative here was bigger than, so it's gonna be the right tail, and then that's it, right? So then it's gonna give you the static and then the p-value. So obviously I didn't put all the data there, right? But if you look at this 4 data only, and then the p-value is bigger than, it's very large, so there's no enough evidence to reject the null. Okay, so we're gonna so that's how you're gonna conclude. But obviously we didn't put all the data, but I just wanted to demonstrate that you are able to use the data instead of stats to do the t-test. Okay, so that's great. And let's have a look at the 169. So for this one, what are we supposed to do? It says 0.02 significance level, whether a claim should be rejected or not. So for that, I just have to quickly make the null and alternative. And for the null, is going to be, what is it? Mean. Okay, so I have a null being 95,000, but the alternative will be right tail because it's got more than, right? Right, that is great. And then I got the sample size. Don't have what is enough, so the underlying distribution will be the normal distribution by the central limit theorem. However, I don't have his variance, right? I only have the average income was, the static was now, 96,318, and then the sample standard deviation is going to be 14,268. What, really? It's huge. Okay, sure, and then you can do the test. Would you do the z-test or t-test? You're absolutely right. I should do the t-test because we are given the static like that. Okay, because we don't have the population variance. So that's great, no problem. So we can simply use our calculator just like we did. So if we simply use calculator here by taking out calculator. Then let's plug it in. What we're going to plug here is a menu, stat test, t-test. And then this time I'm going to use stats. That's great. And then the mu was 95,000. And then the x bar was 96318. And then the sample standard deviation was 14268. And then n was 113. 113. So what you need to do is subtract that by 1. And then it was bigger. So right tail is what we're going to do. So there you go. Right. The p-value will be 1.165. That means it's a very large. So you know that you want to do, what is it? That it's a lot bigger than 2% level of significance. So there's no enough evidence to reject the null. Right. So what we can do, since we have accepted null, we can conclude that the mean is still 95,000. Okay. Sure. So if the conclusion made by the statistician is incorrect, what type of error? So this is so look at this. So conclusion as made by the statistician is incorrect. So what we're doing is true given incorrect. That will be type 2 error, right? So yes, we're gonna have a look at the type 1 or type 2 error later on, but that's the type 2 error here, right? So that's great. Yeah, so for 2 sample here, what do we need to do? So there's the 3 in the shade and 3 not in the shade. Petra noticed that the one of her apple trees grew in the shade and then the other did not. She wanted to find if apples from the tree in the shade weighed less than those in the sun. She picked up 9 apples from each tree and weighted them in the grams. Perform t-test, 10% apples. So, you know, for assumption here is that the what is it? Not only their underlying distribution is normal, and also it needs to be pooled. It needs to be pooled. That means it needs to have the same variance, right? It's the population has the same variance, not the sample. Is what you need to do for this 2 sample test, right? And then yes, you know, my null hypothesis is that their average is the same. And the alternative is that who is bigger, right? Shade weight less than those in the sun, right? So okay, so I'm gonna say average of the one in the not in the shade was actually bigger than one in the shade is what we are saying, right? So for that, what you can do here is to use this data and then put it into the 2A. So if we quickly go to our calculator, right? Let's do that. And then what you can do is to go to the list and spreadsheet, right? If we did, what you see there is we're going to create the list. But hold on a second. Let me quickly just create another list to nullify all the comment that I already had. So let me call that as A and B. So A, I'm going to do the one in the shade. So that would be, 75, 82, 93, 77, and 85, 78, 91, 83, 92. Okay. And then the next one is 74, not in the shade, 81, 95, 79, 95, 82, 93, 88, 90. So that's great. So what we're going to do is menu and then stat test. So what we're going to do is a 2 sample t-test, right? So it's going to be the data, sure, because we have done the A and B, right? And then the alternative is that the mu2 is bigger than the mu1. So it's going to be the, right? And then yes, it's always pooled. That means it's coming from the same variance of underlying population. It's very important that you do that. So then we can get the, the mean, and then the, their standard deviation, and then the, the static here as well. But most importantly, is the p-value, right? The p-value we got was, the 25% is way bigger than the given level of significance, which was a 10%. So yes, there's not enough evidence to reject the null. That means their average is about the same. Okay, so that's how you can find them, right? So make sure we are able to work with the 2 sample t-test. But for that, make sure it's going to be always pooled, because we want to say that it's coming from the same variance from the population. Okay? Right, so let me take a 5 and then come back to the next problem, and then we will discuss more. Alright, let's move on to the next question here. So 171 is also 2 sample. What I want you to do is to create them and make sure that you choose Again, press menu on the spreadsheet. There's a two sample t-test, and that's all you gotta do. Make sure you choose pooled because that represents that it's coming from the same variance. Okay, but yeah, one more thing that I would like to check is the paired test, right? So we are going to perform the t-test. However, in this one, what are we going to do? Yes, we need to get the difference because it's from the one sample, right? But it's just they changed, so I like to know what the difference is and then see if the new hypothesis is that it did not change, so hence the average is gonna be 0. But if it did change, did it get bigger or smaller is what we are checking. So paired test is not the two sample test. This is just the t distribution with the new hypothesis being giving the difference being 0. So what you got to do here is to get the difference of each data. So it's gonna be negative 0.1, negative 0.2. So I'm looking at just the difference here, from the end to start, going all the way. So up to the last one is going to be, negative 0.4. So you got to put all those difference on the calculator and then do the t distribution on it, right? So if I quickly define the d as the difference, right? And then I'm going to put the difference there. So it's going to be negative 0.1, negative 0.2, 0.2, negative 0.3, 0, negative 1.4, 0, 0, negative 0.2, negative 0.2, negative 0.4, 2, 1, negative 0.2, 0, 0.1, 0.1, 0.2, negative 0.2, negative 0.4. So that's what we have. And on this, what do? We're going to do the menu, statistic, stat test. And then what we're going to do is we're going to do the t-test, right? So here, I'm going to do the data and I'm going to put my d there, right? So that's what we have. Sorry, my mean is 0 and my d is going to be the list. And for the alternative is that the performance has improved. So for running, if it improved and it ran shorter time, so then the difference must be negative. So what I'm going to say is that this is going to be left tail is what I'm going to say. Okay, so that's great. So then you can press OK to find your the p-value, right? So here p-value gives you how much? 2%, right? It's a 2%. It's a less than 5, right? It's a less than 5. So if your level of significance was a 5, p-value was a 0.0292, less than 0.05. So as you can see, there's enough evidence to reject the null, right? So make sure that you know what to do for the difference versus two sample, right? They are not the same. So for this one, we are just attacking on the difference. Okay, so that's great. So let's have a look at the 4.12. We're checking with the estimating the parameter for the normal distribution. We can estimate the mu or sigma, or for both Poisson distribution, we're checking on the lambda. For the binomial distribution, we're checking on the proportion, etc. Depending on the number of unknown, we need to check on the degree of freedom and etc. Right? So let's have a look. A pot paint should cover 24. Okay, in the test, 32 pots of paint were tested. So that's the sample here, right? And as we have enough number of samples, we can assume that the underlying distribution will be the normal distribution by the central limit theorem. That is great. So now the average was what? The x bar now is the 23.3. It is known that the standard deviation of the area. So it is known that the population is given, so you can actually do the z-test. So that's great. So my yes, I can do the z-test in this case because it was a large to use the central limit theorem as well as the standard deviation of the population was given. So I'm very happy with that. So what I'm going to do here is, yes, my null hypothesis is that the mean is the 24, and then the alternative, as you can see, it got smaller, right? So it's gonna be actually what? Less than 24, to call it that this is a left tail. So then, what we can do is to get a p-value for that, right? So state the null alternative, which we did the p-value test and conclusion from the test. So for this one, I'm going to use the z-test. So no problem. So if I quickly go to the calculator and then press menu, statistic, and stat test. Z-test is what I'm going to do because I'm given the standard deviation from the population. That's great. So I'm gonna put, what is it? The mu was 24. Standard deviation here was given as 1.8, right? So that's great. And then the x bar is 23.3. That's great. And the number of samples were how many? It was 32 many, I believe, right? And then, you know, we're doing the left tape because it got smaller, right? So that's what we have. And here the p-value is almost 1%. So 0.0139 is my p-value, right? And as you can see, it's less than 0.05. So we know that we're going to reject there's enough evidence to reject the null hypothesis. So we're gonna go with the fact that it got less, right? So that is great. So now let's have a look at D. Find the critical region for the test and use it to verify the result in the part C. So sure, what they are saying here is we draw the normal distribution curve, and it was supposed to be the left, and then the critical value is the R, such that the less than will be how much? The level of significance. It was 5%. So what you need to do is simply do the, inverse norm. You're going to do the probability of x bar less than R to be 0.05. So all you got to do is simply just use the inverse norm, and that's it. Okay, so you know, I'm given the mu and sigma, so you can get the R without actually doing the standardization. You don't need that, right? So let's do it. So it's going to be the inverse norm. Let's have a look. So we're gonna do the inverse norm. Here the area was 0.05, and then mu was how much? It was 24, and then sigma was how much? It was oh, you gotta be careful for the sigma, because it was for the x bar, isn't it? So we are doing the x bar. So x bar was the sample standard deviation is going to be 1.8 over square root of how many? The sample was 32, and then we close the bracket, and then you can do that. So then you can find the upper bound, which is of approximately 23.4766. So if I put it in the three significant figure, the R is roughly 23.5. And as you can see, my static from the t-test, so from the z-test, look at this. My static here was given as a negative 2.199. Oh, well, you know, I got to standardize that actually, right? So if you standardize that, that becomes oh, sorry, we were given the static. It was 23.3. It was 23.3, sorry. So that is less than here. That is less than the, what is it? The critical value, which is then going to give you the p-value less than the 5%. So yes, it is confirming that we have to reject the null hypothesis. Okay, so that is great. So this is in the critical region. This is an acceptance region, right? So we need to be able to distinguish. Okay, that's great. So let's have a look at the normal distribution here. It says John believes the average time in the factor no longer. So it is known that the time between the arrival of two buses is normally distributed with a standard deviation as a 2.1. I'm very happy that my standard deviation for the population is a given. So we can use the, the z-test. So that's great. So my null hypothesis is going to be that the mu is going to be the, the average is 8.3, right? And then the alternative is that the longer, so mu is bigger than 8.3 is what I'm going to do. And state the null, we did that, and find the mean, which is going to be used as a static. So what we need to find the average of this 8 all the way to 8.5 divided by 5 gives you 8.56. Right, so that's the static that we're going to do. Then the sample mean distribution here is going to be normally distributed with the same mean as a population. However, for the variance, that's going to be 2.1 squared over the number of samples, which we had 5 of them. So that's great. And then remember, we are trying to get the p value by using the right tail. So this is going to be probability of x bar bigger than the static that we had, which is 8.56. So that's what we have. So you can use this distribution, or you can simply use our calculator, right? The z-test. If you do the z-test, the p-value you get is how much? It's going to be 0.391. You can check yourself. And because this is bigger than the alpha, there's no enough evidence to reject the null hypothesis is the conclusion that we're going to make. Verify your answer performing the test using the input function on your... So that means you need to, put it into the probability and see yourself whether you get the p-value or not, right? So that's what we just did. That's fine. But for part G, find the critical region for the test. That means what you need to do is draw the normal distribution here, right? And then I need to find the critical value that will give the probability of x bar bigger than k is 0. At the level of the significance, which was how much? Did it give you? It should give you the level of significance, right? And where is it? The distributed standard deviation, the mean time is at the zone, average time is faster than the sum time before the state the null. Okay, let's assume typically 5%. Let's assume typically 5%. Okay. So 0.05. You know, that's a typical level of significance. I'm just going to verify it. So for that, yes, you can just use the inverse norm here, right? But for that, I would change the direction of inequality. For the CDF, will be 0.95. And for that, I'm going to put an inverse norm of 0.95. However, you got to put the mu and sigma, right? So mu will be 8.3. However, sigma will be 2.1 over square root of 5. That's going to be your mu and sigma. Then you can get the upper bound, which is going to be the critical value. Okay. So that's how you can find. And if you do so, the critical value will be 9.8448. So then you can say, okay, in that region, it's going to be the critical region. So if your static is around there, that means it's not good. We need to reject the null. However, if it's less than this, that it's an acceptance region, that means that we are not going to reject the null, is what we're going to say. Okay. So let's have a look at the test on the binomial. Right, let's have a look at the test on the binomial. It says the medicine company claims that its treatment leads to significant reduction symptom within 1 week for 60% of a patient taking the treatment. In order to test this claim, trial conducting a sample of 30 people will take place. Okay, if P represents the proportion of people who benefit from the treatment, state the null. Okay, so my null is that my proportion is a 0.6, no doubt. But that the alternative is what? There's a significant reduction in symptom. 1 week for 60% of patients. So alternative is a reduction, so it should be smaller, right? So I'm going to say P is less than 0.6. Okay, so that is great. And then what we need to do is hence find the critical region for the test for 5% significance level. So what you can do here is, okay, probability of what x less than equal to k, I want that to be 0.05, right? So that's what you can do when you have n to be how many? 30 people, right? So then you can do the inverse binomial, right? So if I quickly go to the calculator and I'm going to go to the inverse binomial here, and then cumulative frequency, I want to be 0.05, get it. I got it to 30 here. Probability of success was a 0.6, wasn't it? Then if you put that on the OK here, that's roughly 14, right? So if I actually put it into the CDF, right, you need to double check because that may not give you the exact 5, because remember, this is a discrete random variable. You may not get the exact probability. Sure. So if I try to do the binomial CDF, right, of a 30, and the probability of success was a 0.6, and upper bound is going to be 14, if you press that, you get a 9%, you see? So that is not going to be the critical value. You need to then have a value that is similar to the 5%. So the critical value here is going to be 13, slightly less than the 9%. If I quickly go, it's going to give you the less than 5%. That's the value that we will have for the critical region. So your critical region here is going to be x less than equal to 13. You need to always double check because this is a discrete random variable. It may not give you the perfect probability as you want. Okay. When the test is performed, 13 people report the reduction in symptoms. State the conclusion for the test. Okay. So for this, if you have, what is it, the 14 that is bigger than 13, you are in the acceptance region, my friend. If you're in the acceptance region, there's no enough evidence to reject the null hypothesis, is what we can say, right? So make sure you are also able to do the inverse binomial. So that's great. Let's have a look at the Poisson distribution. So here, if you want to make decisions, it says Ev is trying to improve his writing. At the moment, the number of typing error makeup per page is the average of a 4.7. So X is the number of error. So then we're gonna say X is distributed by Poisson of a 4.7, but I'm gonna say that's one page, right? So that's great. So that is the for per 10 page, you need to increase, right, with the same scale factor for the average. So it's going to be x10 page will be Poisson distribution of a 47, right, is the Poisson distribution. That's the 10 pages. Okay, after attending a course, Evie checks a random sample of 10 pages and finds that he made 35 errors. So it's a less, isn't it? It's a less, right? Is there evidence that 5% level has decreased? So my null hypothesis is now going to be what? My lambda is gonna be 47. That's the null. The alternative is that it got reduced. So I'm gonna say less than 47, right? It's what we want to check. All right. So then what we want to do here is to get a CDF, right? We want to get the CDF that and then see whether it's going to be an acceptance region or critical region. So let's have a look. So now we're comparing with what, 35. So that's gonna be my static. So probability of what, x10 less than 35 is what we're gonna do, and get the probability. If you use a Poisson CDF, right, menu, and then 6.5, go to Poisson CDF, and here the mean here is gonna be 47, and my upper bound is gonna be 35. And if I do that, the probability now is in the 0.041. It's in the critical region. So yes, there is enough evidence to reject the null, right? So that then we can say that we can conclude that yes, it has decreased, right? So this is a 0.0420 less than 0.05. So there's enough evidence to reject the null hypothesis is what we're gonna do. So make sure you're always trying to find the right interval, right critical region, right correct acceptance region. So let's have a look at the next question. The call center receives a lambda calls per hour. Okay, one morning it received 20 calls between 9 a.m. and 12 p.m. Okay, so now X is going to be the number of call. And I'm going to say X is distributed Poisson of how many, right? We got to follow the interval. What interval are we going to do? It's going to be, what is it? The lambda is equal to 6. Okay, so null hypothesis is that lambda is a 6. Okay, during that interval. All right, that's great. And alternative is that what? That we have received more than 6 calls. Okay. Critical region to make your decision. Okay, so let's do that. But here's the thing. So if your lambda is so it's not during the time because lambda is for 1 hour. But now what do you have? You have from 9 to 12. That's how many? 3 hours. That's 3 hours. So for 3 hours, your expected value has to be multiplied by 3. So you're talking about the what is it? Sure, the probability with the expected value of 18 is what we have. And then what we need to do is to find the upper bound, right? Sorry, the right tail. We need to find the right tail so that it's going to be, what is it, giving us the, if we draw the distribution curve like that. Obviously, the Poisson is positively skewed. It's not going to be Bell's curve. But, it's good to just visualize the diagram. And what I want to do is to find the critical value that will give you around, what is it, 0.05 is what we want to do, right? That's gonna be the critical region. So for that, what we need to do is to play around with the CDF, right? So what we want to do is a probability of X now bigger than equal to K, so that's going to be close to 0.05, right? And if you work with the CDF, right? So then we want probability of X less than equal to K minus 1 to be 0.95 is what we want to find. And then obviously that's a huge number. So you can try to put the relatively big upper bound for the CDF of the Poisson to find it. Okay. So for example, if I put, let's say, play around, right? So if I get the Poisson CDF, menu 65 Poisson CDF with the expected value of 18, right? And then let's say upper bound was, the 18. So maybe let's put 18 there. That's a 56. So we need to obviously go bigger. So let's go maybe 25. That's already 95%. That's great. So what I want to try around here is mid in the halfway. So let's say 20, right? So obviously we gotta go a bit bigger, right? So 25 seems to be okay, right? So because it gave you, maybe we can do more, okay? We can do 24. Yeah, actually 25 is perfect, right? So 25 is a perfect. So if that is a 25, it's give you the 95%. So then your critical value will be here as a 26 because k minus 1 was a 25, right? And then what we want to do here is that if you have how many calls? 20 calls, right? If you get 20 calls, it's going to be, what is it? Less than the critical region. So that means it's in the acceptance region. So that means we can say we don't have enough data to reject the null hypothesis is what you're going to say. Or what you could have done is just get the CDF up to 20, right? If I get the CDF up to 20, which we did here, then I get 0.73. So it's definitely within the acceptance region. So I'm very happy with that, right? Because that's if you subtract from 1, that's gonna be well bigger than 5%. So that's great. So then we can conclude that there's not enough evidence to reject the null hypothesis. So it's always about finding what tail, and then where is your where is your acceptance region versus the critical region. Then the next thing is that we're going to talk about what it means to, reliability and validity, and then, what technical words we have to use to conclude. And for that, let's go over with start with the question 178, but let me quickly take a 5 and then come back to you. All right, let's have a look at the next question here. It says, suppose two schools both teach IB diploma program. A approximately 60% of girls, B has approximately 40%. Each school has a very different style of teaching to the other. Both schools agree to sample of their students taking a standardized test at the start of the course, which will then be compared with their final result to see how much they have improved. Given it is assumed that the girls show more improvement between the test and the final result than boys, state how you will select your samples if you were interested in A1. Finding out that which school is better in terms of how much their students improve. So for this one, yes, we want to look at, with the how much their students is improved. So we need to see the same proportion of those students. So for us, we are going to do this stratified. Right, because then we need to have the same number of those students from those schools, so we need to take the same probability from whatever the number, right? So that's what we would do. For the second one, if I'm finding out which of the two teaching methods are better, then we need to have like the equal, so it's going to be random sample, right? So improvement is due to the teaching method and not by the, find out which two. So for this one, I don't need to figure out between the girls and boys. I just have to talk about the school. So we are going to focus more on the sample from the schools, not from the gender. The testing whether in fact girls do perform better than the boys. So for that, then sample of girls should be compared with the sample of boys. So samples could also be pooled with the mixture of boys and girls. So for that one, yes, we will select boys and girls. For a second part, it was focusing on the students from schools, but third one should be focusing on the boys and girls. So for the part B, state a test you could use for each of the case above and comment on the assumption. Okay, so we don't know the variance of the population, so we will probably use the t-test. But whenever you try to do the t-test, and it's going to be 2 sample, So that means you need to work with the two sample t-test, where then you need to assume that it's going to come from the same normal distribution with the same variance. So it's gonna be pooled t-test for two sample, and then I'm gonna use pooled, right? So that will be a good test to use if we got the data, right? So you always have to be able to, you know, answer them what category you're using and what reasoning. Okay. Oh, sure. So let's have a look at the next one here. A social scientist wants to look at the people's experience of a crime. He conducts a survey using a questionnaire. When the question asks, how many crimes activities affected you in the last year? He leaves his questionnaire in a police station, asking people to post their completed questionnaires in a box. So yes, it's now in the police station. He has received the following response in the question. So explain why reasonable to, yeah, because this is gonna be an outlier, because if you compare with the other data, it's just too big, right? From the remaining data, calculate unbiased estimate for the population mean and population variance. So for that, you can do the one variable stat. And for the one variable stat, you're gonna have X bar. It's the same thing as the sample mean. That's gonna be the unbiased estimator. And for the population variance, what you can do is typically just Sn minus 1 squared, and for which that's the value that you usually see in the one variable stat. So that's great. So we can simply find them on the calculator. So what's gonna be the validity? You know, we need to know what validity means. Is that the whether the answer is really whether this answer is correctly telling us or not, right? So for example, comment on the content validity. I guess it really depends on the type of question, really. You know, it says what criminal activity, you know. So instead of defining the criminal activity categorized as, you know, harassment or physical violence or theft, they didn't specify that. So this criminal activity can be multiple crimes, and therefore may have affected their answer, right? It's not, and also you know, if the question asks about the last year, you know, would it be exactly 1 year before? Would it be representing for 2022 as a whole year, right? We don't know what that year is going to be, so that's definitely going to affect on the validity, right? So we need to be able to justify why the question could have been better. And then for part D, comment on the validity of the sampling method. So I'm not gonna say I'm gonna say it's not random. Why not? Because it was put into the police station, right? So there are certain categorical people, certain type of people who come to the police station as defined. It's not as random as you would have done on the street. So I wouldn't say this is a random, right? Thank you. So it will be, there's a higher chance of being biased answer. So that's a part C. That's part D. Let's go with part E. Is there a social scientist estimate of the population mean more likely to be overestimate or underestimate? Okay, so for that, you know, how would you answer it? So, you know, what I'm saying here is that as I've said before, people visiting the police station has likely to encounter, right, the criminal activity if they were victims, or yeah. So then I could say that yes, it will be overestimating, because you're asking people who have likely experienced the criminal activity. So it could be an overestimated to compare for the social science. How could the reliability of a survey be improved? So for example, maybe, you know, there are too little samples here. There are only 5 of them. So increasing up to 20, 30 can definitely help us to improve the reliability, is what I can do. So, you know, so really it's just to make a comment that's gonna fit into the category of the answer. So as long as you justify well, you know, I think it's very hard to get wrong, right? So of this reliability or validity sort of question. So reliability is when, you know, when you conduct a similar experiment, are you going to reach to the same conclusion, is what the reliability means. And if you look at part B, psychology test tries to assess people's personality test on 4 different categories. A test uses the 4 questions to assess throughout the questionnaire. The psychologist wants to check whether the results of each question testing the same category correlate. Name the reliability test that she is using. So what reliability is that using? That's going to be the parallel forms, because you're using the same forms over and over. That's okay. And then suggest an alternative way to assess the reliability test of the test. Well, instead of asking to the general people at parallel lines, so at one go, you can do the test over and over again, right? So it's gonna be test and retest and retest. This will give you the the results more reliable to compare the test. So retest is what we can do to assess the reliability test for this one. Okay, so that you can check whether it's going to be the same result over again. So let's have a look at the validity test, whether it talks about whether your method is correct or not, right? So validity is you're measuring what you really want to measure, right? For example, the criminal activity last year, is that valid? Well, maybe we could have specified more categories for the criminal activities, and giving the frame of last year is too general. So maybe you could have said, so from exact date to what other exact date, that could have given you the better interval to answer well, right? So that's what it means by the validity, is to measure whether you are measuring the things that you want, right? Sure. And let's have a look at part B. A career coach wants to assess his impact on people's business success. Okay, he does this by asking following question at the end of the course he has run. Do you think this course increases your salary? Okay, give 2 reasons why this question does not have content validity. So content validity tells us whether the answers to questions will tell us about the thing he wants to measure. He wants to measure whether the salary has increased or not. But by simply saying yes or no, we don't know how much it has increased or what percentage of his effort has contributed to that, right? It's hard to measure the expected value, right? So explain why making the questioner anonymous might increase the validity of the questioner. Well, it's going to, put more honesty, because they don't have to be judged by the answer. And then also, explain why making, that's it, right? It says, oh yeah, that's it, right? So that's it, right? So for part D, the career coaches follow up the question response 4 years later and check to see whether the salary increase were greater for the people who answered yes to his question. What aspect of validity he's using? Okay, so this is a criterion validity. So, and because you want to correlate your answer, if you want to check the answers to the question correlate with another measure of the same or similar thing, we say this is a criterion validity. So you need to be more familiar with this technical term so that you can draw the answer for the correct question. You can draw the correct answer for the question, right? So it's really just to meet the appetite of the test, so it's not big of a deal, okay? So let's have a look at the regression for the bivariate for that section here. So it's a rational function. If you quickly sketch with the vertical asymptote, I'm sure you're gonna have things like this. So that's okay, right? And then and then yes, you can do the regression here to draw the scatter diagram. And what's the residual? Sure, residual is the difference between the y value and then the function value that you have defined, right? So you're gonna put this function value onto this x value onto the function and get the y. If you have used your function, you're gonna get 0.3707, 0.5520, all the way up to, if you put 9.5 on the rational function, you're gonna get 0.3763, and then the residual is the difference between them, right? So you're looking at the difference between the y and then the function value. So for the first one, for example, you're going to get 0.0293, all the way up to, for the last one, you're going to get 0.2237. And if you want to get the residual, so I got the residual, and sum of the residual is, yes, the difference squared. So sum of residual squared is going to be 0.0293 squared plus all the way up to 0.2237 squared. You add them up, you're going to get 0.144. That's what we have with the residual. So comment on how well the model fit the data. Well, what you're going to say is that if you look at the sum of the residue, it's very small, right? It's very small. So we're going to say, yes, it does fit well, right? That's how you can also say about the use of the sum of residues. And make sure your coefficient of determination will be given by 1 minus sum of residue over the sum of the total, where he's the that's the difference, the square between the data and then the average rather than the data. Okay, so make sure you know the formula as well. So coefficient of determination. Okay, so that's great. So let's have a look at the 183 here. I got the this is not the PMCC, that's the coefficient of determination. Please remember that. Okay. And it says Alessandra and collect the data on the number of visits to their business website every hour in 40 to 24 hour periods, and it fits the quadratic regression, put it to the data and gets the coefficient of that. Zoe, however, fits the cubic regression, and then get this. Zoe claims her model is better than the other, explains claims is not necessarily true. Okay, comparison may not be true because may not be valid because they are using the what is it, the even though it got higher, right? I would say that it's not accurate because you're looking at the different number of parameters for the quadratic and cubic. Because if you look at the quadratic, you got the ax squared plus bx plus c, where for the cubic you have ax cubic, bx squared, cx plus d. You got 4 parameters here unknown, where you got 3 unknown parameters. So depending on the unknown, depending on the initial conditions, it may affect on the accuracy as well. So even though I got the higher coefficient of determination for cubic, it may not be necessarily true, right? Depends on also the number of initial conditions. So you need to be able to justify it. We cannot rely 100% if you're using the different model. But if I was comparing with the cubic, and then another cubic gave a higher coefficient of determination for that, yes, that's gonna be more accurate. We can say that. But if it's a different modeling, you got to take it into consideration with the different parameter as well. Okay. Sure. Now we got the power function. You can do the regression, and then you can get the coefficient there. That's great. Okay. And then draw a scatter diagram of the data. Sure. Let's suppose we did that. No problem. Okay. And then, you know, if it was bigger than 1, I'm sure it's going to be increasing. Sure, no problem. Draw a scatter diagram of the data. Sketch the fitted model of the same axis. So we can do. Sure, if you want to get the residual, again, you know, what you got to do is plug those x value onto the function. So your function in this time is going to be function of x will be 6.89 times, what is it, x to the power of 1.359, and you put those x value onto the function, get the y value, get their difference, and then that's gonna be the residuals, right? So if you, for example, get if you put the 2.7 on the function, you get 26.589. The residual, the difference is then going to be negative 1.99. For the last one, if you compare with the if you put x value to be 0.6 for the function, you get 10.2. All right, and if you get the difference, sorry, you don't get 10.2. You get the 3.443. If you get the difference, that's a 6.76. So sum of residual square is gonna be u squared, all that, and add them together, right? That's gonna be the sum of residual squared. So that's great. So if you get that, that's 122. And as you can see, unlike the previous example, that's a very large. So I'm going to say that's not going to be a good fitting modeling, right? However, they say use the log model to fit the power model to the data. How does the model compare to the one above? So what they're saying here is, okay, I'm going to put a log scale on both x and y, right? If you did, you know, you're going to get you're trying to linearize the equation, right? So, you know, you got the ln x, ln y, and then all the data will be now put it in a different way, and then it's going to give you sort of a linear line equation for which you can do that, right? And also, right, if you did, you know, using the gradient and then the y-intercept, you're gonna have ln y is equal to 1.03 ln x plus 2.52. And then if you exponentiate, you're gonna get a power function. Y is going to be e to the power 1.03 times, what is it? It's going to be e to the power of 2.52 times x to the power of 1.03. That's the power function you have. And now you can have the, what is it? You can also do the similar step of a sum of residual squared. But if you did, that's going to give you 1,160, which is greater than the initial sum of residual squared with the other function. So obviously, this is going to be more inaccurate, right? So we're not going to use that, okay? So this model does not fit the data as well as the previous one. So I guess, the power function approximation would be irrelevant. So you can use another regression such as, exponential or other functions, right? So we can conclude that the power function either way is not good. Okay, that is great. Let's have a look at the section 4.14. It's talking about linear combination of random variables. So the normal distribution is going to preserve it. Poisson only the sum. Binomial also does, but it's not in the syllabus, so you don't have to worry about it. Okay, so let's have a look at the part A. It says one of each side. So what we are given here is that the small and large were normally distributed. I'm very happy. And one of each size bar is selected random. Find the probability that the larger bar weights more than 3 times. So what we're looking at here is a probability of large bar is weighting more than 3 times the smaller bar. So what we're trying to measure probability here is a probability of large bar minus 3s is bigger than 0. So you're looking at the new variable L minus 3s. So for that, you need to find its expected value and the variance. So expected value of x is going to be expected value of L minus 3s. That's going to be E of L minus 3 times E of s. That's what we have. Okay, and then variance of x is going to be variance of L minus 3s. If it's a constant multiple, you got to square it. So it's going to be variance of L plus 9 times variance of s, right? So you need to always make sure be able to find that. So if I were using those initial value, we got the expected value and then the variance each. But for this one, it's going to be -4. For this one, it's going to be 60. So then my x random variable is normally distributed with the -4 and 60. Make sure your standard deviation therefore would be square root of 60, isn't it? So then you can perform the normal CDF, probability of x bigger than, for example, 0 is what we are looking at. So if you get the CDF, you roughly get 0.303. That's your probability, right? And then you can compare it with part B. So this is very important because you're not doing the multiple, you're adding the independent variable together, all right? So that's very important. So they're saying find the probability of L is bigger than, what is it? S1 plus S2 plus S3. So we are not doing the multiple, we are having the sum. So that one will be equivalent to probability of L minus these sum here, for which we can use it for the expected value and variance of the new random variable y. I'm going to call the y to be that. And then the CDF that we're trying to get is that y bigger than 0. And for this one, expected value of y will be the expected value of of these random variables. So that's great. But then I can do linearity of the expected value. So it's going to be E of L minus 3 times E of s, because those were independent and equally distributed. So that's great. So that's going to be the same. It's going to be -4. However, you got to be careful for the variance, because I got the constant multiple of -1 each. It's simply going to be, what is it? Expected value of L plus variance of s plus variance of s plus variance of s. So instead of multiplying 9, it's going to be just multiplied by 3. So if I do, the variance here is going to be 30. So that's great. So now the y will be normally distributed, same mean, however, different variance. Okay, then you can perform the probability of y bigger than 0 to get the probability. Okay, make sure that you know, all right, how to distinguish with the constant multiple and some of the independent equally distributed variables. So getting the mean and then the variance on them is different. It's not the same, my friend. So if you look at the part B, part A here also, we got the small and large. Okay, and then what they're saying here is that the large bar contains less than 2 times the probability of large less than 2 twice of the small. So for this one, yes, I'm going to call x to be L minus 2s, and then expected value of x, it will be what? E of L minus 2 of E of s. But for the variance, is going to be variance of L plus 4 times variance of s is what you're looking at. For part B, right, find the probability that large body contains less than total of 2 small bodies. So it's not going to be multiple of 2. Please be careful. It's going to be sum of those samples. So sum 1 and sum 2. For that, you're going to have the same expected value if I call the y to be L minus S1 and S2, expected value of y is going to be the same thing. However, the variance of y, you got to be careful. It's going to be variance of who? Of that random variable there. And then what you realize that it needs to be variance of L plus twice of the variance of S, because it's an independent, equally distributed random variable sample. So that's how you can distinguish. As you can see, more samples you have, less the variance, because it's going to be more accurate around the average, is what you can say. And then you can use the normal distribution to find the probability. It's not that bad, but please make sure if it's a linear combination with the constant multiple for the variance becomes a square. But if it was a sum of independent variables, we simply have to add them together. Okay, that's great. Let's have a look at the 187. So what you're looking at here is, what is it? This time taken travel between two town buses can be modeled by the normal distribution. Bus company claims that the mean journey, the time between the town is 83. Okay, so my alternative is that the mean is 83. My null. And my alternative is that what? Jackie believes that every time has longer, so mu is bigger than 83 is what we're going to do. Okay, so that's great. So I got that. So from there, you can already find the static, right? So the static here is going to be 82, 85 over 5. That's going to be your static. So I got the new alternative. For this sample, find the mean. I did set a standard deviation. You can find that too. That's going to be that's going to display on the calculator, right? So if I do the Sn minus 1 for the sample, or you just use the one variable stat, right? And then if I get the Sn, it's going to be square root of what? 82 squared, all that sample divided by 5 minus the average, which is going to be average here. If you get it's 86, so 86 squares, that's a standard deviation. But unbiased estimator, we know that formula Sn minus 1 will be square root of n over n minus 1 Sn, for which you will see in the one variable stat anyhow if you put it in your calculator. So that's great, right? And then find the p-value. For that, you can simply just use the data and t-test, no problem, right? So we already have done that. But in this question is asking about the unbiased estimator, so please make sure how to find it. Either you can just get it from the one variable stat, or you can use the formula. If you got the standard deviation from this sample, make sure you multiply this factor so that you're going to get the unbiased estimator for the t-distribution. But you don't need that other journey, because you can just simply use a calculator. And for this one, I'm going to use the right tail test for the t-test, for which we already have practiced a lot. Okay, that's great. I think we already talked about it, right? So no problem. I'm gonna skip that. Okay, sure. Sample mean and center limit theorem. So there's two ways of finding out that your samples are going to be normally distributed. The first is that yes, your population was already given normally distributed, then taking the sample will preserve the normal distribution. Or even though you were not given the the normal distribution for your population, if you had enough samples, then yes, by the center and limit theorem, it will converge to normal. Okay, so if you look at the first one, yes, the population was already given normally distributed. So even if you had a little number of samples, it will still be normally distributed because it's preserved, okay, from the population. No problem, right? It is normally distributed because even though we don't have enough samples, yes, because population was normally distributed, therefore it's going to be passed over. So that's okay. Would you expect X or X bar to have a greater proportion of a score over 100? Obviously, X is going to have, right? Because, it's got... for X bar, it's got small numbers, so I don't think it's gonna have bigger. So for that, you can just use a CDF. But for this one, you need to define your normal sample distribution well. Although it's gonna have the same mean, you need to make sure it's gonna have a 20 over what? Square root of 5 square. So that's gonna be his standard deviation. Make sure then you use a calculator for finding out the probability. But make sure, we've been doing that, right? But for the sample mean, either the population is already normally distributed, or you got enough sample to call it that it's going to be normally distributed, right? So let's have a look at this here. Center limit theorem. So custom at clothing store is mean time of 18, standard deviation is 4.3. So whatever the expected value of the population is 18, and then the variance is 5.3 squared. They did not give me that this is normally distributed. However, if you want to take the sample with enough sample of 37, you know it is going to be normally distributed by the center limit theorem. All right, that's great. So my x bar is going to be normally distributed of 18. However, for the variance, it's going to be 5.3 squared over 37 by the center limit theorem. And then you can then what? Use this data to find the probability of what x bar between 17 and 20 is. This can be easily done by using calculator, so that should be 0.864 as you do this on the calculator. But please remember two things: population already defined, it's gonna pass over the sample regardless of normal, Poisson, binomial, it doesn't matter, it's going to preserve. However, if the population didn't have, but if we have enough sample, then sample mean is going to be normally distributed by the central limit theorem. Okay, so that's great. Okay, let's have a look at this one. So it says, now we are looking at the confidence interval for section 4.16. It says 95% confidence interval population mean based on the sample below like this. State one assumption that you made in your calculation. What assumption would you make? Sorry, you got to do A first. So for that one, yes, you can do the calculator, right? So now I got the data. So I need to put the data here. So and make sure you always put the name of the column. So I'm gonna put 12.2. And then the 14.4, 11.6, 15.1, 13.7. So that's great. So what I'm going to do here, my friend, is that I'm going to do the menu statistic, confidence interval, Z interval is what we're going to do, right? And then, yes, I got the data. And I'm going to put the, oh, sorry, I don't have, I think I didn't have the standard deviation from the population, my bad. So I'm going to use the confidence interval for the t, sorry. Yes, that's what we have. And I'm going to put the data there. That's great. And my data was n, right? So confidence interval, yes, 95%. That's as good as it gets. So we got that. So the interval here should be between, 11.57 and 15.23 is what we have, right? The marginal error here is 1.82 is what they're saying. So that's great. It already defines it for you. So that's okay. So interval is going to be between, 11.57 to 15.23. That's going to be my interval. And one assumption is that if you want to use a t-distribution, what we always have to assume is that your population would have been normally distributed. That's the big underlying assumption for either z-test or t-test. Okay, that's great. But it depends on whether the presence of the standard deviation of the population. So that's the one assumption. Comment on your claim, the population mean is 15.3. But if you look at the 15.3, it is, outside the interval of the confidence interval. So it's unlikely that it's going to be the population mean. So we need to have within this mean to confidently say with the level of 95% accuracy that it's going to be population mean, but it's off the interval. So I can't say that it's going to be on the mean. Okay, population mean. This is what we can say. All right. Same thing here. I got the A sample. We're going to use the data. So it can be assumed. Yeah, that's great. So that I can use the t-test easily. So just like we did, you're going to use the t-interval here. Right, then it's just simply using the calculator is fine, which we already have done, so I'm not going to do it again. Let's have a look at this one. So mass of fish is pond is normally distributed. I'm very happy they have defined it for me, and then they have given me the population standard deviation. That means I can use the z-test. For this one, let's use the z-interval. I'm going to use the z-interval here, my friend. But they have given me the static, so I'm not going to use data, but in this time I'm going to use the static. So for that, what are we going to do? Menu 6, go to confidence interval, very good, z-interval, and this time I'm gonna use a static rather than the data. So that's great. So sigma here was 124, and then the x bar was 85, and then the standard deviation. As the mean was 806, and then data was 85 of it, and the confidence interval they wanted to get 95%. That is great, and that gives you the interval here. It's going to be between 780 to 832, as you can see for the lower and upper bound. So make sure, depending on the presence of the, the standard deviation of the population, you can choose either z-test or t-test is what we're gonna do. Okay, that's great. And also, yes, you need to understand about the formula. If you want to get the width and then choose what sample size we have, you got to remember the formula. It's going to be n is equal to twice times the marginal error, okay, of the standard deviation over the width that you want to get. Square is the sample size. I want you to remember, please, this formula. And if I got the 95%, what was the marginal error? You're right. It's going to be 1.96. And that's the formula that we need, right? So it's not in the booklet. Make sure you memorize it. So then you can plug in all the values, right? For the part A, then voila, then it's good to go. 2 times 1.96 is because it's 95%. Please know how to get that, right? The inverse norm of the, inverse norm of the 97.5% because it's a two-tail, right? But anyhow, it's a 1.96 times the standard deviation was given 34 over the width I want to be 5. Square that, you roughly get 710.5. So for that, for the sample size, I want to use the discrete data. So I will round up. So 711 is going to be the value that you need. Okay, so that's how you find the width. So make sure you know the formula like this. All right, so then you can, you could have done all this, fancy work of the, plus minus marginal error of the expected value and all that, but then it's that this formula summarize it. And the essence of AI is that you are able to come up with a formula quickly, and they don't ask you to justify why you have used it. Instead, they're asking whether you can algorithmically come up with the formula quickly, like the computer program. Okay. All right, we can continue with the question 195, but let me take a 5 and come back to you. All right, let's have a look at the next problem here. So it says, construct a 95 confidence interval for the population mean contest. So what you need to do is to choose whether you want to go for the z-test or the t-test. What do you want to do? When you read the question carefully, if it's about the confidence interval, manufacturer bottled water, I don't care. I only care about whether I have the population's standard deviation is given or not. That's all I care, right? And thankfully, yes, what are we given? The water nose machine dispense water is a standard deviation is given, right? That is great. All right, so I got 30 bottles at the sample mean of that, right? So for that one, yes, I can do the z-test. So I want you to use your z-test for a confidence interval. No problem. Because why? The standard deviation for the mean is given for the variant for the population, so that's good for part A. So for part B, all you gotta do is what? Is talking about the width. So yes, we know the formula for the width, right? We know the formula for the number. So the number was previously we have using this formula here, right? So you can rearrange, you can rearrange to find the width, right? Or just get the interval and just get the difference. That's also fine. Yes. But for the width, if I quickly do that, it's going to be 2 times 1.96 times 2.3 over square root of 30 is what we can do, right? So that's great. Okay, so that is part B. And let's have a look at the part C. It is decided that the accuracy of a testing procedure must be improved. So the 95% confidence has an interval of that. So again, so for that one, yes, we're going to use this formula, isn't it? So for this one, I want that interval to be 0.5. with the standard deviation given as a 2.3. Then you can find the number. So the n is given as a 325.2. So more samples you have, the less the interval is going to be to gain that confidence intervals. That is a great, but of course we're counting it. You need to give a discrete data. So I'm going to round up. So I'm going to say at least 326 is required. The more the merrier, obviously, right? So we found the sample size. And then what problems may result from attaining a narrower confidence interval? Okay, so because it takes time to conduct the survey of having 326 samples. Maybe it's we need to consider the longer time of collecting the data is what you can say. Okay. All right, let's have a look at 196. So it says t interval. Why? Because I got the samples. That's great, right? I got the mean. I got the standard deviation, but those are the sample standard deviation, you see. I don't have the standard deviation of the population. So for that, I need to use the t-test. But, they're asking for the confidence interval. No problem. I'm going to just get the t-interval from the calculator. No problem. Let's do that. So I'm going to go to, the calculator. Press menu. Go to statistic. And the confidence interval. T-interval is all I got to do. For that, I'm going to use, stats. Okay. Because we were given those stats. So the x bar, the sample mean was given to be, how much? Let me check. It was mean length was a 38.2, so I'm gonna use that 38.2. Okay, and then the sample standard deviation was given to be how much? 4.7. Right, that's great. And what was the number of sample? It was 42. 42. So on my calculator, I'm going to put n-1. So I'm going to put 41 here. And then the confidence interval, instead of a 95, the question asks 90%. So I'm going to erase it to 0.90. And then I get the upper bound, lower bound. It says 36.96, so almost 37.0. And the upper bound is going to be 39.4, right? So that is your interval. So make sure you are able to use your calculator, okay, to find those intervals, and then find, for example, the marginal error, degree of freedom, etc., is what we do. Okay, so that's great. So 90% interval will be between 37.0 to 39.4. So make sure you're able to use your calculator. Okay, that's great. Sure. So now let's have a look at the section 4.17, our favorite distribution, the Poisson distribution. I want you to pause this video and really try this example because it's very, very important. So let's have a look. Students sign up at a desk activity during the course of the afternoon. The arrival of each student is independent, so it's suitable for the Poisson distribution. And every time, my friend, you're encountering a distribution problem, make sure you're defining your random variable. I'm going to define my random variable x is the number of arrival, right? And then it's distributed by Poisson. I'm very happy to have that. But then the expected value was lambda. But again, for the Poisson, what matters also is your interval, your fixed continuous interval. So it says per hour. Okay, so I'm going to give 1 hour for that. That's great. And now let's read the question. It says desk is open for 4 hours. All right, so we're increasing the time interval. So maybe you need to introduce a different random variable for the different expected value for the Poisson distribution. If exactly 5 people arrive to sign up for the activity, if in the probability you're dealing with, if it's very likely to work with the conditional probability. Okay, that is great. I want to find exactly 3 of them arriving the first hour. Okay, so we are looking for, the probability of x, because it's the first hour, it's 1 hour, so x is suitable. I want that to be 3, given that. But now, I have a total of 5 people during 4 hours period, so I need to introduce another random variable y, which is a 4-hour period. So the lambda is going to be 4 lambda. That's a 4 hour. Okay. So now I have that. And the y is equal to 5 is what we are doing. And for this one, it's going to be who? That intersection. Because we are dealing with the conditional probability over probability of y equal to 5. That is great. And then, now how do we deal with the intersection with its independent variable, right? Independent events. And then what you realize that y represents 5 number of people arriving for 4 hours. But in the first hour, 3 people already have arrived. So now you need to think about the interval for 3 hours, right? That is great. So I'm going to introduce another variable z for Poisson of a 3 lambda. Because you always have to consider for each interval. So for that intersection, now can we put it into the multiplication because it's independent events, right? But when you do so, you need to realize that, okay, first hour, 3 people, remaining how many hours? 3 hours, 2 people is what you want to do. But unfortunately, we can't use calculator for this one, right? Because as you can notice, right, the lambda is not given, but you will realize conditional probability is independent of the lambda because it's going to cancel out. Let's see. So knowing the PDF probability distribution function for the Poisson is very crucial, which you can get it from the booklet. However, obviously we should memorize it. So for the first one is we have e to the power of negative lambda because x mean was the lambda. And then it's going to be a lambda to the power of 3 over 3 factorial is the first probability. For the second one, for the z, which is now given in the 3 interval, multiple of 3. So the expected value is 3 lambda. So e to the power of negative 3 lambda, and then 3 lambda squared over 2 factorial is the product on the numerator. For the denominator, what I'm going to do is e to the power, what is it, 4 lambda, because it was a 4-hour period, 4 lambda to the power of 5 over 5 factorial. As you can see, beautifully the exponent form here cancels out by the property of exponent. So is lambda cubic, lambda squared, lambda to the power of 5. All you got to do is just to simplify the numbers. If you manage, you end up getting this as a 45 over 512. So make sure you're able to perform this conditional probability for the Poisson distribution. Very, very good. Okay, let's have a look at the A. It says, so before doing so, let's define our random variable. Every time you're doing with the binomial or Poisson, make sure you define your random variable. It says number of birds seen on the power line on a day, any day, can be Poisson distribution with the mean of 5.84. So that's great. So that's just one day of a Poisson over 5.84 is great. Okay, and for part A, it's talking about 7-day week. 7-day week. So now I have x7 distributed Poisson of a 5.84 times 7, right? Because the expected value has to change according to the same scale of your interval. Okay, and then we are looking for a probability of what? X7 bigger than 40. That's a CDF, right? For the Poisson on the calculator, I'm going to do 1 minus probability of x7 less than or equal to 40 with the expected value of 5.84 times 7, which is going to be 40.88. Okay, so that's great. So that if you put in your calculator, you're going to get 0.513. So that's great. Part B is a very beautiful question because you need to understand that it talks about the conditional probability. All right, let's have a look. On Monday, there are more than 10 birds seen. Okay, show the probability of there being more than 40 birds in an entire week is what they're doing. So it's a conditional probability. What they're saying here is this. Probability given that on Monday, just one day, Monday is more than 10. In that case, out of 7 days, I want that to be bigger than 40 is what they're saying. Okay, so that's great. So, I got the conditional probability. We can break it down using the intersection. So it's going to be probability of who? X7 bigger than 40 intersection X bigger than 10 over probability of X bigger than 10 is what I've got. That's great. But now you need to really understand what it means by having the intersection with the CDF of the Poisson, right? So imagine, look at this. Imagine that I have, on Monday, bigger than 10. So on Monday, let's say I have 11 birds, right? That means out of how many days? Yes, 6 days. 6 days. How many birds should we have? You're right. I need to have at least, so strictly bigger than 29 to guarantee in total of 7 days, I will have more than 40 birds, right? So that's what you do. Or I can go probability of X equal to 12. Then probability of X6 is bigger than 28. You can do this. We're going to describe it as a series, right? So if I describe it as a series, on Monday, if I got 40 birds, which is very unlikely if you think about, then I don't have to think about the remaining days. Birds, it just have to be at least one bigger than 0. Or at one go, on Monday, I got bigger than 40 birds. I don't need to consider any other days because on Monday, I already cleared out the possibility of having more than 40 birds. So that's great. That is what's going to happen in the numerator. But of course, we can put that in the sigma. If we put that in the sigma, that's going to be sigma r is equal to 11 to 40. So for the highlighted part, I will put that in the sigma because in the product in the same form. So we're going to have, probability of X equal to R. However, probability of X6 is bigger than 40 minus R is what we're going to have. But that red part it's not in the sigma, so that's why it's not described with the index of the sigma, is what we have. So then finally your answer can be put it as what? That sigma notation divided by the CDF for the X is what you're going to say. And that's what the question was expecting you to be able to answer. Okay, so make sure for the conditional probability for the Poisson distribution you need to describe with this product because it's an independent event for the intersection. That is great. Let's move on to the next problem. Very common problem also uses the n solver, but let me quickly show you a trick on the n solver for the Poisson distribution. So I want to find the expected value, all right? I want to find expected value. So I'm given those some of the PDF. That's great. So I'm going to use the n solver for that, all right? So let's go to the menu. 3-1. let's go to menu 3.1. That gives me unsolved, right? So then I'm gonna go menu 6.5, go to the distribution. I'm gonna go for the Poisson distribution. There you go. Poisson PDF. Lambda, I don't know. That's my aim, right? And here I was given that it was a 5 on the left hand side. If it says blah blah, just press enter. It's okay. And I'm gonna do the same thing, right? I'm gonna use those same expression over and over. So let me copy that. Is equal to Poisson of 3 plus Poisson of 4. And I'm looking for the x. But if you do that, they give you domain error because you're dealing with the discrete random variable. And then the question says, oh, I cannot find the integer to find the exact value of x in an integer that will give such information. But you know what? You cannot put the approximation on the x. You can ask him to find around this value, try to guess. So I'm going to just put 1 there. If you do that, they give you the value. So the expected value here is going to be given as a 7.62. Right, so that's what you need to do. So the expected value is going to be 7.62. That's great. So for this, then it's going to be 1 minus probability of x less than or equal to 2. So you can use this Poisson you can use this parameter for the Poisson CDF. Then you get the probability. So make sure for this ends over related problem, just put the approximation next to the x and you're good to go. Okay, that's great. Right, then also make sure sum of the random variable for the linear combination of random variable for the normal distribution is preserved. I get it, but for the Poisson you got to be careful. Only the sum. It does not involve the linear combination. You got to be careful with that. All right. So now Jussi, they follow the Poisson distribution. The Jussi goes by Poisson of 10 signature per hour. Right. That's very important. And then what is it? Kelly, Poisson of 8, that's go by 40 minutes. You got to be careful because the interval matters for the Poisson distribution, doesn't it? Right? It's very important that you understand that. Now we want to get, what is it? 8 a.m. Find the probability that we collect, what is it? At least 250 signature by 6 p.m. So from 8 a.m. to 6 p.m., how many hours? 10 hours, my friend, 10 hours. So now I got to go for Jussi for the case of a 10. It's going to be distributed by Poisson of 100 for 10 hours. That's great. And then for Kelly of a 10 hours, it's going to be, well, it was a 40 minutes. That's 2 over 3, right? And then we're going to multiply that by, yes, that's 2 over 3 hours, right? Ha ha ha. Good. And I'm going to multiply by 30 there, right? No, right? So I got to multiply that by 1 hour, so 3 over 2, and then multiply by 10, right? That's great. So that's the scale factor that I will multiply for my mean. So that's going to give me 120 for 10 hours as well, right? That is great. That is great. So now I can add them together, right? So sum of those random variable is going to be preserved for the Poisson. That's great. With adding the expected value also. So 100, 120, now you got the expected value of a 220. That is going to be the expected value that you're going to use for the CDF here because it says at least 250. So if I call that as an x for the sum, so you're looking at probability of x bigger than or equal to 250. But remember, this is very important. This is a discrete random variable. So for this, I'm going to do 1 minus probability of x at less than 250. But you need to make sure you got to convert it to less than or equal to. So I'm going to go 1 minus probability of x less than or equal to 249. Right, is the CDF we're looking at. And then yes, for the CDF, I'm going to use the expected value of, what is it, 220. And if you did, the probability is going to come out as a 0.0251 and 3 significant figure. So make sure I cannot do linear combination of a random variable for the Poisson, but the sum will preserve the Poisson with the sum of each random variable's expected value. Okay, so understand that. And also, yes, very popular for the mixed variables. So what I mean by is the following. Let's look at this. What I'm given for part A is that it's key result mean number of accidents. So x is the number of accidents on any given weekday. It's just a 1 day, right? Is x is Poisson 2.2. That's just a 1 day. But if you want a certain week, then it's a x5. That's a weekday from Monday to Friday. It will be distributed by Poisson of 2.2 times 5. That's going to be 11. That's your expected value, my friend. You always have to change your interval. And then for part A, we want that fewer than 12, so that's a CDF. But for the calculator, I will change it to less than equal to be 11. So if you put that on your calculator, you roughly get 0.579. So that's great. So that's part 1. And let's have a look at the second part. There are more than 8 exponents given that there are fewer than. So that's a conditional probability, isn't it? For the second part, I'm going to do, what is it? Probability of x5 bigger than 8 given x5 less than 12 is what you're doing, right? So for that conditional probability, this is going to be probability of 8 less x12 over probability of x5 less than 12. And yes, you can use a calculator for this conditional probability. Then you get, roughly speaking, 0.600. So that's fine. So make sure you always try to change the interval depending on the case of a scale factor for the expected value as well. So now let's have a look at part A. B, assuming Poisson model, calculate the mean number of the accidents per day at the weekend. So what we have here is due to the increased usage, it's found that the probability of more than 3 accidents in a day at the weekend is 0.24. So for this, yes, what we can do is simply just to use n-solver. You can use n-solver for this, no problem. Let me quickly show you. So for this one, I will do probability of y less than equal to 3 is 0.76, isn't it? So for that, I will use n-solver. Let me quickly show you. So n-solve. And then I'm going to go to the Poisson CDF. Expected value, I don't know. And then it was up to how many? 3, right? Whatever the error sign, just ignore that. I'm going to let that to be 0.76. And I'm looking for the x. But for the Poisson distribution, don't forget to put just a 0 or 1. That's okay. And I got my expected values is 2.59. So it's 2.49. I got 2.49 is what I have. That's my expected value. That's great. And then I found expected value for 1 day. That's great. And it says calculate the probability that in the 4 weekends in the February. Oh, so this is very important. I want you to be very careful with this problem, right? Because I want you to realize, my friend, that I'm no longer counting the number of accidents for this problem. I'm counting the number of the weekends. So for that, what changed? The counting changed. The distribution will be changed also. So I'm gonna use a different random variable. Let me call it W. And then it didn't say it's Poisson distributed, so that means I need to come up with another distribution. But there's only one distribution. They don't tell you that it's distributed by. It's a binomial. It's a self-telling. So I'm gonna go binomial. And then how many weekends in the on February? 4 weekends. That's good. And how do I get the probability of success? Well, that success comes from the number of the accidents, which is going to be done by the Poisson distribution. That's great. But it's a weekend. That y was a 1 day on the weekend. So I need to then do the y2, 2 days on the weekend, distributed by Poisson with the expected value of 2 times 2.49. For that, I need to get the probability of y2, more than 5 accidents. So if you use your calculator for that, for the CDF, you get 0.380. That is great. So that's going to be my probability of success for the binomial distribution to count the number of the weekends for the containing that number of the accidents. So the weekend is going to be binomially distributed by 4 and 0.380. So that's great. So now I want how many? At least 2 weekends. So I'm going to do probability of W bigger than equal to 2 is what I'm going to do. And for my CDF, I'm going to change kindly to 1 minus probability of W less than equal to 1. Make sure this definitely changes the probability for the discrete random variable. You got to be extra careful. So if you put that result on your calculator, what you end up getting here is that it's going to be 0.490. Okay, so make sure this type of mixed distribution is popular for the exam, especially between binomial and any other distribution. So be able to come up with the right answer for those. Okay, I'm going to have a look at the hypothesis testing for the parameters, but let me take a 5 and come back to you. All right. Let's have a look at the t-test for the bivariate stats. So when we were given this and then we want to see that there is no relation between them and there is some relation between them is how we do the t-test for the linear test, right? So what you can do is simply just put those data, right, on your list. So what I like to do is, yes, let's simply go to the spreadsheet on your calculator, right? Why not? And then let me call it as a Q and E, QW, sorry. And if I put 12, 15, 16, you know, and let's say I got the 4, 6, 5, you know, then you can just simply just press menu, statistic, stat test. And what are you going to do? If you go to scroll down, linear regression t-test is what you want to do, right? So then I'm going to put my X list as Q and then W here. And then yes, it's a two-tailed test because I want to see that there is a relation or there's no relation, right? So if I do that, right, and press OK, then you get the t-static p-value as well. But if you look at the p-value, that's 48.7%, my friend. There's no enough evidence to reject the null hypothesis is what we're going to say, right? So what we're going to say here is that, yes, there's no relation between them whatsoever, okay? So no reason to reject the null. So there is insufficient evidence that there is a linear correlation is what the conclusion is going to be. Make sure you know how to check on the test for the PMCC, okay? That is great. So yes, one error, the type 1 and type 2 is that the okay, so for A, null is gonna be innocent, right? And then the alternative is gonna be the guilty, right? So for part B, the type 1 error is gonna be true, false. That means you want to call someone guilty despite him being innocent, is what it means by the type 1 error. Type 2 error is true given false. So that means you're calling someone innocent despite that person being guilty is what the type 2 error is. All right. So let's try to do the hypothesis test with the type 1 and type 2 error consideration for the next follow-up question for the section. What was it? Section 4.18 from the AI guide, right? That's great. All right, so if you look at it, so now we want to have the null hypothesis being the mean being 2 and then expected value here being 2. So alternative is the two-tailed test, right? So let's quickly read the question. Ice cream 2 liters knows that volume of the ice cream normally distributed with standard deviation. Oh wow, I'm given the population standard deviation. I'm very happy with that, right? The test of the following hypothesis taken for the sample of 10 containers. So, you know, for this one, we're going to do the Z-test, right? So that is great. And then what is the probability that they conclude that the mean is different? What is the probability that they conclude that the mean is different when it's in fact, it's not? So that's what they're saying is the type 1 error. This is the type 1 error, my friend. And yes, for the type 1 error, if you're given the level of significance, it's always the alpha. It's always the alpha. You don't need to compute anything. So it's going to be 0.05 is what we are looking at. That is great. Okay, let's have a look at part B. Now decide to redo the test by rejecting the null hypothesis if the sample mean is less than 1.95 or more than the 2.05. So that's your critical region. What you're looking at there, my friend, is the true critical region. Sure. So that is the what we want to compute, right? So find the probability that indicates that they conclude that the mean is different when it is not. So what you're doing here is you need to decide whether you're doing the type 1 or type 2 error, right? So I'm calling it, what is it? In fact, it is not, right? It is not. So it's a given not. So that's what we're going to do with the type 2 error, okay, which is the probability of a sample mean falling in the critical region given that the null hypothesis is true, right? So, oh, hold on a sec. So that's going to be the type 1 error, isn't it? So this is going to be type 1 error, actually. So let's do that. So I'm going to do the sample mean here is going to be normally distributed over 2, and also, because it's a Z-test given the population standard deviation, that's going to be 0.1 squared over, what is it? The sample cases were 10. So that's great, right? So now I'm going to test on the critical region. We were given that what? It's going to be less than, so probability of who? X bar less than 1.95 or probability of who? X bar bigger than 2.05, right? So that is going to be the the probability that you're going to do using your calculator. And then we are very happy to do the normal distribution here because we got the mu and sigma. So that is great. So if you do, you get 0.114. Right, so that's how you can find those probabilities. You always have to consider what, if you're using the acceptance region or critical region, if you're given the alpha, the level of significance, that's automatically your type 1 error. Okay, that's great. Let's have a look at the type 1 or type 2 error for the Poisson distribution. So it says number of people attending in the gym over the course of an hour, very important interval, right, for the Poisson distribution with the mean of 20. Okay, so X, I'm going to say number of people. Always try to define briefly what you're counting about, and I'm saying X is a Poisson distribution of, what is it, 20, and it's within 1 hour. So that is great, okay? And it says whether the number of the people attending has increased, my friend, increased, right? So that's going to be the right tail because it got bigger. So I'm going to say my new hypothesis is going to be who, my friend? My lambda is going to be 20. My alternative increased, so I know it's going to be right tail. Bigger than 20 is what we are looking at. Okay, state the null and alternative hypothesis. We did that. Manager decided to reject the null, so that's the false, guilty, if the number of the randomly chosen is bigger than 28. Find the probability that he concludes that he has increased when is in fact he's not. That's talking about the type 1 error. I am not given the level of significance. That means I have to compute myself. That's calling someone guilty, given that he was actually innocent, right? So what we are doing here is, yes, I am going to perform the critical region here. So it's going to be, what is it, X bigger than 28, given, my friend, that lambda is actually did not change. It's still 2. So that's the CDF that you want to do, right? So I'm going to CDF of a Poisson distribution of a 20. If you do so, I get 0.0343. As you can see, that's going to be the alpha. That's going to be the type 1 error, my friend. If you want to do the type 2 error, so, the acceptance region, given the false, you need to have a true mean. You need to be given true mean on this case, but we are not given. So, we're going to move on to the next case where it says, okay, true proportion, true mean, true value, true interval, and then you can perform the type 2 error. Let's have a look. So, describe in this context what it means type 1, type 2 error. Okay, let's read. It says a distribution of the wildflower seeds states that they have an 80% chance of germinating. Daniel suspects that the proportion is not as high as stated as planned, so it's got smaller, right? So it's got smaller. It's not as high, so it's not small. It's going to be smaller, so it's going to be left tail, right? We can see that. So it's always important for the hypothesis. It's that you're checking with the null hypothesis. It's going to be the proportion, so it's very likely that it's going to be checking with the binomial. And do we have the fixed number of trials? Yes, we do. We are very happy. And then the alternative is that it's not as high, so they got smaller. That means it's going to be left tail, my friend. That is a great answer. Okay? So X is the seed, right? And I'm going to say X is distributed binomially of, 20? And then 0.8, right? So that's what we're going to check. That would have been used for the type 1 error, right? So type 1 error here, am I giving the level of a significance? Am I giving the level of a significance? No, I'm not giving the level of a significance. So you need to calculate by yourself. You need to calculate by yourself, my friend. So type 2 error is going to be then what? So type 1 error is that I'm going to attack on the critical region. I'm going to attack on the critical region. So what's going to be the critical region here? Too high if it is, that's the critical region. So I'm going to say X less than 14, given the proportion was what? 0.8. Yes. Then for the type 2 error, I'm going to use acceptance region, my friend. So it's going to be bigger than or equal to 14, given whatever the other that the proportion is not the same as the 0.8. So you need to use another proportion, possibly usually given in the question. Okay, that's great. So if I look at the part B, I'm attacking on the critical region with the given null hypothesis. So yes, with that distribution, I'm going to say probability of who? X less than 14. So then you can use a CDF, right? But then for the CDF, my friend, of the discrete random variable, please change it to who? Probability of X less than or equal to 13. So if you put that in your calculator, you get 0.0867. I'm very happy with that. Okay, so that's a type 1 error. Type 2 error is that you need to attack, my friend, on the acceptance region with the true proportion. So what it says is that given that the true proportion here is true mean, true proportion is what you're looking at. So now I'm given X prime is a binomially distributed over 20, but now the true distribution is 0.75. Voila. For that, my friend, you're going to attack on the acceptance region. What was your acceptance region, my friend? Yes, probability of who? X bigger than equal to X prime bigger than equal to 14. So I'm going to use a calculator. I'm going to do probability of 1 minus probability of X prime less than equal to 13 with the proportion, the P as a 0.75. If you put that on the calculator, you get 0.786. That's your type 2 error. That's your type 2 error. So find the probability that he makes in the type. Find the probability. So we did that, right? Given that truth, yeah, we did that as well. State 2 changes Daniel could make to reduce the probability of a type 2 error. Okay, so how would you reduce the type 2 error? You can increase the, what is it? Type 1 error. Or do the more samples, right? If you have more samples, usually it makes always better, right? The sampling, according to the central limit theorem. So those things can be interchangeably given, but it says 2 changes, so that's the changes I'm going to mention, okay? Every time you want to really increase the accuracy, your best bet is that you increase the number of samples. That's usually always true. Okay, so that is great. Yes, let's have a look at the type 1, type 2 error for the Poisson distribution. I'm very happy that I'm given the alpha because automatically, what error do we have? Can you tell me? What error do you have? Very good. You already have type 1 error. I'm very happy. Okay, let's go. So it says the call center receives an average of a lambda calls per hour. Once morning and receive 20 calls between 9 a.m. and 12 p.m. Hypothesis is okay. Alternative is, what is it? Well, but it's I think we did this before. We did this when we were talking about the hypothesis testing. This is nothing to do with the type 1, type 2 errors. I'm gonna skip. We already have done that, so I'm gonna skip. Okay, so let's have a look at the 209. I don't think this is a type 1, type 2. This is just what? The linear test for the T regression. So we already talked about it, right? So if you want to check that, just put that on the X and Y on the calculator. So if I quickly just remind you again, so you put those X and Y, press the menu, and then where do we go? Stat test. And if you scroll down, there's a linear regression t-test because we got just the samples, all right? Then there you can get the p-value, and if your p-value is less than 2%, then you need to, reject the null. That means that there is a linear regression, etc., etc. So if you actually put this on your calculator, let me give you the p-value. The p-value you get is a 0.0256, which is bigger than the alpha. So that means if there's no enough evidence to reject the null, that means we can conclude that the variables are not linearly correlated, is what you're gonna say. Okay, so let's have a look at 210. I want to get into the type 1, type 2 error. Is it talking about the type 1, type 2 error? Yes, it does. I'm very happy. Let's do this. All right, so hypothesis, what is it? Yes, the mu being what? 3.5. And it says 2 tail, my friend. It says 2 tail. So alternative will be that mu is not the same as 3.5. That's great, right? That's great. Okay. It says for 1% level of significance, find the critical region for the test. Okay, so if you look at that, it's always great, all right? It's always great that you try to draw the curve. And then you wanted to have the level of significance of how much of a 1%. So that means I gotta have a 0.5% here and 0.5% there. So the critical region will be smaller than that value and bigger than that value, right? That's great. And then what you can do here is to get a confidence interval. The confidence interval here then will be how much? 99%, right? So I can just plug into the calculator to find the confidence interval, no problem, right? Why not? Let's do that. So is it possible? Well, I got the mu 3.5. I got the sample, and I got the standard deviation from the population, which was 0.15. Of course, it's possible to get the confidence interval. No problem. Let's get it. I go to the calculator, press the menu. Where do I go? Stat. Confidence interval. Z-test is what I'm going to do. Let me put the stats. That's great. Oh la la, the standard deviation for the population was given as a 0.15. And then the X bar is going to be 3.5. And the number of samples were 20. And now confidence interval, because the level of significance, my friend, was 1%. Okay, it was a 1%. So I put 99. Okay, so lower bound is 3.41, and the upper bound is a 3.58. Okay, that's great. Is it possible to paste it? I think so. Let's do that. Okay. Yes, but let's change the color. So that is great. Those are my bounds. Those are my bounds, my friend, for my expected value. So for my the interval here. So lower bound is going to be 3.41, and then the upper bound is going to be 3.5863, like that. That's okay. That is great. Okay. So in this one, what are we going to do? Look at this. I want to figure out what is it. Critical region for the test. So the critical region test will be then the x bar less than 3.413 or x bar bigger than 3.586. But obviously for the critical region, you can convert that into the z. No problem. For that, you just have to standardize that. For the z, we just have to standardize that. So 3.413, how would you standardize it? We can standardize it as a subtract that from, 3.5 over, 0.15 over square root of 20 is what I'm going to do. That's what I can standardize, no problem. So if I put that in, what do I get? Haha. Divided by, oops, sorry. I think at the moment it's complex. I don't want. Sure, and I'm going to divide that by, oops. Square root of 20. That's great. I got the negative 2.59. Okay, so what I got here is going to be negative 2.59. Other one is going to be 2.59, right? So we can find those critical region. That is great. Okay. And then what we can say here, my friend, is that so now I want to get the type 2 error. Type 2 error is attacking on the what? Acceptance region. You're attacking, my friend, the acceptance region with the true mean. Okay, so then you know what? You could have literally do the probability of what? 3.413 x bar 3.586 given, right? X bar distributed normally with now the mean length as not the 3.4 but not as a 3.5 but 3.4. That's okay, right? And then the standard deviation is still going to be 0.15 over square root of 20. That's also fine, right? That's gonna be your true mean, no problem. Let's try to use that, right? Why not? Let's try to use that. So what I'm going to do, my friend, is that we go to distribution, number CDF, right? So then I have a 3.13 for the lower bound, 3.586 for the upper bound. The mean is 3.4. That's true mean. We are attacking on, my friend, the acceptance region with the true mean. And then the sigma is going to be 0.15 over square root of 20. Thank you. So then the probability is given as the following, and that's what the answer is going to be for our case, right? So that's great. So that's how you can figure out the type 2 error. So for me, the type 2 error is going to be 0.349. That's great. And power of test is just a 1 minus type 2 error. So it's going to be 1 minus 0.349 is all you got to do, right? So that is great. So make sure you're able to work using these values for your case for the type 1 or type 2. So it's always about attacking on the critical region with the null or attacking on the acceptance region with the true proportion, true mean, depending on the case. Okay? So let's have a look at the test type 1, type 2 error again for the binomial. Why not? So Ari has a coin which has a probability P giving a head when tossed. She believes that the coin is a fair. Okay, that's going to be the rule, right? So proportion is a 0.5 because it's a fair. And alternative is that it is a biased and it's got bigger, so it's going to be right test, my friend. It's going to be the right test. Okay, that's great. To determine with children correct, 12 times. Okay, so number of times is 12. It's going to be binomially distributed. So you just mentioned the null alternative. That's great. Area rejects the null hypothesis. That's your critical region, isn't it? That, my friend, is the critical region. That's your critical region. What is the name of the given? Oh, yeah, there we go. Haha. So they ask you which region this is, and that's the critical region. I'm very happy. So then you can figure out the type 1 error. So type 1 error is going to be the finding out the probability from the critical region with the given proportion, which is the 0.5. So, what we're going to do is the probability of x bigger than or equal to 10, given that the x is distributed binomially over 12 and 0.5. That's great. So if you put that on your calculator, you get 0.0193. So that's the alpha. That's great. So state the significant, yeah, so we got that. So significant level is 1.93, so percent. So that's exactly what we did. And the type 2 error is going to attack, my friend, on the acceptance region. So acceptance region is going to be what? Probability of x less than 10, so less than or equal to 9 for the discrete random variable, given x now is distributed binomially over 12, but now the true proportion is going to be 0.6. That's great. So you can get the beta. Sorry. You can get the yes, you can get the beta, which is the type 2 error. So what you get is a 0.917. That's great. Then you can do the what is it? Power of this test is going to be 1 minus beta. It's going to be 0.0834. Okay. So area is used the decision to rule from B, and type 2 of the error is at risk of making. So which one has a very high chance? Yes, the type 2 error. So we're going to say, okay, she's at risk of making the type 2 error is what we're going to say. Okay. So no problem. Type 1, type 2 error is really a piece of cake. Attacking on either acceptance region or the critical region is what we're going to do. Okay, let's have a look at again the type 1, type 2 error for the, what is it? The Poisson distribution. Very good. Let's have a look. So I got the, what is it? I got the null hypothesis and then the alternative hypothesis. Very good. Okay. So random variable says that where line is 3 or 4 to test the value of the, so random variable samples, there are 9 samples of it. Okay. So my so here, I think what you need to do is to see which one is going to be your critical region, right? Your critical region is whatever the fancy variable that you're going to use, bigger than 37 is going to be your critical region, right? Because if it's less than or equal to 37, we accept. That's what they're saying. But how many samples are we collecting? We are collecting 9 samples. So x will be distributed by Poisson of 9 lambda is what we need to say. Okay? So if you want to find the level of significance, that's a type 1 error. That's an alpha. That's a probability of what? Attacking on which region? You tell me now, my friend. Yes, the critical region. The critical region, we just defined x bigger than 37, given x is distributed by Poisson of the null hypothesis, which was a 3, isn't it? We multiply that by 9. That's going to be 27. Very good. And for that, we're going to use now what? 1 minus probability of x less than or equal to 37 is what you're going to do, my friend. And if you do that with the expected value of 27 on the CDF, you get 0.0263. So that's going to be your alpha. Your alpha is going to be 2.63%, my friend. Very good. Power of test, you need to get the beta, the type 2 error first. Which region do you attack? Yes, you're going to attack in the acceptance region. Happily, we are given the acceptance region. So it's going to be probability of what? X less than or equal to 37. But you need to be given the true mean. The true mean here, it says what? It says 4, right? So then what we're going to do here is x now is distributed by Poisson over 4 times 9 sample. That makes it 36. You're going to use now the expected value of a 36 for the type 2 error for the acceptance region, my friend. For the CDF, I can just put the right away with the 37. And then your beta is going to be 0.609. All right, that's great. The power of the stat will be then 1 minus beta, which is going to be 0.391 is how you get it. So please, type 1, type 2 error, you don't have to be scared. It's always about the what? Critical region, attacking on the critical region or attacking on the acceptance region. That's it. It's a piece of cake, okay? All right, section 4.19, it's talking about the Markov chain. No problem. It's the byproduct of the eigenvalue, eigenvector. Piece of cake. If it's a 2x2 cases, sometimes they ask you to find the eigenvalue, eigenvector. If you can't be bothered, just put a higher power on it. You can find the steady state very easily. Okay? Manufactured by this next car. So it's gonna be, what is it? write down what does A and M indicate here? Automatic, manual. Probably there's someone who currently owns the manual buying automatic. So M to A is what you're looking at. So M to A is what you're looking at. So that's going to be 0.35. So what the question here asking you whether you can translate, my friend, the matrix is a from to, right? So that's great. So it's going to be, what is it? 0.35. Long term. So if you want a long term, if you want to find steady state, really, you could do the eigenvalue with the 1 and try to find the eigenvector, put it into the probability form, but you just put it in the power of 100, no problem. And it's going to become the same probability over and again, no problem. Let me quickly show you on the calculator, right? So if I just quickly put a matrix, it was a 0.95, 0.05, 0.35, 0.65. And then let me put that in the power of 100. Why not? So as you can see, each column has got the same thing. So it will have a steady state. I'm very happy. So in the long term, the manual cars should be in the second row. So it was a 0.125. So that's going to be 12.5%. That's all I got to do. That's all you got to do. It's a really piece of cake. It's not that bad. So for part A, if you read the question carefully, just pause the video, read it carefully. What does it say? Next penalty is 0.95. So the transition matrix is going to be 0.95. It's a complementary, so 0.05. And then next time is 0.8. So it's going to be 0.2. That's my transition matrix. Try to go by the column. And then given that he missed his last penalty, he missed it. He 100% missed it. So initial state is going to be 0.1, right? Because he missed for sure. What's the probability that he scores with his third penalty? So it's going to be, what is it? Transition matrix multiplied 3 times. So if you put that on the calculator, you get 0.938, 0.062 is what you have. Very good. Find the steady state, no problem. You know what? You can do the eigenvalue, eigenvector, all that. But what you just have to do is put it in 100, no problem. You don't need to sweat too much. Yes, you can do the, transition matrix times the steady state with the one eigenvalue times the steady state. But why bother? If I can do this very quickly by just putting into the higher power, that's okay. Especially for the 3x3 case, it's even better because they do not expect you to find the eigenvalue for the 3x3 case. Just put a higher power on it, absolutely fine. But yes, as we have discussed before, please make sure that you are, my friend, able to describe what it means for the entry, right? It's very, very important. What does it mean by row 3 and then the column 1? That probability, what does that mean, my friend? Right? We need to understand. It's always about the interpretation. You need to understand what it means by the context. It means there are 10% of the land, which is very good, will be very poor next year, is what the question is. From to, okay? From to. That's great. So we know how to translate things and then describe the land quality after 3 years. That means you just have to put in the power of cube, right? For what? What's the initial state? Is all very poor, so it's going to be 0.001. Then you describe the probability of the 3x1 column vector, and then what you see at the end, at the very land quality after 3 years, you can describe each of them, right? So transition matrix, Markov chain, really piece of cake, but you just have to be able to translate well. Again, if you want to find the long run, don't bother with the eigenvalue, eigenvector. Just put a very higher power on it. That's okay. What I'm going to do is just put it into the power of 100. That's fine. Oh yeah, you can do 550. So it's also okay, right? So steady state is piece of cake. So what is this? Give an estimate of the distance travel. Okay, don't worry about that. But anyways, okay, so let's have a look at the topic 5. The reason I didn't really write much on the topic 5 is most of them are very similar to what I already have mentioned for the last minute AA revision topic 5. So if you want to go over more details of the rules of differentiation, applications of differentiation, and integration, please check the video. It's a very similar, and I will only go over very special cases of a calculus, okay? For the AI special. So most of them are very similar to the AA, so please do go over, but I will do go over some of the AI special cases. So if, for example, section 5.8 says, yes, we need to know the trapezoidal rule, so I will mention about it, okay? But before I do go over, let me take a 5 and come back to you. All right, let's have a look at the trapezoidal rule. It's the approximation method, isn't it? So, if I have a curve, instead of writing a rectangle, right, we are trying to make a trapezoid, right? And then typically the formula goes by the following, right? So if I have it like that, the formula was the delta x over 2, and then you have the starting y value and then the last y value, and then twice of all the value in between, right? So that was the formula that we did for the trapezoid. So we are not using the rectangles to find the area. We're doing the trapezoid to find the area, right? So that is great. So, if I have a question like the okay, so if I have a question like this, well, typically what you're given here is the first kind is that you usually are given a table, right? So imagine that you are given a table of a t, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and v as a 12, 14, 17, 21, 22, 21 savage, 15, 11, 11, 14, 17. If you got the table already, then it's easy, because we can just, we say that we're going to integrate from 0 to 10, right? Let's say of the velocity to get a displacement. But now I don't have a function, I got only those discrete data. Then you can do, the delta x. Well, delta x is uniformly defined to be 1, so 1 over 2. And then the first and last y value will be 12 and 17. So 12 and 17, and you double all the y value that you have, so 14 to another 14 there. Then put that in the calculator, right? So if you do that, you get 160.5. So that will be the approximation for the displacement, right? If it was representing for the velocity. So if you got the table already, that's good. However, if you look at the next problem here, it doesn't have the table, right? By the way, this is a very important error function for the normal distribution, right? For statistic. But anyways, sure, use a graphing package to help the sketch. Oh yeah, it looks like this. Typically looks like this. Okay, so that's the error function, what it looks like. So we have it, right? So now, if you want to calculate the lower and upper rectangle sum of interval using n equal to 225. Okay, so we are trying to find the, what is it? From 0 to 3. It is a decreasing function, right? It is a decreasing function. So your left sum is going to be the upper bound. So left sum is going to be the upper bound because it's a decreasing function, right? So what we can do here is to use, the rectangle formula for this one. So it's going to be integrating from 0 to 3, e to the power of, negative x squared over 2 dx can be given by, the partition of a 2,250. So if you do so, your left bound is going to be, 1.2493. Sorry, your left sum is going to be given as such. And then your, so that will be the lower sum. So that's going to be the right sum, because that's going to be the lower sum for decreasing function. And then, but for the upper, if you put that on your calculator, you get the, 1.2506. So that's correct, right? So you can find the lower bound, upper bound, right? And then using the symmetry of that to compare your answer with these. Okay, so what they're saying here is a symmetry by the y-axis. So if you want to integrate from -3 to 3, you just have to double what you have under the curve there, right? So what we can do here is -3 to 3 of the function, because it's an even function, it will be twice of from 0 to 3 e to the power of negative x squared over 2 dx. So that will be finding the, twice of the average that you have from the left sum and the right sum. So it's just going to be simply the sum of these two, right? So that's great. So that's going to be an approximation. If you add them together, you get 2.4999. So roughly speaking, that's a 2.50. And if you put that on the square root of, 2 pi, on your calculator, you can see the difference. So it's going to be square root of 2 pi. Where is it? Pi. There you go. So it's a roughly speaking 2.5066. Right? So very close to the estimation. Right? How many subinterval says are necessary so that it's going to be more accurate then the lower and upper rectangle sum in part B. Okay, so now that's the trapezoid, right? Now that's the trapezoid, right? So what you can do is you can gradually start dividing, right? So you can start dividing by 1, 2, 3, going all the way, and then you can decide which interval is gonna be better for you, right? So if it's from 0 to 3, then your delta x is going to be, it can be 1, it can be 3 over 2, it can be 3 over 3, it can be 3 over, 4, etc. Oh, sorry, it's gonna start from 3, isn't it? Yes, and then you need to decide that which delta x over 2 times y naught, yn, plus y1 to yn minus 1 is going to be better approximation, is what you need to decide. So if you just play around, you're going to end up saying that n equal to 7 is going to give you the better approximation. So make sure you're able to work with the trapezoidal rule, okay? And I suspect that, it's obviously it's going to be not as big, not as large as the rectangle, because the whole point of a trapezoid is that it reduces the gap, so it's going to be very small interval comparing to the rectangle, okay? Sure, that is one thing that I had to mention from the section 5.8, and then let's move on, right? So, all the other things, geometry and integral, etc. I already mentioned it. In where in the AAHL. It's a very similar approach, so I wouldn't go too much in this video, but I want to go over the special topics that we need to be aware for the AI special. For differential equation also, like the separation of variable, I already went over a lot, so please go over. But I like to talk about the ones that are special for the AI, which is going to be approximation, such as the slope fields, isocline, and then the Euler's method. So let's have a look at this. So here, find the missing values of the gradient of the tangent to the solution. So, the slope field is to get the gradient of each point and then trying to find the isocline on that, right? So let's see what gradient we are missing. So if this was x and y, you can put those x and y to your derivative and be able to find them, right? So if I put 1, as you can see, your gradient is going to be simply 2. If I put 1, 2, that's going to be 3, 4, 5, 6, 7, 10, 11, 12. Those are the missing gradient. We are happily able to present that because we can just plug into your differential equation. That's great. Sketch the slope fields for the differential equation. So if you want to sketch the slope fields, what you need to do is, we try to do the xy plane. Let's do that. And then what you want to do, my friend, is to put those put those dots, and on those dots you're going to represent the gradient. So for example, if I have a 1, 1, the gradient is going to be 2, is what you're going to indicate on this lattice diagram. So if I put, for example, 3, 3, the gradient is what? 12. Is very sharp, is how you indicate. But for example, if I put negative 1, 0, negative 1, 0, in there the gradient is going to be negative 1, so it's going to be decreasing like this, right? If it's a 0, 0, the gradient is going to be 0. So you just have to indicate all the values there, but it's obviously a lot, so help yourself if you want to do it. But this is how we can represent them. Use a slope field to sketch the solution. Yes, because it's slope fields, depending on your initial condition, the general solution might change the shape. And for this one, for 2, 2, 2, negative 2, so here you need to indicate what the slope is going to be around, so then you can sort of sketch your solution like that. But obviously it requires more the representation of a slope field on other coordinates, so you should indicate more, but that's pretty much how we can do. Okay, so from this topic here onwards, we want to focus more on the special calculus parts of the AI, starting with the differential equation. But let me take a 5 and then go over the next topic. All right, and we should be able to demonstrate the slope field and its general solution depending on what the initial conditions. So, for example, we initially had, the x squared plus y, right? So if you want to demonstrate the slope field on your calculator, you can do that by, changing the graph entry into the differential equation. And here you can put that value, so it's going to be x squared plus, but make sure my graph entry says y1, so I'm going to put y1 there, right? So if you just press enter, it shows the slope fields, right? Then if you want more slope fields, what you can do here is press the menu, differential equation. So on your previous entry, what you can do is go here, click this setting here, and yes, for the resolution you can increase. So if I press, for example, let's say 30, then it's going to show you more slope fields than the previous part, right? So that's great. And if you want to find a general solution, my friend, you need to find particular solution, sorry. You need to put your initial condition. It was 2, -2. So if you want to demonstrate your solution at the particular solution, this is how you can demonstrate, right? So that is very lovely. All right, so make sure not only getting those values manually, but be able to, you know, visualize according to the, the calculator. So if I look at the, the question number 222, 220, if you want to demonstrate the slope field, you can do the same thing, right? So if I quickly go to the calculator and graph another one, press, the graph entry, differential equation. For this one, what am I going to put? I'm going to put the, and this time it was something with the log, wasn't it? So let me double check that. It was a negative y2 times ln of y2 over 2. So if I put that, oops, sorry, let me just create another graph, my bad. So if I did here, menu, graph entry, differential equation, here I'm gonna put my negative y1 times, ln of a y1 over 2. So then I get slope fields, right? So here, and also they ask me to find the general solution from 0, 0.5. So you can also do that by putting the initial condition here. What am I going to do here is I'm going to put the 0 and then the half. So if you do so, then you can find a particular solution like that. All right. So that's great. Okay. So explain why the model might be suitable for modeling the growth of a tumor, right? Because it was like a sigmoid, isn't it? So the maximum size of a tumor agrees with the fact that it grows environment when it's so you know, for this one it doesn't go blow up. So thanks to God, right? So the tumor is gonna stay like with the horizontal asymptote is what we see, what it seems to be, and then that's what we're gonna say. Okay. Sure, so be able to visualizing the differential equation is very important. So yeah, construct a slope field at the points where integer conditions. So yeah, you know, you can do the same thing. Really, you can just put it onto the calculator, and then try to find the sketch the solution curve. No problem, right? And what can you say about the solution curve corresponding to the initial condition? Yeah, you know, you can, as we just have done, you can do the same thing, right? You can just change it to graph entry, put it into the differential equation. Put the initial condition to find the particular solution is what you want to do. Okay, no problem. So the use of calculator really give us the chance to find the solution. So that's great. So yes, this was one of the very famous exam question from the past exam paper, and when you were dealing with the topic or option topic 9, the differential equation. Let's try to sketch the isocline. So for this isocline, we should be able to sketch by hand. So if you look at the isocline there, so it's going to be, what is it? Oh, no, I think the part that I wanted to talk about is part D. So if you want to sketch the isocline, what you do here is that you're looking at the x equal to y squared. That's a parabola. So it looks like this. Okay, and the isocline, all those coordinates indicate the same gradient of a 0. That's what that 0 represents when the dy over dx is a 0. Right? So on that, all the coordinates there is going to be 0. Okay, so that's great. So that's where all the stationary points are going to happen for whatever the solution that you want to have, depending on your initial condition. It says for the general solution, the fx, it cannot cross the isocline because if you try to draw another isocline with the slope fields, so for example, let's do the x minus y squared is equal to -1, right? So for that, I have x equal to y squared minus 1. That isocline is going to be a parabola with the y-intercept plus minus 1. Okay, I get it. And then there is going to be the negative gradient. Okay. That's great. And then what you can do here is draw another isocline maybe I would put that as positive 2. Then you have x is equal to y squared plus 2. So when y is equal to 0, x is going to be 2. So that isocline is going to look like this. On that, the gradient is 2, so it's going to be sharper. So, my solution looks like this. It's going to decreasing, but at that point, it's going to be stationary. And here, it's going to be increasing, right? However, think about if it cross over that isocline after x bigger than 1, after x bigger than 1, if it cross over the isocline, that would suggest as soon as it crosses over, that gradient is supposed to be positive. But as we know, fixed by that isocline here, anything to the left will indicate the negative gradient. So the contradiction arises. So you can show the answer like that by visualizing the solution. So you need to really indicate where it's going to be negative gradient and where it's going to be positive gradient. Hence, it cannot cross over, because as soon as it crosses over, you show that it's going to give you positive gradient. That's a contradiction. Okay? That's great. Yes, let's talk about the Euler's method. You're going to be dealing with Euler's method all the time, right? So if we quickly have a look, it says what? Consider differential equation xy. So, what we're doing here is to use initial condition to get the gradient of a tangent, right? So for this, what you have here is that I can do the, I got those x and y, and I can get the gradient of tangent by plugging into the differential equation. And then what I can do here is that for that, the tangent, for that gradient, I can create, tangent line. So -1, x minus 0 plus 3 is -x plus 3. That's my tangent line, right? And then for the small increment, I can plug that in to approximate the next y. So what you're doing really here is trying to use bunch of tangent line to approximate for the next y line, right? While making the small gap, right? So since I got this x and y, you can put this again onto your the differential equation to get the gradient. In this case, it's going to be -0.71. That's great. And then with that gradient, with this passing point, you can create another tangent line equation. So it's going to be y is equal to -0.71 times x minus 0.1 plus 2.9 using the point gradient formula. Then my next x is going to be with the step size length of 0.1, so it's going to be 0.2. You put that here. So that's going to be the delta x, which is always going to be 0.1. You multiply this and add that together to approximate the next y value. So it's going to be 2.829, right? Then you use those two values again to create another tangent line equation to approximate for the next step. It goes on and on and on, right? And then you can complete the table. So if you do, what you're going to end up getting here is a 0.4. It's going to be 2.7691. And the gradient here is going to be 0.1077. 0.5, 2.7799. So make sure you're able to complete those tables by showing them that you're creating the numerous tangent line equation to approximate. So plot those solutions. You can do this easily on the graph, and then we can demonstrate what the particular solution is going to look like. So what we want to show is to show this by the sequence. And let me quickly show you how we can plot this sequence on the calculator. But before doing that, let me take a 5 and then come back to you. All right, let's have a look at the Euler's method for the coupled linear differential equation. No problem, okay? It's not big of a deal. You don't have to be scared. But what we need to be able to demonstrate is that we can use our calculator, right? And make sure you're able to display the sequence on the calculator. So let's go. So what we're going to do here is we put a graph on it, okay? And then press menu, go to graph entry, my friend, and then go to sequence, and then sequence. So here we're going to put in recursive form. So for the time series, we're going to put the u1 and -1 plus, it depends on the step size. If you look at the step size here, it says the step size is a 0.1. All right, so I'm going to say 0.1. Initial term to be 0 for him, and then I need to go up to, so yeah, let's just do that, right? No problem. And then I put another one. For that one, it's gonna be the progression of the x. So that's gonna be from the previous x value. I'm going to demonstrate the change which is given by the product of the step size times the derivative of the x, which is given by the differential equation. So if you look at it, it's got the dx over dt. I'm going to put all that, right? So the x and y will be demonstrated by u2 and minus 1, u3 and minus 1, which is the recursive form. All right, so I'm going to multiply the step size with the differential equation. So that's going to be 0.005 times, it was x. So I'm going to put u2 of x minus 1. Right, so that's the the differential equation that I want to demonstrate. Okay, and I think I have to put the bracket here. Oh no, so it was that one times x times, and then the bracket u2 of, and oh sorry, not x, my bad, yeah, I'm n. And then the u2 and minus 1. That was the x minus 3 times u3 and minus 1 to demonstrate that's the y, minus 20. Okay, then my friend was the value. So initial value for the x, where x represents the population rabbit, and I was given that it was 150. All right, so that's great. I'm going to press enter for that. Now I'm going to go for the next entry by pressing the tab on your calculator to demonstrate the change of y. So I'm going to put the y, so u3 and minus 1 plus the step size 0.1 times the derivative, which is given by 0.005 times u3 and minus 1 times 3 times u2 and minus 1, because in the differential equation that's a 3x minus 5 times u3 and minus 1 minus 300. I'm very happy with that. Then the initial term for the fox was 40. So I'm going to press that. And as you can see, it's not demonstrating anything because we didn't set up the domain correctly. If you think about the initial, value was 150 and 40, that's pretty large value. So what I like to do here is maybe just press the zoom fit. I would just press the zoom fit, and then the calculator is going to find a suitable y value for me. So that is great. And then what the question said was, is to demonstrate the, 6 month. So if you look at it, my t is in years. So if you want 6 months, that's going to be 0.5 years. So what you're looking at is when the time is equal to 0.5. So then we can go to the calculator again, press menu, and then go to table, all right, and split screen table. And here U1 represents the time series. So what you really want to look at is the x and y, which is U2 and U3, when the t, the U1 is 0.5. So we're looking at if you round up for the three significant figure, U2, the rabbit, is going to be 157, and then the fox is going to be 37, right? So if we have a look, so then yes, the x of 0.5 should be 157, y of 0.5 will be 37. So that's how you can use the couple linear differential equation with the calculator. So that's very lovely. And the same thing here, really, all that, with the initial value, you can use the Euler step to demonstrate, and then find the depth of the water after 3 months. So if it's 3 months, let's have a look at the unit for the time. It's in years. It's in years, my friend, and it's talking about 3 months. So that means 3 over 12. So that's 0.25 is the t value that we want to do, and then you get the x value for that, right? So you can perform the same thing as we just have done, trying to make sure that the u1 n as a recursive form, u1 and minus 1 plus the step size here, and it was a 0.01, very lovely. And the u2, which represents the change of x, is going to be u2 and minus 1 onto the previous one. I'm going to multiply the step size, which is the 0.01 times, what is it? For here, my differential equation dx over dt is now given as a negative 0.2 u2 and minus 1 cosine pi. And that t is going to be given as a, u1, my friend, and minus 1 is what you're going to do. Very good. Okay. And then that's it for the dx over dt, right? And the same thing for the dy over dt, right? So for that t, yes, we need to use the u1 and minus 1, right? So then in that case, you should be able to demonstrate the solution also, and then you'll be good to go. So make sure you put that in your calculator to see if you can manage to get the x of 0.25 is going to be 8.12, y of 0.25 is going to be 9.46. So make sure you're able to get those values by using the calculator. For that t, make sure you put the u1 and minus, well, whatever the x value you did. But for me, it's better to always stick with u1 to 3. So every time I have to solve the differential equation, I will make a new spreadsheet that clears everything that I have done before. And it starts with the clean sheet, it's less confusing. All right, so that's great. So yeah, let's have a look at the differential equation, right? So the final part of the differential equation for the AI is to work with the eigenvalue, eigenmetrics, and find the general solution, right? So find the general solutions for the system and sketch the phase for at least 3 trajectory. Okay, so why not? Let's have a look at the part A. Okay, so if we have a look at the first one here, right? What you want to do is to find the eigenvalue first. So I'm going to do determinant of what? It's going to be 2 minus lambda, 3, 2, 1 minus lambda. That's going to be a characteristics equation. So if you actually try to solve it, then the lambda 1 is going to be -1 and lambda 2 is going to be 4. That is great. And then for that, you can find the eigenvectors. We already have practiced a lot, so I will give it to you. Okay, make sure you're able to solve this matrix algebra. And then the eigenvector for the first one is given as a 1 and -1. And then for the 4 eigenvector is going to be given as a 3, 2. All right, so your solution here, x and y, in terms of t, will be given as what? Constant coefficient times, e to the power of -1t times eigenvector plus constant coefficient e to the power of 4t times eigenvector 3, 2. So that's the general solution that we have, right? And since the eigenvector, one of them is negative, so as the t gets bigger, that's going to go to 0, right? So the trajectory is going to be approaching the equilibrium and move away. So we're going to have, saddle point. So you need to understand if one of the sign has the negative, it's going to be having a saddle point. So if I quickly, my friend, put the xy axis here, right? In that case, we can put the eigenvector. Okay, we can get the eigenvector as a 1, -1, so it's going to go like that. And 3, 2, it's going to go like that, right? And then as you can see, because it's a negative, right, what's going to happen? 1, -1 is with the negative. So for that, it's going to be going to 0. But if it's a positive rate, it's going to move away, right? So that's what we have. So it's going to have a saddle point, right? So it's going to be unstable. So we're going to have a trajectory like this, and then like that, like this, and like that, right? So you need to understand that if I have one of the eigenvalue being negative, and along that eigenvector, it's going to be moving towards 2. If you try to get the second differential equation, and for that, let's just create a extra page because we want to describe with things with the different signs for the eigenvalue. So if you try to do the eigenvalue, eigenvector for this, what you get here is that the eigenvalue is going to be -4 or -25. You can see yourself. And then the according eigenvector, respective of them, is going to be 1 over 1, 1, and 2, -5. So that's great. So your general solution is going to be given as coefficient and e to the power of -4t, 1, 1, right? So it's going that, and plus b, e to the power of -25t, oh my god, very fast, 2, -5. So it's going to be stable, right? Because both of them are negative. So it's going to be stable system. So and what you want to do is that on the the xy plane, try to draw the eigenvector. So it's going to be 1, 1, and then 2, -5. So it goes like that. And then, then all of them is going to be going towards each other because they all represent with the negative eigenvalue. So that's great. So, the trajectory that we can do is that, sure, it's going to be like that. right? And it's gonna go in that direction, right? And it's gonna be like that as well, no problem, easy peasy, lemon squeezy, right? So then we want to have a look at also one with maybe both being positive, right? So let's see if we can have one of those. If you look at the, what is it? Let me try to find an example with the both of them being positive. I don't think we have any of the example here with the positive, but if it's moving away, you know, imagine that I've got this face portrait, but then imagine that both of them were giving you the, you know, positive, right? So in that case, then you need to, along the eigenvector, it's going to be moving away, isn't it? So yeah, it's going to, you know, be going like this, going like that, going like this, going like that is also fine, right? So that's great. So is what we can do, okay? And then the another thing for the imaginary part, so let's have a look at the use of a complex number to describe the solution here. So if I was working with the part A by adding another page, right? Let's try to write as neatly as possible. So this is my differential equation, and if you try to find the eigenvalue and eigenvector, what you get is a 5 minus 2i. It's going to be 5 plus 2i. And then the according eigenvector, you can get it. However, if you want to just describe the phase portrait, you know, what do? You know, for this one, I see that the real part is a positive, right? So you know that it's going to be, what is it, spiral out. It's going to be spiral out, right? So, and the eigenvalues are complex, and the real part is a positive, so trajectory move away from the origin, and it's going to be spiral manner. And then what you want to do here is that is to check the sign of the derivative. If you put, for example, the some of the initial conditions, so let's put, so for example here, right, let's put the 0,1 onto our differential equation and just check the sign, right? So if I put 0,1 there, dx over dt is going to be negative, and if I put 0, t, that's going to be dy over dt is going to be, what is it, 4, so it's going to be positive. So that means it goes up to the left, so it will go in that direction, right? So what we can see here is the general solution is going to look like that, right? It's going to look like that. So that's great, because at that 0,1 we know that it's moving up but to the left, so it will go that anti-clockwise, right? So that, and then we know that it's going to be spiral up because the positive real part, and that's how we can determine, okay? And let's have a look at the part B. So for this one, yes, you are more than welcome to perform the, you know, determinant and characteristics equation, and you will be able to find that the eigenvalue here is going to be plus minus 2i. That is great, and it's purely imaginary, my friend. It's purely imaginary, so it's going to create a what is it, the stable equilibrium point at a circle, right? So if we try to demonstrate on the xy plane, what I can do is that the origin is going to be a stable equilibrium point, right? So it's going to the center, so then we're going to have a stable like that. Then yes, I want to see if it's going to be clockwise or anti-clockwise. I don't know that, right? So that depends on, you know, one of your initial conditions. So again, you know, if I put, for example, 0,1 in here, right, then my dx over dt is going to be, what is it, positive. And if you look at my dy over dt, that's going to be negative. So that means it's going down to the right. So it's going that direction, it's going clockwise. So my spiral is going to be like that. So you can draw the direction easily. So make sure that you are trying to use one of the initial conditions and decide what direction it's going to go. Okay, so that's great. That is great. So if you look at the part C, and then try to find the, what is it, the characteristics equation on him, you find the eigenvalue to be negative 0.1 plus minus sign, and as you can see, the real part is, what is it now, the negative. So it's gonna go spiral in, isn't it? It's gonna go spiral in, and as you know, for the spiral in, I need to know what direction it's going to be, whether it's going to be clockwise or anti-clockwise. And again, for that you can use your initial condition. So if I use a 0,1 there, it's going to be spiral in because the real power is a negative. And then if I put 0,1 there, then dx over dt is negative. If you look at the dy over dt, that's also negative. So at the 0,1, it is going to the left and down, right? So it's going, that direction. So that's going to be, again, anti-clockwise. So what we can do here is that it's going to be spiral in. And then even though we draw a spiral like that, right, it's going to... No, sorry. It should be the other way, like this, so that we know going to the anti-clockwise will give you the what? The spiral. And if you were sketching other way around, that would have been a spiral. We didn't want that because for the real value that's negative, it should be spiral in because exponential is going to decay to 0. Okay, that's how we can figure out. So yes, show that. So second differential equation, sure, if I have, this is a homogeneous case, then you can solve it algebraically by putting into the couple linear form. So if we let the dx over dt to be y, then the second derivative with respect to t squared is going to be dy over dt, right? So that we can substitute that in. So dx over dt is going to be, if you rearrange, so it's going to be dy over dt plus 2x, right? This is what we can find, right? So that's how you can figure out the, oops, sorry, my bad. If I do it again, the second derivative is now dy over dt plus, minus dx over dt, but that was already y. So minus y minus 2x is equal to 0. So for that one, you already have dy over dt being y plus 2x. So as you can see, this is what we have. And if it's a homogeneous, yes, we can use what we just talked about with the couple linear differential equation with the eigenvalues, and you can find the general solution. So if you try to use the characteristics equation on that, right, then you can figure out the eigenvalues, and then you can find the general solution. But here's the thing, they ask you to find the Euler's method, right? If you want to use Euler's method, we can use actually the method that we just discussed, right? So why don't we use it, right? So let's try to put it into the calculator for this couple linear differential equation we already have talked about, right? So if I quickly go to the home and then go to calculator, and then go to the graph, and then I'm going to press menu, and then go to the, where do I go? I'm going to go to the graph entry sequence, right? And then here, that's going to be my time series, right? So my time series here, I believe the question gave you the step length of how much. It was, let's say we want to do the 0.5. Let's do this. Then the initial condition was given as a 0, and okay, that's great. So let's see what we can have. And here, if it's half, then I'm going to do u1 and minus 1 plus 0.5. And the initial value for the step is just going to be 0. So that's great. And then let's create another one. That's going to be for the x, right? That's going to be for the x, my friend. So that's going to be u2 and minus 1 plus the step size was 0.5 times you got to multiply by the derivative of the x. And then that was given as a, y. So that I'm going to use a u3 of n minus 1. That's great. And then the initial value for the x was given to be 0. So I'm going to put that, and then we move on to the next part. And then we put an entry again. That's the dy over dx, isn't it? Sure. If I use the dy over dx, that's going to be, from the initial y, we put the h times the dy over dt, which is y plus 2x. That's great. So let's plug it in. So here I'm going to put u3 and minus 1 plus 0.5 times, what do? I put the dy over dt. So it was a y plus 2x. So it's going to be u3 and minus 1 plus 2 times u2 and minus 1, which is the x value, right? So, so then initial term here, the initial y value, let's think. What we are given here is that the dx over dt at 0 was 2. That's same as the y, so that's going to be 2. So your initial value for the y will be 2. So I'm going to put the initial term as the 2 for the y value. So that is lovely. So we got this, right? So if I quickly go like that, then press the zoom fit, you know. Oh, well, you know, it's going to be an exponential function, so maybe I shouldn't have put the zoom fit because it's too large. However, what you were supposed to do was what? When the, x was 10, right? So when t is equal to 10, right? So what you can do is go to the calculator, press menu, press, table, split screen table. Here, I need to find when the t becomes 10, right? So when you see that, my x value is now 699,000. So for the 3 significant figure, I think that would be great. So I'm going to say 699,000. So that will be the approximation. To answer more accurately, you know, what I think you could have done is to, you know, increase the step size. Reduce the step size. You could have gone 0.1 or 0.01. That would have been definitely better. Or solve analytically, right? We can solve the question using the the auxiliary equation and all that. So that's great. Okay. But for this one, I want you to realize this is inhomogeneous. This is inhomogeneous. If it's inhomogeneous, as we already talked about, I cannot solve it analytically. So I must use the Euler's method. So it's inhomogeneous. This is inhomogeneous. Inhomogeneous. So we must use the Euler's method, and we already showed the process already on that. So let's suppose that we already know how to put it into the couple linear form for the inhomogeneous case. But we are not going to we can't use matrix now because it's inhomogeneous, no problem. We can still use the Euler's method. And the thing is, yes, for those y and x, for the x, we're going to use u2. It's going to be u3. However, for t, make sure you use u1. Okay, and let's see if we can actually use those methods for the inhomogeneous case in our calculator. So let's go. So here, what I'm going to do for you is to create another graph here. And then on that graph, let's go to the menu, graph entry, and where do I go? I'm going to go to the sequence. Okay, that's great. So here, let's do the step size. I think the step size was given to be 0.2. So u1, my friend, and minus 1 plus 2, 0.2 is what I'm going to do, all right? So that's great. The initial term is a 0. So we go. And then press another one for the derivative of x. The dx over dt was given to be y. So for this one, I'm going to do u2 of previous x plus the step size was a 0.2. And I'm going to multiply by the dx over dt, which was given to be y for our substitution. So I'm going to put, u3 and minus 1. That's that. That's it. Right, that's the dy over dx, and then the initial value for the x was given to be 0. Okay, so I'm going to move on to the next one. And then, my friend, we're going to go to the next step here for the y value. Okay, so I'm going to go u3 and minus 1 plus 2. The step size was a 0.2 times. You're going to now multiply by the dy over dt, but remember, it was in homogeneous case, so it's got something of t that's going to be replaced by u1. No problem. So what we're going to do here is that on top of the h, I'm going to multiply by the dy over dt, which was a y minus x plus 1 minus t. So for that, I open the bracket. Y will be replaced by u3 and minus 1, the previous term, minus u2 of n minus 1 plus 1 minus t, so u1 of n minus 1 is going to be the answer. So that is great. And then the y was a dx over dt, and the initial condition for the dx over dt was a 2. So I'm going to put the 2 there. So I'm going to press enter. That is great. So that, my friend, is going to be the approximation. And then the question was asking us to find what? The question was asking us to find when the t was equal to 4. Right, so then we can find the estimation for the x when t is equal to 4 by opening up the table. Let's open up the table, my friend, no problem. So we're going to open up the table here, split screen, and go when the t is equal to 4. So if you scroll down, that's my t. And here my x is given as a negative 3.46. And then that's going to be my approximation. So at the t is equal to 4, the approximation is going to be negative 3.46 as a 3 significant figure. So x of 4 is going to be negative 3.46. So that, and my friend, is the approximation. So in homogeneous case, you cannot solve it analytically. So please make sure that we are willing to, use the Euler's method, right? So yes, there you go. If second order differential equation, no problem. It's homogeneous. Either you can solve this analytically, or the Euler's method, no problem, right? So for this one, what you can do here is they have given me the dy, so that's great. So dy over dt is gonna be the second derivative of x. That is great, right? So if I substitute in dx over dt, my friend, is gonna be negative 50 times dy over dt, right? So that's great, right? Is it? Give me 1 second. Dx over dt, sure it is. And then, I can put that as a negative 50y, no problem, right? So that's great. Why does it look so wrong? Yeah, dy over dt is a d second derivative, sure. And so, dx over dt is y, that is great. And dy over dt, oh yes, so sorry, so for that one I have to rearrange, right? So I will rearrange that to who of that one, sorry, where dx over dt was, what am I doing? Let me arrange that, okay? So here I got the second derivative of the x to be, dy over dt, so I'm going to put 50 times dy over dt plus dx over dt is equal to 0. But then the dx over dt was simply y, right? So that's great. So then, dy over dt will be negative 1 over 50 y is what we have. Okay, that's better. So then your the matrix is going to be given as a 0, 1, 0, negative 1 over 50 is what you have of the x and y. Okay, so that's great. That's lovely. So you can use it for either general solutions or the Euler's method. But the question says equation dy over dt is a separable and independent of x, and we can find the dy over dt. No problem. Yeah, that's right. So we can use a separation of variable here. So I'm going to pair the y with the y. So it's going to be 1 over y dy is equal to negative 1 over 50 dt. And then we're going to integrate. So that gives you ln y is equal to negative 1 over 50 t plus c. So if you exponentiate, my friend, you get the y is equal to e to the power of c times e to the power of negative 1 over 50 t. That is great. So you can let that to be just a constant coefficient. So that's fine. So that's going to be your general solution, isn't it? So that is great. Okay. And then, you can use that solution because we said that dx over dt is equal to y. So I'm going to let that, my friend, to be the y. So then, now I'm very happy because this is just typical, integral case where I can describe things in terms of the independent variable t. So all I got to do is just integrate. And if you use the, the integration by substitution, that will be negative 50a e to the power of negative 1 over 50t plus c. As simple as it can get, right? So then you can use your initial conditions to find the particular solutions, and that's absolutely fine, right? So for this one, yes, it was using more of the, separation of variable rather than the method that we were talking about, right? And then, yes, you should really be able to. So this will be the hard problem. Why is it a hard problem? Because they did not give you the differential equation. But if you can sort of translate the problem and put it into the following couple linear form, then you can use them for finding the general solution, because now I just have to work with the characteristics of negative 3 over 10 minus lambda, and then 1 over 20, right? And 3 over 10, negative 3 over 20 minus lambda, and then find the determinant, right? That is great. And if you let that to be 0, you can find the lambda. And if you use the quadratic formula, I want you to check yourself that you are able to come up with negative 9 plus minus square root of 33 over 40. But as you can see, if you see the real part is, negative, right? So, oh, sorry, my bad. It's not complex number. So this is going to be either the one with the positive inside and then the negative outside. I like to just to verify whether it's going to be, one of them can be positive or negative. So if I do that, and plus minus, and as you can see, 9 is a lot bigger than square root of 33. If you square them, you can clearly see that 9 is a lot bigger. So then if you subtract by 9, both of them are going to be negative. So then you can see the solution is going to be actually stable, right? Solution is actually going to be stable. So make sure that find the x and y. Sure, you can find them, right? So it's going to be a times e to the power of lambda 1t with the eigenvector that you can find using the algebra. So it's going to be given as a 1, 3 minus root 33 over 2 plus b e to the power of lambda 2 t 1, 3 plus root 33 over 2. And as you can see, yes, it's a conjugate. We talked about before that if you found the radical conjugate, a complex conjugate, is always going to be in pair for the eigenvalue and eigenvector. So if you found this, that one is gonna be free. Okay, then so then x is going. Then you can find the a and b using the initial conditions of such values, right? Then you can find the x and t respectively. And then they didn't ask you about the phase portrait, but you can clearly see because those two eigenvalues are negative, that is going to be spiral. It's going to be stable solutions. Okay. So yeah, that's sort of quickly just summarize on the AI. It's really the last minute, right? I'm so sorry that I didn't make this video in advance, but at least I did it, okay? So, this is just to briefly check your skills. Obviously, it does not go over all the hard questions or detailed question, mixed problem for paper 2 or 3, but it's briefly to check whether you remember, right? Not only the skills and also the popular questions to accompany with that skills. So please, use it as just a brief last minute checkup, and then make sure you try to, solve them as efficiently as possible. Do not rely too much on the calculator. Do not rely too much on the booklet. If we can be simplifiable, please do by hands. It's much quicker. For the topic 5 calculus, most of the problem were skipped because it's very similar to the AA calculus. So please have a look at them, and then we can continue more next time. So that's pretty much it for me today. Good luck for the exam tomorrow. Ciao.